with an aging population. Tech roles can often be in environments expecting 996 working, 9 a.m. to 9 p.m., 6 days a week, 996. Highly competitive environments that older mid-career switchers will not always be able to do or want to do. That question is from Jeremy. Thanks for that question, Jeremy.
Yeah, thanks for that. I just did a webinar on Monday and I had the same question asked. One of the big things that we do and we believe in Generation is employer education. I think employer bias is real and we, just call it out, acknowledge. And then what we need to do is really to have conversations. And the employer partners that we have with us are enlightened enough to understand that there is a need for diversity and inclusivity. And definitely age should not be a barrier. We do see how, in terms of tech, there sometimes could be a steep learning curve, but we also have brought the attention to the employers that you have people who have these years of experience, perhaps in finance, perhaps in marketing, perhaps in communication, or even engineering. And they will be able to bring all those past work experience into the new role. And it's up to, I think, the employers and us to have further conversations on what are the support systems that are needed to make sure that we set up enablers. So again, it's to make sure that people are set up for success.
Great, thank you so much. We also have a question from Nadira. So she says, we talked about those who graduated from 2019, 2020, they can't apply for our SGUP and SGUS programs, but they're encouraged to go for the traineeship program. So she's asking, what kind of traineeships would be good? I'm a freshie who works as a UI UX designer. I've thought of narrowing down my skills and upgrade my skills in a tech career. Anyone has any inputs for this? I believe we're not specifically covering the traineeships program here. I don't think, does TP has traineeship programs? I'm not sure. I don't think so, right?
No, we don't.
No. Yeah. So I did a quick Google search just now, and SSG, Skills Future Singapore, has a website just for the traineeships, and there are links to jobs that offer these traineeships. So I'd advise you to go there and take a look, or otherwise get in touch with SSG for the traineeship programs. Thank you for that question. Question for the next question, number 4. Generation Singapore and TP Poly in Budget 2021 highlights. Government said that it will shorten all SGUS training to ideally 6 months and below from April 2021. Does this affect your 6 SGUP CT from the June intakes?
Maybe let me take this question. So the answer to this question is no. This will not impact existing programs. It will only impact new programs introduced from April 2021 onwards.
Okay, very clear. Thank you. Okay, Janice Liu asked, no impact on existing programs, only the ones. Oh, somebody replied already, right? Okay, that was Janice Liu. Okay. Is the program for Indians as in those not in Singapore? I'm afraid the answer is no. These programs that we're talking about today actually apply only for Singapore citizens and Singapore permanent residents. Okay, so thank you. These are very generous programs launched by the Singapore government, well, not launched, but supported by the Singapore government, because they are training allowances of $1,500 for the SGUP CT programs and $1,200 for the SGUS programs that we talked about. And these courses are very highly subsidized by the government also. So Singaporeans only pay a fraction of the true cost of the program. And additionally, the fraction that the Singaporeans pay can actually be paid using Skills Future Credit, which is a system that that the government has given to Singapore citizens, and it's like a cash incentive to pay for training programs, for upskilling. All right, so Hui-Shan, missed the slide just now. Did you mention that the course is 3 months and after we will be placed in a company for on-site training for 6 months? That question is from Lynn.
Yep, that's right, Lynn. So it's a 3 months full day training program, and after which you will be placed for a 6 months apprenticeship with one of our employer host companies. And the slide that showed you some of the employees that we have on board include Tiger, NTT Data, as well as ComfortDelGro and Singapore Airlines.
Great, thank you. That's the last question that I have in the shared notes, but I'd like to ask a question for Hui-Shan of Generation. You know, as part of the qualification process or the process where a potential student goes in to answer the questionnaire, right? There is a quiz that they have to take, some sort of an assessment, online assessment they have to take from a third party. Is this chargeable or is it free?
It's free. So yeah, it's a very basic Python course on Udacity that is free. In fact, any one of you here, if you do want to, you know, just learn a little bit about Python, you can actually go. And then the other one on Code Academy is also free.
Okay, so you know, no hidden catches here. Everything is is all taken care of. Huh? Okay, very good, very good. If we have attended other SGUS trainings before, are we allowed to participate? Question from Lynn. Hui-Shan from TP, do you want to take this one? If we have attended other SGUS trainings before, are we allowed to participate?
So I think that Lynn is probably asking whether is she able to participate in another either SGUS or SGUP program. If Singaporean or PR can only attend one. Yeah.
Okay, maybe I want to clarify that a bit also. Yeah, the can only attend one of these courses because these programs are super highly subsidized by the Singapore government, and therefore, you know, to have equity, to spread the love, so to speak, to more people, everyone gets basically one bite of that cherry. Yeah? Okay. Is it possible to find out which partner companies participate that focus on open source software? Example, is there, there is Red Hat in Singapore. Not so sure who can take this one. Is it possible to find out which partner companies participate that focus on open source software? Example, is there a Red Hat in Singapore? Anyone has any idea on this?
I don't know if the question is specific to the Get Ready SG programs with our existing employer host companies. What we have checked when we have, you know, asked them in terms of the things that they'll need, there is really a variety. So whether it's open source in your particular case here, or something that's very specific to, you know, Spring Boot versus what's the other one that people have been asking for? There was something else I can't remember now. Yeah. So these are things that we have listened to them and we tried to build into the program. But in general, what we've also heard is, and I don't know if this answers your question, the companies are not so particular when it comes to any kind of software. Basically, they really just are looking for things like intrinsically, are you adaptable? Are you willing to learn? Do you have, you know, as we mentioned earlier, growth mindset? So those are the things that we've been hearing from most of the companies.
Great. Thank you so much. I see Michael has come back online. I think he's chasing us because our time is almost up, or it's really up already. I think if you check in the shared notes, Harish from Red Hat, thank you for joining us. He actually replied that they are in Singapore. All right. Yeah, I need to show 2 more very quick slides. We have to wrap this up now. Thank you very much for your questions. But Skills Future Singapore has skills and training advisory services. So please do check them out. We'll leave these slides up for a little while so you can take a snapshot for the QR code if you want to get more information. And one more last slide. Yes, please need to get your feedback and survey. So please help us with that survey. The top one in the slide, share your feedback with us. And for more information on My Skills Future, there's the QR code as well. We will post the feedback URL in the public chat room. Right, thank you very much. Michael, you wanted to end the session?
Yeah, thank you to all of our presenters. We've learned much from you about some very exciting programs. I hope that people will be able to either check these out for themselves and also to share this with people that they know as well, because it's a very unique opportunity. And I mentioned in the chat, this is really a model for other countries, other places to follow as well. We hope to see much more of this happening. Clearly, Generation has been involved in multiple places now, and we that kind of thing growing for people all over the world. And we're very excited that Singapore is doing it. We have a break now coming up before our next session, which is at 12 noon back here. So we're going to leave this up. Definitely encourage everyone to check out that survey. We'll post a direct link as well in the chat room. Would really love to get your feedback and how you learned about these topics. But for now, we're going to go ahead and take a break. Again, please join me in thanking virtually with applause presenters, and we are very grateful for the work that they're doing. So thank you. See you all back in just about 1 hour here in the chat room. Take care, everyone.
Thank you, everybody. And bye-bye from sunny Singapore.
Thank you. Bye-bye.
Thank you. Bye.
Bye, everyone.
Hi, everyone. We'll be getting started in just about 2 minutes. So a quick chance for a minute water or to step away before our speaker begins. So we'll be back here in 2 minutes.
Hello. Hello.
Hi there. Audio is fine. Video is fine. I think we'll be ready. Hello, everyone. We'll get started in about 30 seconds. We'll just wait for people to join us on the live stream on YouTube. All right. Well, welcome back from break. And for those of you who are just joining us, welcome to day 7 of the FOSSASIA Summit 2021. Our next speaker of the day gives us really a taste of what's to come for one of our themes today, which is AI. And they bring what I think may be the most creative name of all of our sessions this year, artificial intelligence, more like artificial stupidity. But seriously, it's very valuable to understand some of the limitations of even the most cutting edge technology. And as technologists ourselves, we can learn a lot from failure and use those experiences as our tools. So here to guide us through what I'm calling a festive failure and help us learn how to do better in the future is Eiko Klesterman, who's a senior software engineer based in Singapore, who's worked around the world as an AI consultant and is now focused on building data platforms. Now remember that you can ask questions for our speakers, any of our speakers during their talks, by going to the Shared Notes tab up on the upper left side, and we'll do our best to make time for them at the end, the schedule permitting. So without further delay, please join me virtually in welcoming Eiko Klesterman. Over to you. And
thank
there
you.
you go.
Thank you very much for that introduction. Yeah, the title is indeed a little bit clickbaity. And it's good to be back at the FOSSASIA Summit. Right, so you mentioned it already. I want to talk a little bit about artificial intelligence or artificial stupidity. And even though the title is very clickbaity, there also is a little bit of truth behind that, and I'll get into what exactly that means later in the talk. And I mean, what I want to do basically today is I want to tell you a couple of stories. Some stories about data, some about AI, about machine learning. And some of these stories are success stories. They are great examples of how powerful AI can be and how useful and amazing features it can bring us and has brought us. But some of them are also failures, and some of them are pretty big and bad failures and impactful failures. And especially into those, I would like to dig a little bit deeper and try to see what went wrong there and why did that go wrong, and what we can do in the future to prevent that. And when I say I want to tell you a couple of stories, let's start with at least in my opinion, one of the greatest storytellers that we had, Douglas Adams, and I'm sure many of you have read this book or at least heard of it, the Hitchhiker's Guide to the Galaxy. It has brought us pretty famous memes that 42 is the answer to the question of life, the universe, and everything, and that we should not panic. But it has also brought us one more thing that's not quite as popular, and that is the Babel fish. And this Babel fish is obviously it's fictitious. Douglas Adams, obviously it's a little bit crazy because that's what Douglas Adams is writing about. And this fish is a tiny fish somewhere in the universe. And you can take this tiny yellow fish and you can put that in your ear. And what it then does is this fish picks up the brain waves of the organisms around you. And when these organisms speak, this Babel fish picks up that and translates it in your ear into a language that you do understand, any language of the universe. So it's basically, I mean, it's absolutely crazy, right? This fish does not exist. I mean, as far as we know, it does not exist. It is a fictitious, crazy idea by Douglas Adams. But let me show you something that does exist. And I tried this demo a couple of minutes ago. The website seems to be broken a little bit, but let me just try it. Yes, it's not working. What I would have done was I would have spoken in German, and it would have picked up my voice. And what I would have said is, Hallo und herzlich willkommen zu meinem Vortrag über künstliche Intelligenz. And what we can see is actually, like on my watch, it still works. What we can see is that my voice gets picked up. What I say is being picked up and is then being translated from this language, which was German, into English, because I selected English. I could translate it into other languages as well. If I were to click this button, it would actually read out this text in English. So this Babel fish, which does translation in my ear, this is, I mean, I don't put it in my ear, and it's not quite there, but this instant translation from one language spoken into another language spoken again is already there. And this is powered on multiple levels by machine learning, by artificial intelligence. And it is a functionality and a feature that I mean, about a decade ago was unimaginable. And that is something that, I mean, I use it quite often, and I'm sure other people also value this feature quite a bit. But then again, I mean, I talked about the Babel fish, and it's not quite there. But Google is not only building this translation service, and other translation services also exist. Google also has these Pixel earbuds, and you do put them in your ear, and they do translate, live translate, and speak into your ear. So it's almost, you still need a phone, but it's almost as this crazy idea that Douglas Adams has described in his book has come to reality in powered by machine learning. And I think that is one of those great examples where machine learning does bring a lot of value to us, to society, if you will. But that's not even, like, I think there are even better examples. And machine learning models for a couple of years now have been proven to outperform trained professional doctors in identifying cancer cells based on image data. So it started with breast cancer cells a couple of years ago. So basically, you look at the image data of cells, and machine learning models are more accurate in predicting whether that shows a cancer cell or not than professional doctors whose job is it to do exactly that. And it started a couple of years ago with breast cancer. I think Google 2 years ago also achieved better results, more accurate results in humans for lung cancer. And that is a life-changing achievement, a life-changing feature that we get from machine learning, which just shows how powerful and useful if it is being put to good use, machine learning can be. But obviously there's a but. Given the talk title, there are obviously failures, and I mentioned it before. And if you look here to the right side, there's a tweet from this Indigo, which is an Indian airline, Indigo passenger, and he's thanking Indigo for sending his baggage to Hyderabad and flying him to Kolkata. Obviously, it's a sarcastic tone. And I can only assume that the Twitter reply, which reads "glad to hear that," did not pick up on the sarcastic tone. And I would assume there's some kind of chatbot handling that, and a similar situation in the screenshot in the middle where someone is talking to PayPal and saying, "Hey, I got scammed." And the response is great. And on the very left, there's another example where I failed. So there are a couple of funny failures, if you will. My favorite failure of, and it's weird to say that, of applied machine learning is this. And if you speak Mandarin, you might already know what's going on. For everyone else, I give a little bit of background information. There are cities in China that have cameras installed over zebra crossings. And basically, these cameras, there's some object recognition. These cameras look or watch out for a person jaywalking, crossing the street while having a red light. And that is what you can see here. They see a person crossing at a red light, and then there's a big screen, and they display, hey, this person just crossed the street at red light. This person just jaywalked. Now, if you look closely at this picture, you can see that is not really what happened, right? There was a red light, and there's a zebra crossing, but the person that is being shown here is actually advertisement printed on a bus, because obviously the bus had a green light, right? And so the object recognition, the camera picked up, oh, look, there's a person, I can see a person. I have to now shame this person on this big screen saying, hey, we saw you jaywalking. In fact, this person is the CEO of this company, and they're advertising with her on the bus. She was in a different city at the time where this happened, and she got a notification on her phone saying, hey, we just saw you jaywalking, while being in a different city. And obviously that didn't happen. It was the printed picture on the bus. And I think in this case, that is basically where it ended. In other cases, other cities have gone a step further. They're not just have object recognition, have face recognition, which was also the case here, and then have have the way to identify the person and contact that person. But they also have made the link to their bank account. And through the bank account, they have made the link to the WeChat Pay account, which is, I guess, the most prevalent mobile payment solution in China mainland. And what happens is that in some cities, if they see you, or they believe they see you jaywalking, they identify you, and they, within seconds, deduct the fee for jaywalking from your WeChat Pay account. So that is, I mean, from a technical perspective, and I'm a little bit nerdy there, I think that it's a very interesting technological challenge. There are so many different systems working together. It's very complex, and that is kind of, it's kind of interesting. But on a different level, on a less technical, on a more of an ethical level, on a moral level maybe, and especially where we see that it can fail, that is that might be not as cool as it looks on the technical side. Right, and I've mentioned artificial intelligence and machine learning a couple of times now. I think it would be good to have a common understanding of what I mean with by those words, especially since a lot of them have been hyped quite a bit in the recent years. And let me start with artificial intelligence, which is, and I'm using the definition here of the Oxford dictionaries, which is also, if you type in define artificial intelligence, it also uses this particular definition. And that definition reads that artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence. The thing to note here is that this is not talking about a technical implementation. It is the concept of a computer does something where we previously believed only humans can do and you need human intelligence. And I'll give you an example to make it very clear. A chess program, like a computer that you can play chess against. Usually, if you play against a person, chess, you would assume that person has somewhat human intelligence, especially if it beats you in chess, which most of the chess programs that I've played against do. But now, if we look at the implementation or think of a possible implementation of this chess program, it could be relatively straightforward. You look at the chessboard, look at where all the pieces are, the position of the pieces, and then look at the possible moves that you can make. And then the follow-up moves and the subsequent follow-up moves. And if you just brute force all the possible moves that you can do over the next over the time, then you would then just pick the one set of moves that leads to the outcome that you want, which is winning. But brute forcing and having maybe a couple of loops and if else, isn't that crazy from a software development point of view? Yet it would fit this artificial intelligence definition. Where it does become kind of cool and crazy is when it comes to machine learning, where the algorithm that actually gets used to solve a problem, to make some kind of decision at the end, to identify something, is actually not written by a software engineer. The algorithm is learned over time by a certain set of data. There's a structure, and if you feed in this data, then the algorithm learns to decide in that way. If you feed in different data, the outcome will be different. So it's not a fixed algorithm, and it depends on the data that you feed in to train this machine learning model. So this is where it becomes quite different from the classical software engineering approach. And then there's neural networks, which is a subset of machine learning, which is basically a structure of this model that tries to emulate or is inspired by a human brain or a biological brain, actually. And then there's deep learning, which more or less is just a neural network with a lot of layers. And we'll get to that a little bit later. Right. And that being said, you can see these layers here, and this is supposed to be a deep neural network. It's actually a very simple one. It's relatively shallow, where you have 3 layers and 1, 2, 3, 4, what is it, like 8, 10 nodes in each layer, and you can see that they're all connected. I think this is actually fully connected. So this is not like real life deep neural networks have 10, 50, 100, sometimes more than 100 layers actually, not just these 3 hidden layers, and more than thousands of nodes per layer. So this is a very small example. But even in this example, you can already see there are so many connections between all of these neurons, between all of these nodes, that it's basically impossible to figure out what the data flow was for, and that resulted in a particular output. Now, if it gets even bigger, 10 times, 100,000 times bigger than that, it is virtually impossible to understand why this neural network made this particular decision, or why this input in this machine learning model created that particular output. And that is one of the 2 issues that I want to talk about today, and that we have seen before. The complexity is so high that the machine learning model can be only described as a black box. We do not understand what is going on, and that is one of the 2 issues, that this black box behavior of machine learning models makes it more or less unpredictable. Right, but there's another issue, and let me give you an example here for this other issue that I want to talk about. And this is another story, right? It was 2011. The city of Boston had a problem. They had potholes across the city. And it was 2011. They did what everyone did in 2011. They built an app. This app was called Street Bump. And how this app worked was, and I must say, it's actually, I mean, the idea is quite smart. This app works in the way that when you drive around in your car, you get your phone out, you open the app, and then the app is running, and you put it on the passenger seat, and you drive around. And whenever there would be a pothole, the phone would pick up the vibration through the accelerometer, and then use the GPS coordinates to figure out where this potential pothole is, and will then send this information to the servers of the city of Boston, who then can go and fix that pothole. Now they did that, and they released that, and after some time they realized that the potholes reported, or the potential potholes that got reported, were mostly in high cost of living areas, only in areas where rich people were living in Boston, which doesn't, I mean, if you think about it, doesn't really make sense, right? Why would only in those areas be the potholes? If anything, you could argue that depends on how the city is managed, it would potentially be in the other areas even more. At least it would be somewhat more evenly distributed. And the reason why this data was so off was that in 2011, not everyone had a smartphone. They were relatively new, especially those where you could install apps from the App Store, and they were relatively expensive. And now the thing is that if they are expensive, only rich people can afford them, and only rich people then install this app. And that's why the data showed potholes only in the high cost of living areas. Now, they did solve this problem, and I have to admit again, equally smart. They solved this problem by installing the app on phones and putting those phones into public vehicles, garbage trucks and public buses that would cover the whole city grid. And that's why then they got more representative data that covered the whole city. The thing to notice here is we've seen previously the machine learning black box behavior that makes it unpredictable. In this example, there was no machine learning. The issue here was basically only that the data was skewed. The data was not representative of the real world. The data was biased, and that led to this basically only being able to misinterpret the data. If you see, oh look, there's only potholes in the rich parts of town. Right, and let me show you again an example. And you might remember this example actually from a couple of years ago. It got famous some time ago. I've selected here to be translated from English into Malay, and the reason why it was Malay is because Malay does not have gendered pronouns, and you might remember these examples from a couple of years ago. What I typed here was, she is a doctor and he is a nurse. And in English, it's relatively simple. There's a gender attached to this pronoun. It's a female. The female is the doctor, and the male here is the nurse. If we look at the Malay translation, I'm not going to pronounce it because I would only embarrass myself. But you can see that the pronoun is the same because there's no gender information. It's the same pronoun. And what's interesting now, if we take these two Malay sentences and translate them back into English by clicking this button, you can see that all of a sudden our female doctor became male and our nurse became female. We typed it, she was a doctor, it got translated loose, and it lost the gender information. And now we'll translate it back. Google translates it as he is a doctor and she is a nurse. And there are countless examples where this is happening. And I've used the Google Translate previously, literally used this very example as a positive example to show how powerful it is. The thing here is that, and the machine learning part works in a way as expected. Because again, the issue here is the data that was used to train the machine learning model had this bias. There's this social bias that was inherent in the data that was used to train this machine learning model. And now how do you train these translation models? You basically let them read a lot of text in one language and in another language. And then over time, the machine learning model picks up, okay, this part in English should be translated to this part in Malay. And that is what happened here. And historically speaking, the historical texts that were used most often translated this Malay sentence about being a doctor with he is a doctor. Because historically speaking, maybe that was the case. Maybe most of the doctors were male. I mean, nowadays we know that everyone can be a doctor, everyone can be a nurse. There's no need to make this differentiation. The thing is, the data was biased, got trained in that way, and it is replicating in that way. And there are countless examples where that is happening. There's, in fact, this got famous a couple of years ago because Turkish, same situation. There are gender-neutral pronouns. There are other languages that do the same, and it got popular. People called it out, hey, this is how it is in Turkish. And then Google manually added this extra feature, hey, this sentence can mean she and he. But that is obviously a manual effort that would need to be put in for all the languages that have gender-neutral pronouns. And Google has not done that. And as I mentioned, it is the historical or the social bias in the training data for the machine learning model is the real cause of this issue. Right, and I'm talking about AI failures, and it's hard not to talk about Microsoft Tay here. Some of you remember Microsoft Tay was this chatbot, this conversational interface that Microsoft developed, and they released it on Twitter, and basically people could tweet to it, and then it would tweet back, and over time Tay would learn how to have a reasonable conversation. Now people on the internet have figured out how this works. I have figured out that there's this training mechanism, and if you think about in general, if you want to teach something to speak like a human, to have a decent conversation, do you think Twitter conversations is a good way to teach that? Maybe not. And I guess that was also the learning here. Some of there were lots of trolls who found out, hey, I can just feed horrible ideas, horrible thoughts into this machine learning model, so that then Tay does in fact reproduce these horrible racist thoughts. There's one tweet that particularly stands out. Someone calls Tay a stupid machine, and Tay's reply is, I learn from you, and you are dumb too. And I think that is the crux of the issue here, that the Tay just repeats what it is being fed to, and the machine learning model just repeats the input. And if, as we have seen before, if there is a bias, a social bias introduced by humans, the machine learning, or in this case, I mean, forcefully by trolls, outcome is the same. The machine learning model will have the same bias and will repeat the same mistakes. And there's, I mean, now you could argue that, okay, there's Tay is a Twitter bot. I think it worked on other platforms as well. But it's a chat bot. It's not, I mean, we can now look back and laugh about it a little bit. But there are other systems where it is significantly more impactful. The Compass system is used by judges in courts to determine bail sentence and prison sentences. And this is a system that basically offenders, criminals, fill out some kind of form, some kind of questionnaire, like 200 something questions, and then the system predicts if this offender will re-offend after a prison sentence or whatnot. So the prediction is, hey, this person, based on the questionnaire, is likely to re-offend after the person gets released. Or the outcome is unlikely that this person reoffends again after release out of prison. And ProPublica analyzed this data. And what they found out was they basically differentiated between African Americans and white people who were the criminals. And what they found out that this system, and they are basically, the system can be wrong in two ways, right? False positive and false negative. And in this particular case, that means the system can say, hey, this person is likely to recommit, but then the person actually doesn't. Or the system predicts, hey, this person is likely not to recommit, but the person actually does. Right? So you can be wrong in two ways. And what they found out that in the first case, where they were labeled a higher risk, but then did not commit, that applied to 23% of the white offenders, but almost 45% of the African American offenders. And vice versa, in the same, like in the other case, where people being rated lower, but they actually do recommit. The white offenders is 47.7, almost 50%, and African Americans only 28. So there's a clear racial bias in the system that is more likely to falsely state an African American offender will reoffend, and more likely falsely claim the white offender will not reoffend. So clearly a racial bias. The questionnaire doesn't even ask about race. They're asking questions about where people, the neighborhood they're living, and some other questions about their parents, and their quasi-identifiers that then lead to this model to be able to identify and have this basically this racial bias. So that's pretty bad, and it gets potentially even worse. Like, autonomous driving is going to take over the world. Probably it's going to take over the streets in the next maybe decade, maybe 2 decades. I don't know how many decades, but it probably will at some point. And these machine learning models and these autonomous driving cars, basically a lot of them have cameras, and there's machine learning to identify what's going on the street. How does my car have to react? If there's a pedestrian walking across the street, I should probably brake or like drive around that pedestrian. And now there's a study that found out that these machine learning models that drive these autonomous driving cars have a higher failure rate when it comes to detecting pedestrians if they are dark-skinned. Identifying white-skinned pedestrians seem to be more successful than dark-skinned pedestrians. And that, if we scale this to 1 billion cars on the roads, this will eventually lead to people being killed, more likely because they are dark-skinned. And that is a bias that I mean, absolutely unacceptable, and I think everyone would agree. But that is the power of that we currently give or potentially give machine learning models. And again, the reason here is probably it was trained with less data of dark-skinned pedestrians, and the outcome is that it is worse at identifying dark-skinned pedestrians. Now, basically, how I remember my mom telling me I wanted something, and I say, it's my fault. My mom out, hey, your friend over a bridge, would you follow? Obviously, I wouldn't do that. With machine learning, that is not the case. The machine learning reacts in the way how it sees other data, and it got trained with other data. Right. So now you're saying, Aiko, you're telling us there's machine learning everywhere. There will be even more machine learning in the future, but it's failing horribly. The world is on fire. Are we all doomed? Luckily, we're not all doomed. Maybe, but not because of this. And the reason is that the industry is already moving what I think is in the right direction. Explainability is considered and should be considered the first-class model selection criteria. There are ways how you can understand the machine learning model better to have less of this black box behavior, and these models, that is value and should be considered an extra value in the choice of what machine learning model I should choose. For example, if you see here, there's this convolutional neural network on the right side and the bottom, you can see, okay, these different layers identify things. There's a way, it's called deconvolution, basically shows this layer identifies edges, and the next layer then identifies like some other combination of shapes, maybe a nose and then some other features. And there are ways to visualize how this black box behavior actually works. So making that more important should be our goal. Basically, we need to move away from the standard machine learning approach where I just feed data into a model and then have a prediction and that's it. We need to add interpretability and human inspection on this interpreted result, and then improve the model again with the data that the humans got out of these interpretable result. And that is where we need to move. And one way is very nice technology is Lime, which works in a way that you can see here in the middle. So basically, we have a picture of this tree frog, and we are relatively certain, like 0.54%, actually that this is a tree frog. And what Lime does is it removes certain information from this input data and compares the result. So basically, hey, I have this machine learning model. If I give this picture, it tells me tree frog. What if I remove certain parts? If it is still telling me tree frog, that means that the data I removed was not relevant for the identification of it being a tree frog. And the same way around, if I remove some data and it is not telling me it's a tree frog anymore, then the data that I removed was relevant for that model. And you can see that here in the middle and in the bottom right. Basically, we figure out this was the relevant data, and by doing so, we understand, okay, that was the relevant input. This is how the machine learning model made this decision and made this prediction at the end. It's 2021. I should not need to put up this slide anymore, but we need more diversity, right, in our teams in terms of software engineering, machine learning, ML engineering, or QA. If you think about the autonomous driving car example, I would argue if the team would have been more diverse, it would have potentially caught earlier in the process that this machine learning model is worse at prediction identifying dark skin pedestrians. There are a couple of other examples where that applies. It's just one of the many examples of how a more diverse team is beneficial to the product that you're building. Then there's another thing that I would recommend, which is the data ethics canvas, which gets released by the Open Data Institute, and is basically a set of questions. If you work with a data-centric, if you're building a data-centric solution or an application, these are the questions that you should ask yourself before deciding on what you do. Like, who is this data shared with? What are the limitations, biases in my data sources? And then there's this very nice tool that got released by Google Facets, which is simply a visualization of a data set. You take your whole data set, you throw it in, and by visualizing it, you can relatively quickly identify, look, I have 80% of my users are male, or of this data set are male, and only 20. So clearly there's an underrepresentation of other genders. And that is an easy way to see how whether certain parts of your data set are underrepresented or how biased it is in a way. All right. That being said, I hope I could give you some insights on how machine learning models fail sometimes nowadays, and how these two big problems that I see, which is that the black box behavior is a little bit unpredictable, as well as the fact that data is often biased, has a social bias in it, and that there are ways how that can be approached, and hoping to look forward in a world where these are addressed and fixed. If you have any questions, you can just ask them now, or you can also, if you Google my name, you can contact me. It's a relatively unique name. Thank you very much for your attention.
Thank you, Eiko. Very insightful presentation. A lot to learn, a lot to think about, a lot of ethical questions to think about and deal with. We from the audience, and I would want to remind people we have a few more minutes. If you'd like to add any further questions, please just go in and feel free to edit the shared notes page on the left side of your screen. We had one participant asking if there are any AI subtitles available. If you're aware of anyone doing, AI-based transcription work or subtitling, translation, things along those lines. Maybe I think the person has left, but I presume for something like a real-time meeting like we're in now. Have you seen any of that been developed?
I mean, I know that they exist. I should have probably come to think about it. I should have probably added that to my own talk here. I know they exist. I think they would suffer the same bias that this Google Translate and other Translate, because they basically all use the same methodology of training this data set by using text, and all of these texts have the historical social bias. You could, as Google did with the Turkish example, you could put extra effort in to make it very clear, figure out what those words are and that they might have multiple meanings, and then make it clear, hey, this can mean multiple things. I am not aware that there's any live translation that does that for all the languages as of now.
At the rate things are going, I would imagine we may see that sooner than later, though. I have maybe a related question, and that's whether or not you've heard of any, maybe the tech giants out there, Amazon, Google, Apple, or others. Do you know if they're actually using that human feedback loop in any of their AI or ML models that they're building for their products? Or is that still something that's kind of on the horizon before that starts to be used?
So I don't know for sure that they are doing that, but I would bet I'm relatively certain they are. This is like Lime, the tree frog example that got released like 3-4 years ago. It is relatively, there is benefit in doing that, right? Like having this human feedback is not just makes it more ethical, more moral, like more accurate. It also increases the quality, right? If your machine learning model is more often wrong because of this bias, then people also don't like using it. Not just on an ethical, questionable level, but also on a feature that if my translation is often wrong, I use a different service. So I think there is luckily a motivation other than being morally correct for these big giants. To use that, and I think I would argue that a lot of a lot of the models are being used and trained in that way. I mean, there is a different question whether the ethical side is the driver of that, and it probably potentially is not, especially if you look at recent news when it comes to ethics and Google and AI and people getting fired over what they think. So I think there's still money is the biggest driver, but luckily, coincidentally, it aligns in this case to make it a better product. So I guess.
And I think the mitigating factor, if you will, is that people like us here at these conferences are having these conversations and awareness and getting people to think about that. So I'll close with one last question before we take a break into our next session. But and this is more of an opinion for you. But Carrie asked the question: do you think that science should stop using AI totally until we've resolved all of the problems that we've talked about today? Do we need to slow down, back up, or pause? Or should we keep kind of pressing ahead and doing what we're doing now and trying to, fix the car while it's driving down the street?
Excellent question. I think that science should probably not stop doing that. I mean, there's because all these big organizations that want to get all your data are also not stopping. And if they develop things in an unethical way before science can do in an ethical way, then might not be the ideal outcome. I think it comes down to understanding the limitations, knowing that there are ethical challenges in the world of science, and addressing that, and then taking that into the public sector or the private sector, and actually apply that there as well.
Very good. Well, Eiko, thank you so much for your presentation. I hope it was informative and inspirational to all of you as you think about how the AI world that you come across every day and things that you may build in the future. Feel free, folks, to go to the session page, get more information about the speaker, and get in touch if you'd like to have more conversations. But for right now, we have a short break, and coming up at the top of the hour, invite everyone to very important panel discussing diversity and inclusion in tech, which Eiko spoke about, and we'll start thinking about ways we can make some improvements there with a very talented set of panelists, again, coming up at 1 o'clock p.m. Singapore time. So we look forward to seeing you back then. For now, take a short break, get some exercise, get up and move around, and we'll see you back here in about 15 minutes or so. Take care, everyone. Thanks for joining us. Bye-bye.
Hello, can you all hear me? Testing.
Hello, Sherry. We can hear you.
Sherry, could you say something? Because just now I couldn't hear you. So you're muted.
Hey, Dr. Kirita, can you hear me?
Yes, I can hear you now. Perfect.
Okay, cool. Hey, can you see me and hear me all right?
Yes, we can, Sherry.
Great. Yes.
Hi, Ms. Sri. I'm the moderator. I'm Marcus. I'm the moderator for the session. So basically, just like I'll provide like tech support and like all that in the chat, basically.
Thank you, Marcus.
Yeah. So I'll just so like before we start, I'll just do like a quick intro for you. Okay.
Sounds good.
Okay.
You hear me and see me okay right now?
Yeah. Everything seems to be working fine.
Okay.
We just wait for like 1 p.m. I guess.
Sure, no issue.
Okay, I think we just get started now. Okay, so hi everyone, welcome to FOSSASIA Summit 2021. This is the panel for diversity and inclusion in tech. So this panel, we have invited a range of really important speakers today, and it will actually be hosted by Ms. Sherry Ng, who is the General Manager for Public Sector Asia Pacific, Microsoft. Sherry's career spans a 22-year journey in the high technology environment across banking and finance, telecommunications, government, and oil and gas industry across various management and global leadership capacities involved largely in business and organizational transformation. So, Ms. Sherry Ng, you may take it from here.
Thank you very much. Good afternoon, everybody. What a super honor for me to be here at FOSSASIA. I'm actually really excited, very, very inspired that, Asia's largest open tech developer community is started by a young lady. I admire her passion, how persistent it is for her to have that kind of vision to drive, to where this community is today. So with that, I just want to start by saying kudos, to brave women. And also thank you, FOSSASIA, for broaching a very important topic today on diversity and inclusion in tech. As we all know, the start of this decade has a tremendous, shift in what's happening in the world, and we see a convergence of three very major trends. Number one, the digital acceleration has, exponentially grown in all the markets around the world in the midst of a pandemic. We see job disruptions in the markets, whether it's remote or physically. We see a range of, calls for all of us to be moving with a greater voice in inclusivity, equity, as well as social justice. And more than ever, in the midst of such sweeping change, you and I and the organization has an opportunity to really make a difference here. Today, I'm super privileged to be joined by a distinguished panel of leaders women whom I call captains of their respective field, and more importantly, they are truly the change makers that inspire all of us to do more. We're going to have a conversation around diversity and inclusion in tech. We're going to touch on some very personal stories, and more importantly, look at the biases, the discrimination, or the barriers we see in the market today, in the world today, and how we can all collectively push ourselves to think outside of the box and draw on all the empirical evidence that exists today to help us identify, promising areas where we can look at investment, where we can direct our leadership voices and focus, and more importantly, what experiment we all can conduct so that this will all serve as a remarkable engine of change. So with that, let me welcome my panelist, Ms. Dong Bích Hang. She's an anthropologist with an experience in international development. In her current capacity as Chief of Culture at the UNESCO, she's directly responsible for UNESCO's program with overall objective to safeguard the region's cultural heritage and foster its creativity. Throughout her career, she's expressed tremendous commitment to gender equality, cultural diversity, human rights, and social development. And recently, she's actually explored the interconnections between culture, creativity, and how that intersects with all that is going on in the digital world. So welcome, Han. Next on the panelist is Dr. Kirutika. She's a research scientist in the field of cognitive systems, learning and memory. Kirutika leads the education team at Science Center Singapore and make her dream and her vision, and she's dedicated her passion to really make STEM accessible to the public, especially to the students, and very importantly to the educators community. So welcome, Dr. Kirutika. Last but not least, the reason why we're all here today at FOSSASIA, Ms. Hong is the reason why we're all here, right? So she's the founder of FOSSASIA, chairs the annual FOSSASIA Summit, organized this amazing open tech summit in countries like Vietnam, Indonesia, China, Sri Lanka, all the way through to Germany. She's also a board member of the Open Source Business Alliance in Europe and served as a VP of Open Source Initiative. Hong believes that free and open source is not just a way to exchange code freely, but more importantly, a collaboration model that will set example of how people around the world can come together freely to collaborate and solve world's most challenging issues. With that, welcome Hong. See, friends, maybe I'll start with our panel discussion with a speed round. The recent events has been a very big reminder for all of us that persistent inequalities continue to permeate our society and economies. So as we seek more responsibility from companies and individuals in the whole issue of diversity, equality, I'd like to start with my first question to the panelists. What are your most passionate top of mind topic when it comes to diversity and inclusion? Can we start with maybe Ms. Han?
Yes, I mean, for me, because coming from the culture sector, so inclusion of a diverse range of sector into the tech scene is a very, very interesting topic to me. And this is something that we have begun to explore here at UNESCO.
That's very, very exciting. Thank you, Ms. Han. Dr. Kirutika?
So I think when we talk about diversity, the most important thing is to make sure that different people are represented during the development, right from the beginning. We always hear of stories where there are products that are designed and then they misrepresent or misalign certain kinds of audiences, and one of the reasons why that happens is because the stakeholders, the diversity is not there right from the beginning. So having the diverse viewpoints on the table enables us to ensure that the wider population is represented when something goes out.
I think that's an amazing, very, very important topic when it comes to when we're looking at, especially in the world of technology, where we hope to use technology to pretty much bring in the equality. the design phase and the product development phase is very, very critical. That's where, you've dedicated your passion to helping STEM in education, and that's where we want to kickstart from development phase, to your point. So thank you, Doctor. How about Hong?
Hi, Sherry. May I say that I'm really glad to be here, and it's great to see you all on the panel. Yes, I totally agree with Han and Kirutika. So diversity and inclusion is very important, not only in the tech sector, but everywhere in our society, right? In order to, whatever we do in the tech industry, we want to build a product, we want to get it into the user hand, and we need to have the user viewpoints represented in the development phase. And without the diversity and inclusion in the way we work, in the way we develop, it's difficult to say that we can represent our user, we can understand the whole journey and the opinion of the user. So definitely, to emphasize again, it's really important that we ensure an inclusive environment in the tech industry. Thank you.
Very nice, which is why you've been so passionate about championing open platform, open collaborations. So thank you. For us at Microsoft, I would say for me right now, there is so much we have to do in the arena of diversity and inclusion. But currently for us, one of our top of mind is how do we address the gender inequality? How do we also look at the space of people with disability? So if you look at the UN Sustainable Goal, for example, it talks about how gender equality is not only a fundamental human right, but more importantly, a very, very necessary foundation if we are all looking to enjoy a peaceful, prosperous, and sustainable, world. But yet in the arena of, of what we're seeing today, especially post-COVID, right? We're seeing how women were among the most hardest hit when it comes to post-COVID impact. And you're looking at a rate where the estimated job loss rate for women is twice higher than that compared to the males. And at the same time, we talk about, Dr. Kirutika and Hong, you talk about how digital technologies today are going to be that backbone of the economies for us to build a resilient future. But if you look at World Economic Report, on gender report 2020, it is a very, very stark realization that how women is actually underrepresented in emerging tech roles. We have very, glaring statistics like 12%, only 12% are represented in cloud computing when the world is moving into cloud. And Hong, you talk about how without the right representation, you're not going to get the design phase and development phase right. In the same way, we know the involvement of data and AI, but there's only 26% of women representation in that field. So I would say, from that perspective, us at Microsoft are looking at how do we actually really bring in place the right programs and foundation pretty much for women in the tech world. I hold that for a second. Let me also maybe quickly share something that we're super passionate about. The WHO estimated that about 15% of the world population, that's close to about 1 billion people, live with some form of a disability. And in Asia Pacific, we're looking at 1 in 6 people has faced some types of challenges or barriers to enable them to be fully participant in the economic arena in society. With this start number, we are passionate about what can we do, really to take inclusion for the people with disability. And it is very, very telling that, by excluding this population of people from our job, workforce, we're actually causing an impact of 7% to GDP around our countries. So maybe just a quick start to kickstart the discussion. I just want to focus a little bit on women as well as disability when it comes to inclusion. And start by sharing a little bit of what we are doing at Microsoft. At Microsoft, it is really our mantra to empower every person, every organization to achieve more. We specifically look at, how do we, to Dr. Kirikita's point, STEM is an area where you start grooming, pretty much talent in this arena. We're very, very intentional about how do we inspire young girls to, one, take up those, subjects in their school, in education, and then create programs where we can help them give them opportunities and environments for mentorship and sponsorship. So we have this program for what we call Digital Girls, basically going to schools and helping children, equip them with the systems as well as the devices and the coaching to be able to learn and start coding from young. This is one example. The other one I'll talk a little bit later is women in AI. We see we're very, very passionate. We talk about how only 26% of the populations are actually represented by women, but this is going to perpetuate in the product development cycle if we do not increase the representation. So we'll be launching a program called Women in AI, really providing the ability to skill and learn, and as well as take up certification in AI and provide that internship and mentorship to bring women actively into the working arena from that perspective. In the space of disability inclusion, we're looking at how do we drive inclusive hiring programs. And this may sound like, hey, it's part of the hiring program, but I urge all organizations out there to be considerate and to consider approach in inclusive hiring to ensure that you create an environment and a platform where people with disability can have equal, equitable opportunities in participating in this arena. And just a point of interest, recently we have this program called neurodiversity. This looks at hiring people with neurodiversity challenges, and basically, to demonstrate that we in the workplace can intentionally provide the right environment, safe environment to leverage and utilize diverse skill sets. I think in the picture you will see that Philip Jarvis is an engineer that recently landed his dream jobs with HoloLens. So he is experimenting and working with HoloLens despite his disability, and equally effective in participating in this. So those are two, arenas we want to really look into and invest into. And with that, let me turn the lens back to our panelists. You all come with amazing stories. You are trailblazer. Can we maybe start with a little story of, how you started in the tech community, how you get involved, and share with us, something exciting that happened in that journey. So maybe we start with Dr. Kiritika.
Hi. Okay. How did I get started in tech? So I think I always wanted to do something in science, right? So it was my best subject in school. And I was fortunate that there has always been opportunities for me. So at some point of time during my university, I managed to get an internship at a research institute. And then following that, I landed finally a project that I enjoyed. And then, that led into graduate studies and finally postgraduate and so on. But maybe around 5 years into my postgrad, I decided to make a bit of a pivot. And instead of focusing on doing research, I decided to move into the education field. And there were a couple of things that wanted me to make this change. The first one was the fact that I became a mother. And I wanted to, it was very important for me that my kids grew up in an environment where education was moving very fast, and STEM education was something that changed. So in the olden days, when we were studying science, when we were studying computing, you literally had to do things where, the question in the exam paper would be name the 3 parts of a computer, and you would have to say the 3 parts of the computer are the monitor, the CPU, and the keyboard. I do not know how many of you belong to that generation, so literally that's how it used to be. And of course today things are very different, and you have tools out there that enables anybody to learn how to code and to get involved in tech. And one of the tools, and I think that this is something that I always like to say, that my younger daughter, learned how to code before she learned how to read.
Wow.
And that is, and it's not so much of the ability of a child, you know, and sometimes say, oh, your daughter is smart, but that's not true. It's the fact that there are tools available today to make it accessible to someone that's very young. And I was totally fascinated by that idea. And what was lacking was the fact that, you know, while there are tools available, people are not aware of these tools. Someone needs to go out and tell parents, because we as parents, we as women, is like, okay, coding. I am supposed to be doing assembly language, and you know that's kind of what people have in mind. You know, pages and pages of jargon and hexadecimal numbers that make no sense to anybody, but that's not what it is. So that's sort of how I pivoted, and now I just want to bring out a couple of things that struck a chord with me based on what Sherry had shared a little bit earlier, on specifically on women. And early, when I was a staff at the Science Center, I had the pleasure of hosting a hackathon that was run by a bunch of students. And they were trying to do some work on hacking old electronics to make cool stuff. I mean, students love to do projects like this. It was a student-fronted project, and this boy whom we had known had got together all his friends and said, you know, we would like to use the Science Center. So sure. And what struck me was that out of that group of about 25 students who were part of this hackathon, there were 2 girls. And they had a lot of fun. The students had a lot of fun. I was observing them. And at the end of it, the kids were doing reflections. And the girl stood up, one of the girls stood up, and she was almost crying. And she said, ever since I was a child, I had never had the opportunity to build anything. I have never played with Legos. I had never built anything, and today I built this. She was maybe about 15, 16, give or take there. And I stopped and I said, what's happening here? You know, 15, 16-year-old girl in a generally good school in Singapore, never had the opportunity to build anything before. And so then sometime later, I watched this video, which I think has been floating around in social media quite a bit, where there is a girl child who is growing up. And as the child is growing up, things happen in the way we speak to that child. You know, hey, princess, how are you? Don't touch that big tool. Let your dad handle it. And these things make very subtle. It's not that as a parent, we don't want our children to go into engineering. It's just that as a parent, from the very, very early ages, we have these little biases that implicitly sort of feed into our kids that, you know, I'm a girl, I should be not doing I don't know what. So you know, so these are things that I think I really want to change, and that's kind of why I am where I am. And I think I'm going to hand the time over before I start talking too much. Okay.
No, this is super inspiring, Dr. You know, you talk about the importance of advocacy. So many people are not aware of the opportunities out there for that shift and that change in this arena. So thank you. Continue to champion that. And I really, really love your story about girls. I just had this impression. We did DG Girls in Sri Lanka. And when we look into the eyes of some of these kids, they're like, oh, you know, exactly the expressions that you just articulated about how, you know, they've never built something. Now that they've experimented it, they think that, wow, actually I can do it. I have much bigger dreams, and I would really want to be there helping the other girls, helping the other, you know, people who has never touched a computer, who has never coded. So I love your inspirational story, and it is super important for us not to put that conditional, you know, lens on our community, especially as parents. Spot on, you know, sometimes we put that unconscious bias and that condition on. Thank you for that. It's super inspiring. And maybe let's turn to Han.
as for me, I must confess that I'm not a tech person. I have been working in my whole career as an anthropologist with very limited knowledge on tech. But what has been really inspiring me and then to begin to explore these stories is so I mean I've been working most of my career in the culture sector, and in the culture sector we face a lot of challenges, and I guess you all know it. There's like artists and heritage professionals have very low and unstable income. There are very little resources to support them. Culture sector is a very poor sector, if I must tell you. On the ministries, on the NGOs working on culture are generally very poor. Artists are often struggling. There are very limited opportunities for networking with other people, to receive new skills, to learn new things. We see with our own eyes heritage are being damaged at a very fast speed. And then if you are from the consumer user's point of view, you also have certain limited access. I mean, you would have access to more mainstream cultural products, for example, than the products that are produced by more marginalized indigenous groups. And then when COVID took place, started about a year ago, we see all these challenges are getting worsening very, very fast. And at the same time, we also see that how fast the culture sector start using digital technology to maneuver and to try to make the sector better, to gain a little bit more income by putting things online and things like that. So that's when we really see that, okay, there's maybe there could be a great ways to bring the partners from the culture, from the technology world, and also bring new business models in to really explore something to make the culture sector a better place for everyone to be. So because of that, we initiated this initiative called Tech for Culture. But then, if you say it is like tackle the digital the challenges that faced by the sector. So with this, we aim to provide a platform for all these different partners from different sectors to come together, to learn from each other, to network, to build capacity, and to develop solutions to support the culture sector. So we started with this first Ideathon. Very great honor to partner with FOSSASIA for the first Ideathon. And we see some interesting figures I would going to give you. So when we did the Ideathon day, when Krutika actually gave a very seminal workshop. So we have 443 participants join, and half of them are women. About 50%, no, 40% of them are young. They are at the students' background. And they come from 31 countries. Some of them are from areas that we would consider kind of a bit of the frontier in the technology world, like Bangladesh, Mongolia, Nepal, Uzbekistan. And then people come from backgrounds like culture. They are artists, actresses, curator, film producer, tour guides. They come from technology side, software, cloud engineer, web developer. And they are students, professors, researchers, entrepreneurs, government officers. So we really see a very diverse range of people. And so we are kind of also very hopeful that how with this approach that we are taking by bringing different sectors together, we can kind of encourage this inclusivity and diversity for the tech world, but of course also for our culture sector as well. So that's how we kind of started, and it's still a very early process in terms of UNESCO. In the parallel session, we are also having other activities at the global level on looking at AI, and especially like so I am very excited to hear about the Microsoft initiative on women and AI, because we also found very much of the same evidence that you have just stated earlier. So that was the process that UNESCO is working on with experts to develop recommendations for ethics in AI, and a lot of that was one of the main principles is related to inclusion and diversity.
Very nice. Thank you, Han. You know, you talk about how, hey, I'm working all my life in culture and not really in tech. But honestly, you know, we have a Satya Nadella said that, you know, culture eats strategy for breakfast. So culture is such an important fabric of, you know, our society, and something that you know, as every one of us make choices, you know, this basically builds a culture, and the culture basically shapes our world. So thank you for the passion and the work that you've been doing. And in this arena, especially when you talk about, hey, you know, we work with farmers in the rural area who are not very exposed to technology, who has very little economic actually opportunity. This is really the era where we got to open up technology platform to give them two things, right? One, technology to AI and technology to help the farmers increase their productivity, increase their ability to drive more sustainable production. But more importantly, with technology, now they can have an openness to the whole marketplace, to the whole ecosystem. So your work in the respective culture, I mean, this is about farmers. The same thing goes for fashion designers, for artists. They do not need to be limited to a small physical constraint of pretty much where they can sell or market their products and solutions, but pretty much open, you know, the whole global ecosystem to them. So thank you. Continue to champion that work. Maybe let's hear from Hong.
Yes. My journey to tech, to be honest, I got a little bit related to what Kirutika said about access to tooling. So I actually did not get into tech until I was 20. Yes, you know, I grew up in Vietnam, and you said even like people who live in Singapore feel that they don't get access to the right tool, and country like Vietnam or India, even like more difficult at the time when I grew up. But I got into tech. I must say again, even though I said it so many times in every conversation, it's all about open source. So my first interaction with open source was at the time when I did a translation freelance job in a conference where we talk about free technology, and where I also met my partner Mario, who explained to me open source. And after that, I got the initial idea. I started to connect with the local Linux user group. Yeah, I went to some meetup. At that time, I remember that they did like every Thursday meeting where they show people how to install different like Ubuntu OS or Linux Mint in their machine. And I get to the group. I start to connect with them, and I realized that people in that group are just so passionate about what they are doing. At one point, when I come there, I never have like tech background before, but when I come there, I remember one member sat down with me for 3 hours, explained to me how to use the terminal, and it got me very excited. When you use the terminal, everything like becomes like so very fast. You can download software so quickly, and you can actually see you give a command and something happen in the background, and it's got me very excited. And of course, not only that interaction get me into tech, but several like throughout the year of that year, I realized that there's so much learning opportunity that open source can offer me. And whenever I meet an open source contributor, they talk so passionate about what they are doing. You know, I met so many people who contribute to project for over 20 years and still so excited. So when you go to the workplace, a lot of things going on, and sometimes you get stressed with your work. But as soon as you ask them to ask about their open source project, they can talk to you hours and hours non-stop. And I think that this is something that's really cool, really cool. And open source is not only about software, it's about open collaboration. Without open source, I would not be where I am today. I got not only FOSSASIA, the reason why I started FOSSASIA, I want to show people, I want to show women out there that actually opportunity, there's so much knowledge, so much resources in this like tech world that people are willing to share, and it can empower you to grow your own career. Even I did not study in tech. I'm now working fully in tech industry, and also got like some I would say a proud achievement, because make FOSSASIA sustainable and like over so many years, and I got invited to join the board of director of the Open Source Initiative. This is the organization that safeguards the definition of open source based in the US, and I also got invited on the board of Open Source Business Alliance because they actually want to understand the perspective of women. And I also recently got appointed to join the IEEE Standard Association. So all these opportunities would not come if I have not made my way into the tech industry and open source community in the first place. And I also want to second what Hạnh said earlier in the hackathon that we organized a few months ago. So we see women coming from Cambodia, coming from Mongolia, places that really difficult to access, coming from Myanmar. But the current time is changing so much. So internet had enabled us to do many things that we could not imagine before. And software technology is not only about coding, and what Kikutika said, there's so many potential for us. And I really think that the conversation is really important. It's also a pathway, the approach to raise awareness to more people. Sari, if I may, I just want to mention one more program of FOSSASIA that we're doing, because we also contribute into this journey by organizing our own coding program. Code Heat, we've been running this program for many years already. So the whole idea is to get mentors, the people like more senior in the community, to help the younger students and developers to contribute to open source and learn a new skill. And last month, I think just last month, our last season, we got 2 women winners in the group. So every season, every time we have 3 brand prize winners, and the last one we have 2 women coming from India, and I'm very proud that we encourage and engage more female students and young developers into open source.
Wow, Hong, I'm super inspired. You're really our hero, here. It's just amazing to hear how you started with an innocent approach into a conference, tried something and got super excited about it. And then that just paved the way of such an admirable journey right now. And I think a lot more people should hear about your story and your journey. And you're spot on, right? Today we are in this arena where the physical boundaries have all been dismantled. We have an amazing opportunity right now to get equal access to the community out there. And I think one of the most powerful things that you said is how it's not just about coding, it's about open collaboration. How do we really need to break down the walls so that we can enable and encourage people to collaborate, make the voice out there very active. And as women, I really think that we have such an amazing opportunity to be each other's allies, to help one another. And I would also say, in my experience, maybe just a quick opportunity also to talk about, you talk about how you did not study tech, but you're now full career in tech. I did not study tech as well. I graduated with a business degree, and I started my journey with this company called Lucent Technologies. Back then, in those era, is the authority, is the tech, icon that is building communications network, internet backbones, switching devices, signaling networks to enable, the mobile and physical data communications. So I got into that role, Lucent, basically starting to do proposals. I'm just putting proposals together, but I really have an appetite to kind of digest all types of information. So I read and learn. I just want to say that really kickstart my journey into tech. And one of the biggest thing, I think Kirutita said that very well, is, don't put limitations. I really did not start, my school days on engineering topics, but today I'm very deep into technology, into the architecture, and know, more importantly, how the systems of work and how technology can make a difference for people's life and our society. So that is super powerful. And I encourage all the women out there, do not put a constraint, do not put a lead for yourself. You have many allies out there who's willing to help and support your journey. And more importantly, what Han and Hong is doing to create that open platform where women from all over the world, can actually have an opportunity to code, have an opportunity to dabble into the tech world. The world that is in the making today is super digital, right? Digital is going to be every part of it. I would think one of the biggest thing is about courage, taking that courage, that first step, just like what Hong did. And more importantly, having that continuous growth mindset, always wanting to acquire more information. And with open system, there's a lot of knowledge out there that you can freely acquire. So with that, maybe let me just turn, in the interest of time, to a second question. You're doing a lot of things out there. Like it or not, the reality is there are still a lot of work for us in the arena of diversity and inclusion. Like to hear what are the barriers that you actually experience, the biases and the discrimination, and maybe some of the good success of how you overcome those challenges. I don't know, Han, Hong, Dr. Kiritita?
Okay, maybe I'll go first. I think when we talk about challenges, there are actually two challenges which I think we face that gets people, not necessarily women, but everyone away from technology. And I think somewhere we need to address these two issues. The first, of course, I think I mentioned this right at the beginning, is that this is too hard for me. Now, we all know that technology is important. We all know that we can't, none of us can live without our smartphones. We have FOMO, fear of missing out if we live without our smartphones. But we don't think that we have the ability to create with the technology that we have in our hands. We want to be consumers because it's easy. Again, a bit of a plug towards what we do at the Science Center. We always believe that everyone should be a creator of tech and not a consumer of tech. And many of the stuff that we do is actually geared towards bringing up that kind of a mentality. And it's doable. And of course, again, the tools that are available, that amazing set of tools that are available that helps us to make this happen, right? The other thing, which is also a little bit concerning to me, is not that it's too hard, but should I do it? And the question comes because, but when we really think about it, right, I feel that this is a bit of an 80s mentality. So, okay, I'm not a coder. I'm not an engineer. Why should I learn how to code with Python, for example, right? Is it even relevant to me? And then if we kind of, again, take a step back, again, I did say that none of us can live without our smartphones. But at the same time, can we just think of any job, open thing where technology does not help us? Let's consider, say, farming. Okay, fine, the most lowest tech job that you would think of, and it's been around for. But we all know, and every day we read newspaper articles about how farming is going high tech. People are using IoT and robotics and farm bots, to get your farming easy, and of course to solve certain challenges in the farming community as well. Let's think about carpentry, for example. All right. So when you're a carpenter, do you need to use technology? I mean, all I'm doing is cutting wood and screwing it together. What do I need to know how to code for? And I just recently read this article about this Indian guy who actually is a carpenter who makes bespoke furniture, and he's using augmented reality to make his furniture more interesting and enhancing. And really, if you think of any job in the world, human resources. I heard a story about how, I can't remember if it was Shopee or some other company, where they're actually they're hiring HR people who need to know how to do big data analysis because they need to crawl LinkedIn to find headhunt people. So really every job needs tech. So don't tell me that I'm not working in technology. You are working in technology regardless of what you do. And tech can help us to make and do our job better. And I think that is one of the biggest challenges that we need to address. It's not teaching technology to technology people. It's teaching technology to people who who feel that they don't need to do technology. And to me, that's a little bit synonymous to say in the early 90s, people used to go for courses to learn how to use Microsoft Word. And you had to have a certificate in typing or certificate in this to get hired. And nowadays nobody bothers with stuff like this. And I think maybe 2-3 years down the road, nobody's going to bother with whether you have a micro certificate in Python. You're supposed to have it. I'm sorry, it's like reading and writing. You just have to do it. So that's what I wanted to share.
Absolutely, absolutely. I love the fact that you're talking about everyone should be a creator, and with the tools and the technology on our hands, the perception that I can't do it. This is one of the biggest challenge. Absolutely, and thank you for continue to advocate that. How about Hong?
Yes, so I just want to continue what Kirutika said. Yes, okay, Kirutika, I totally agree with you, Kiru. So technology, I think all the industry would benefit from technology, and everyone should learn. And it's all about the mindset from the beginning. If we have more models like you who encourage their children right from the start, that would be so good, right? So we need to do more advocacy, more outreach. But another thing that I see as a challenge, I work with many corporations, many companies, and I also see that the ratio in career development on the leadership level. So you still see a lot of men have it seems like, so if you look at report from the industry, there's still a lot of men that holding emotional position in corporation. And of course, I'm really glad to see that Microsoft doing a lot into this direction, as Sherry already shared earlier. And I also see, so besides this is the first time I got to meet Sherry, but before that I've been working several years with Sinhu, and I just see that Sinhu is a good a role model, a way that when people are looking that women can also advance in their career, and there's opportunity in the leadership for women. And this had been the society had been putting a lot of pressure and raise awareness across industry, and companies started to make good effort to change this, and this is something that we very happy about. Yeah, so connect to that, I want to say that we need more role models. So we need women to inspire other women. And this is great to have the panel for discussion, so that companies out there take this as an example and do more, make more effort, similar to Microsoft, create an environment where women feel comfortable. You mentioned about you have the program for women in AI, right? So if you look at Asian landscape, a lot of countries, they have the Pacific culture that makes women tend not to be so comfortable to be around men. So we have, if we could create an environment specifically for women, make them feel comfortable doing what they are doing, it's also a great opportunity. For me, in the FOSS community, of course, I did not, luckily, I did not experience discrimination while working with the FOSSASIA community, but I also heard stories from other people. And at the end, it's all about the misperception, misunderstanding, because the way some people communicate might not be served as appropriate to some other people. So the cultural factors, I also see is as a barrier, and this is something that we need to tackle as well. And this is linked to Han, who's really an expert in culture, and you perhaps, I'm really inspired to see all the team members in your office actually women coming from everywhere. Perhaps you can chime in and share with us the story there.
Yeah, thank you, Hong Phúc. And yeah, I completely agree with the challenges that Hong Phúc and Kirutika had just mentioned, and previously Sherry as well. And before, just very quickly, I would like to point out to the link that my colleague Misako Ito just put in on the chat there about a video. The link to a video that UNESCO has made on gender and AI. So maybe after the panel, you very welcome to have a look. So in terms of challenges, I'm going to shift gear a bit. Of course, yeah, we hear the challenges about how women can, in relation to tech. And I would like to maybe bring in maybe the challenges for people who are not the tech people. But now, as you see, everything is digital now. You cannot really miss the trend anymore, because, I mean, if we are not on it, and you would be very behind. And we have already seen how technology has made great implications for culture and artistic expressions. You start seeing AI producing artwork. I think you all know about this artwork, the next Rembrandt. I think Microsoft was involved as well, right? So eventually, I mean, if I think it's a great experiment, by the way, but then it also raised certain questions about future of the arts, whether a human will be making it or we will be having machine making it, and then also rise and remuneration of artists as well. And so if everything was being put in the hand of the tech, and so what would be for the culture sector, what would our artists, what would our heritage professional have the role in it? So I think the access for the culture sector, and with this, I think would be equally important for agriculture sector, for health sector, for all these other sector as well, not just the culture sector, to how to have access to all these tech opportunities, how they can also be trained in all these tech skills. Of course, I mean, if they had opportunities to learn STEM from their young age, and later if they become an artist or they become a heritage person, they already have that STEM knowledge in them. But then a lot of the countries do not have opportunity to offer STEMs to young children. And so they would grow up, they would become artists, they are struggling because artists all struggle. And then they have to try to maneuver on this digital world, and if they are not fast enough, and then some tech person would come in and run away with it, right? So how to really provide access to the culture sector or to any outside sector to learn about all these skills and knowledge, about all these financial opportunities, on the infrastructure and equipment, and more importantly, I think the opportunity to really work with the tech people, because at the end of the day, it's not really you compete, culture sector compete with tech sector to see who would produce the nicest artwork, right? But I think the future, I think, is I really would like to see the stronger collaboration between the sector, and who would provide these kinds of collaboration. Because to be honest, for me as a culture person, when I look at all these topics that Hong Fook is organizing under this summit, a lot of them look like foreign language to me, because I'm not really a part of this world, you know. And I could say that probably 99.9% of people in the culture sector would feel the same way. So where do we begin to pave the way to start including other people? They would never replace the tech people, that's for sure. But then how they can start beginning the common language so that they can work together with the tech people. So I think that is something that we would really like to explore further.
This is super exciting. I feel like we got so much to talk about, but unfortunately, time is running out. So maybe just a pause of a second, and I want to sum up, all the great insights that our panelists have provided. Any questions from the public chat group that we need to address?
Yes, Sherry, I think that we have a number of questions. Do you see also the share notes? I saw quite a number of questions already.
Somehow, oh yeah. Oh. Shall we take maybe 1-2 questions? Let's see. I'm super excited given we have so much great insight from here. I am scrolling through the chat.
Sherry, so in the share notes, the question, so if you see on the left side, you see notes, and there is the option share notes. People have been putting their question inside there.
Oh yeah, okay, got it. So how about you? A lot of question on diversity, half of young women.
I think we can, Sherry. Yeah, I think that there is.
Take 1 or 2. Yeah.
Yeah. So people are still typing, but I think there is an easy one we can start first. There are so many technologies I do not know how to start. What do you recommend for students who are in school?
That's a perfect question for Kiru.
Yeah, that's my favorite question. Thank you for asking that. For students who are in school, there is a suite now, and the suite is a growing suite. So there is it's certainly not an exhaustive list. So for starting how to code, I think there are a couple of platforms. My favorite one for the very, very young kids, the 4-year-old in us, is actually Microsoft's Kodu platform, which is a little very visual programming thing. So my daughter actually learned her first code in Kodu. That's Kudu. And then there is the open source option. So we've got Scratch, which is from MIT Media Lab, very commonly used in schools to teach kids how to get started in coding, as well as computational thinking. There is also, so when we talk about coding, we also should not sort of ignore the hardware options that are around there as well. So my favorite boards in that order is actually the Makey, which is a very simple board to interface any kind of code to a physical environment, and that really excites kids. We have the Microbit, which is really grown in popularity over the last 3 to 4 years. And then following that, we have the Arduino program. There are a lot of block-based coding opportunities where you actually can code without coding, in that sense, without really like writing any syntax. Other than Scratch, and the block-based environments have actually moved very far. So something like Scratch can only get you to a toy product in a sense, but there are tools like Thunkable. My favorite is actually Thunkable. Thunkable is actually an app development environment, and at the end of the day, you can actually do a functional app that you can export onto an Android phone and distribute it so that you can share your app with your friends, and literally anyone can use Thunkable. So there are really many tools here.
Just so much, and I just sorry. We have 3 more minutes, and I wanted to get
I know.
one close. But before I go there, I would say go to LinkedIn.com. Right, there is a whole series of what we call digital foundations. And to Hans' point, everybody needs to kind of like embrace tech. Doesn't matter if you're an artist or you're a taxi driver or you're a teacher. So I would encourage you to go to LinkedIn.com. We're giving a lot of free courses, basically, and you get certified. So you get a journey into tech, not just awareness and knowledge. And also watch out for maybe my LinkedIn, where we're going to publish a very, very large initiative called Women in AI. We're giving skilling certification program for free to encourage women. And there's a very, very good question on the panel, on the list for all our panelists to close with. It says, what is the one change you want to see now? That's very practical. So I love to hear from that. For myself, the one thing I want to see now is the rise of women in AI, because it starts to Chris' point, from the development phase. If we are able to release a large pool of women into the tech world, you're going to see a change in the end product that's designed. You're going to see a change in the representation of women in top leadership in organizations. You want to see a change in those statistics that needs to move. So I would say women in AI, watch out, click in, take up the courses. It's for free. You get certified, and then, move into economic or employment opportunity. So maybe Hans and Hong and Kiru, just one thing you want to see as we closed for change now.
Yes, I mean, I would definitely send my artists to go and train at your Women in AI course. So thank you very much for notifying us about that. And for us, for me, and for our work here at the country unit at UNESCO Bangkok, we would really like to see how we harness the digital technology to make the sector more resilient and more sustainable. And we would really like to see that as an equal partnership between the tech partner and the culture partner. So that's really the biggest aim for our program, TechCar.
Love the partnership. Home?
Yes, so the same for me. I also want to see more partnership between FOSSASIA and other organizations and companies to run more programs for women to learn about open source technology and contribute into different open source projects. Yes, so we're doing the program for many years already, and we invite companies and partners like the UNESCO to join hands with us and bring more women into open source.
Thank you. Kirutita.
For me, what I would like to see is to encourage more people to attend events and programs like FOSSASIA. That's where you get to learn what is out there and to actually lose that inhibition that stops you from getting on board technology.
Thank you very much. I'm super inspired. Thank you. You know, we all talk about advocacy, you know, taking away that condition, that limitations that sometimes we put on ourselves, and be exposed in events like this to know that there is a world of opportunity awaiting for all of us, and all of us can play a big role in changing and shifting the diversity and inclusion index in the world. This is a very powerful mission for everyone on this, you know, forum. We want to see change. We want to see change for a more inclusive and better society, you know, for our generations to come. With that, thank you so much, our great panelists. You're all superheroes. Continue to be role model out there, you know, to inspire more to come. Thank you. With that, thank you, and I hope you enjoy the panel.
Thank you very much.
Thank you.
Thank you for the opportunity. Han, Sherry, and Kiru, I know that we are running out of time, but there's still quite a number of questions on the channels. I wonder if we can type the answer so that people can get the answer for the question. I think there are a few questions related to Microsoft and a few related to tech cool. So I would really appreciate so the audience can get the answer if we type the answer there.
And continue to reach out to us. I'm sure we are all, you know, on LinkedIn. Continue to reach out to us, and we'll be happy to take questions. After this, we will all go in and ensure that you get the answers in the
Thank
chat.
you very much. Thank you.
And thank you for the great opportunity, and congratulations. You know, we're all super inspired by the work of FOSSASIA.
Thank you. See you.
Bye.
Thank you.
Okay, hi everyone. I'm Marcus, the moderator for the next few sessions. So next up, we have a session on PyTorch, the PyTorch vision and the state of the state in AI. So this will be a talk by Joseph Spisak, who is the product lead of PyTorch from Facebook AI. So yeah, he's here already.
Excellent. Can you hear me, Marcus?
Hi, Joseph. Okay, so I'll just give you a quick intro for everyone here. Okay, so Joseph Spisak is the product lead for PyTorch, the open source AI platform that Facebook internally uses to develop its AI, as well as externally by OpenAI, Microsoft, Tesla, and Uber. His work spans collaborations with internal teams as well as working with the AI developer community to bring scalable tools to help push the state-of-the-art forward. Prior to Facebook, Joseph led a deep training product management team and global AI partnerships for Amazon AI. Before that, he was also the director of machine learning segment strategy for Intel. So with all that, can we invite Joseph up to have his presentation now?
Excellent. Thank you so much for the kind intro. I will attempt to share my screen. Actually, maybe I need permission.
Do you want to upload your slides?
I uploaded them, but I can share my screen as well. Either way.
Okay, wait. Yeah, I'm giving you the presenter rights.
Excellent.
Yeah.
All right. All right. How's that look?
Yep, it's working.
All right. Excellent. Yeah. Thank you so much for inviting me. I know it's this is a really big event, and obviously anything open source is near and dear to my heart. So yeah, I really appreciate the invite and great to see everyone. I wish I was in Singapore hanging out with everyone. Next time, I promise. So yeah, I'm Joe Spizak. I'm at Facebook, and I'm here to talk about PyTorch. So for those who don't know PyTorch, it's really a framework, an AI framework for AI research to production, and has an incredible ecosystem around it. And for me, it's been a long journey, and it continues, and it's still a lot of fun, and it just keeps on growing. So it's an exciting project. So I specifically want to talk about the journey and how we got here, and kind of where the things we're investing in, over the next 3 years. And I apologize, it's kind of dark. It's a little late in California, but I got my tea and I'm fully caffeinated, so I'm ready to go. So as Marcus mentioned, currently at Facebook, I've been with Facebook a little over 3 years now. I joined right at the beginning of 2018, right at kind of a pivotal time for Facebook and building out their AI platform, where they had a number of different platforms, and they were looking to kind of unify and figure out what the path forward was, and how we essentially scaled up, for all of our products, but also for research. Before that, it was Amazon, and then of course at Intel prior to that. And I think one of the reasons I'm really excited to speak here and just hang out with all of you is, this intersection of open source, AI, and community building is something that it's a source of incredible passion for me. So I love working with people. I love working in an open way where, frankly, anyone can have an impact, no matter where they are in the world, no matter who they are. Open source is the ultimate equalizer. And if you're passionate, and if you have drive, and you want to create something, you have a blank canvas to go create it, and an infinite number of collaborators to work with. So that's one of the reasons I love it. So I'm going to start with just a little bit about the journey of PyTorch. So, again, for those who don't know, it's kind of an interesting path that the project took. And it really started back in 2016. We call it this kind of humble journey, right? It was a few researchers across companies, actually. It was in not only Facebook, but also NVIDIA and a few other companies, kind of coming together, actually with even independent developers, to build something that allowed researchers to basically be more expressive. So this was kind of a pivotal time in machine learning. For those who don't remember, in the space there were a ton of frameworks, but there was really this situation where you had a number of these tools, but then you had really this space that was getting more and more dynamic. And so you had different types of architectures, computer vision, natural language processing, speech, and just the overall space was getting definitely more dynamic, and researchers needed new tools. And so there was this, Lua Torch, for those who know Lua Torch, based on the Lua language, which of course not many people program, was incredibly dynamic, but no one really used Lua. So we kind of needed something new, and something that really plugged into an ecosystem and that was more broadly available. And there was also the start of projects like NumPy, and for anyone who uses Python, which in the last panel, I think there are quite a few people who use Python, and they should. It's an awesome language and awesome ecosystem. NumPy is incredibly popular. And right around that time, we also saw this incredible need to scale research. So when these large computer vision models, as an example, for those who remember, the residual nets when they first came out, and they were really large at the time, we started to scale these things over, say, like hundreds of GPUs or even thousands of compute elements. And so you kind of had the situation where you had, you needed to be dynamic, you needed to be expressive, you needed to be able to kind of plug into this ecosystem, as well as be able to kind of scale. And that's really kind of the beginnings of PyTorch. And if you fast forward, essentially, a few years, again, right around the time I joined the party there, about, a little over 3 years ago, researchers, there was this incredible transition where it was like researchers all of a sudden became product owners. And they started really like taking the goodness, the work that they had done to really take the field forward, and again, in areas like computer vision, and they started to see product impact from this work. So things like, object detection or instance segmentation or image classification, a lot of like the self-driving cars were really in full steam at this point. You look at all the computer vision research that they put out, companies like, Toyota Research or Tesla, or Aurora and so on. And, they really started to operationalize or really create products from this research. And that really required a little bit of a different mindset, which we'll talk about later on. And of course, everyone wanted different hardware. So for those familiar with cloud TPUs from Google, we've been working with them for 2.5 years now on that. AMD and NVIDIA GPUs, and of course, Intel has a whole variety of silicon around CPUs and other things as well. And then you had this like ecosystem of software tools that grew up alongside all of this. So this goes back again to like 2017 when you started to see this ecosystem really start to form. So you have projects like Hugging Face or for NLP, or you had Fast AI. If anybody knows Jeremy Howard, he's leads one of the most incredible and prolific communities and ecosystems, and with free MOOCs and just a global community of people just thirsty to learn AI. And he builds tools and so on. He built, of course, on PyTorch, which is awesome. And I would say analogous to Jeremy in the Fast AI space is OpenMind and Andrew Trask. For those who haven't checked out OpenMind, they're an incredible community focused on privacy and building tools to allow application developers to incorporate cutting edge privacy tools like differential privacy into their applications without having to be a privacy expert or a cryptography expert and so on. And then you fast forward to 2020, last year, there's a number of different next generation tools that have come out, or new plugins, things like Visual Studio, where we have custom linting or code completion or things for PyTorch, or Torch Serve if you want to be able to deploy models at scale. That's a project that Amazon, for example, maintains, or MLflow with Databricks and Microsoft and others. And of course, as I mentioned, privacy has become really important. So projects like PySIF, which allows for things like federated learning or differential privacy with Opacus, or even secure multi-party computation with projects like Crypt10. So really, this is this journey really started from research and it really transitioned into this production setting, but really has become an ecosystem. So it's a community, it's an ecosystem, projects all kind of built around PyTorch. So this sounds really nice and sounds very easy, but this was actually, as I mentioned, was a long journey, and it actually depended on a number of core principles that are kind of near and dear to us, and things that I would say that we have to defend almost on a daily basis. Especially in a large company or in working with the community, we want to make sure that our core principles are maintained and how we think about running this project and working and continuing to grow this community. So when you look at AI, and generally speaking, and this whole research to production paradigm, it comes down to this flywheel. So starting with cutting edge research, as I mentioned, that's kind of like the source of innovation. This is where the real breakthroughs happen. Like, how do I push the state of the art in things like language models? GPT-3, a big model that everyone still talks about these days, was built on PyTorch by OpenAI, and really was a big breakthrough in natural language and language modeling. Production grade, as we'll find out very quickly, these are in tension. These two concepts of research and being production grade are in tension. And then this interoperable ecosystem, which kind of ties the two together and creates this full flywheel that kind of wraps around this community co-development paradigm. So starting with cutting edge research, from this perspective, it really is all about the flexibility, this concept of, I can express essentially any idea, and I can quickly iterate and quickly modify my code and be able to just experiment in a really fluid and dynamic manner. And this is what researchers really demanded. And this is something we still defend today in the front end of PyTorch, because we could easily go down a very static graph approach to get more performance, or integrate better with accelerators on the back end. But this idea of full flexibility is just so endearing and allows for so many breakthroughs. It's so important. And then if you look at production grade, this is very kind of orthogonal to what the researchers care about, right? Yeah, they care about performance, but they care about performance in training so they can iterate on their ideas quickly. But they don't really care about efficiency or reliability or scalability as much. These are things that you consider when you're running and say the trillions of predictions, a day, like for example, some of the things that we work on at Facebook. And as I mentioned, these are in constant tension, because again, these are very orthogonal things that you're optimizing for. Researchers may not care, for example, that you have maybe governance or CI/CD or your models are maybe explainable, like you might need in say a production environment. They really just care about being able to iterate quickly, push the state of the art and say a benchmark, and so on. So this constant tension, really is an interesting thing that I frankly deal with on a daily basis. And one of the really interesting things about doing a community co-development and actually having a community around your project is it actually widens, this workload. It widens the scope of what you could otherwise accomplish, and it allows you to really strike this balance, because you have this interoperable ecosystem that allows you to basically either cater to users internally or externally, and be able to kind of diversify your investments, and be able to kind of just I like to actually call it seeing the future, because when you really build this platform that the community can build on top of, and for example build fairness tools, or things like frameworks for graph learning, you really get a chance to understand what might be coming next, and be able to try things in a low-cost way. And some of these we adopt internally. A lot of things we obviously open source if you look at some of the things that our team has done. And yeah, fundamentally, we just can't enable everything ourselves. And this is one of the reasons why it's great to have a community around us. As a result, as I mentioned, a lot of these libraries came to be, and whether it's Cornea or PyTorch Lightning and so on. And I would say, as I mentioned previously, the Python ecosystem has also been something that is incredibly important to us as well. So things like Rapids, if anyone's familiar with the data science platform from NVIDIA, or the Ray project out of UC Berkeley, being able to just basically interop with all these things, or Apache Arrow with the data frame format, essentially it's Python, so you can wrap and wrap and wrap and do whatever you want. It's beautiful. And so it's really one of the reasons it's great actually to be part of that ecosystem. So good news is, I think it's been working good so far. We have almost 1,800 contributors to the project. We have almost I think 64,000 downstream projects to PyTorch that use it as a dependency or build on top of it. And we have almost 40,000 form users. So this is actually pretty interesting, because it's one of the ways that we maintain a healthy community is we have this this self-sustaining forum. If you go to discuss.pytorch.org, you can actually see all of the people answering and asking questions, and you just see the community kind of step up and self-sustain, which is great. So with all of this said, how do we what are the things that we actually want to invest in going forward? So for those who are into AI, and especially in the research space, the areas that we're investing in are things like better front-end APIs. So if you look at some of like the recent release we did just 2 weeks ago, we added, for example, new APIs for fast Fourier transforms or linear algebra functions. And these are modeled after the NumPy APIs. And this is great for scientific computing. So, previously, like, for example, if you had to do, say like a complex number, complex numbers, which we add in the previous release, you actually had to have like 2 tensors, right? One for the real and one for the imaginary. And so we added some nice APIs also for things like that. So generally speaking, we're always looking at ways to kind of make life simpler for people doing different types of research. Second is these new modeling paradigms. So for those who have followed the transformer, revolution, everything's a transformer these days. So of course, it's not limited to language models, like GPT-3 or some of these like larger models like Roberta and so on. We're also seeing these vision transformers, and we're also seeing things like again, graph neural networks and so on that can capture a lot more information. And then comprehensive domain libraries. So again, this isn't something that we all do ourselves, but we have an incredible community that keeps coming out with libraries. And like for example, just last week, the community members developed something called Torch Drift, which allows you to understand in production when your model is actually drifting, say, concepts. This is actually a really nice robustness library that kind of falls under that responsible AI umbrella. So when we think about production grade, some of their investments are, acceleration. So, if you look at whether it's looking at quantization or distillation or NAS or some of these areas that you can actually accelerate models, whether at the numerics level or at the model architecture level itself. These are areas we're investing in, not only for server, but also for on-device. So mobile is a really important aspect. If you look at how many of the models these days for either user experience reasons or privacy actually run on-device. And if anybody, for example, uses, say, an Oculus Quest or like a Quest 2 or say a Portal, those are actually running models right on device. So if you use the hand tracking as an example, that's all computer vision running right on your headset, right on that processor, which is pretty amazing. But that, of course, uses aggressive things like quantization or running at lower precision and so on. Compiler is a really interesting area over like the last, I would say, a few years here. It's been a really big source of innovation in the AI space. So, whether it's generating kernels for different types of hardware or being able to basically take graphs and be able to like lower them, run passes over them. Basically, like the compiler technology, generally speaking, is kind of in this really interesting space right now where there's a lot of innovation happening. And there's even startups like OctoML with Tianqi Chen out of UW, now at CMU as a professor, where they're actually building products and actually building startups around this technology, especially a project called Apache TVM. So we're kind of in like the heyday here of AI of compilation, and which is really interesting. And of course, PyTorch has its own kind of built-in compiler technology. We have a pretty large team working on compilers these days. And I think the other piece of performance is hardware. So whether it's like hardware we're developing ourselves, whether it's the on-device stuff or in the data center, or also, if you look at just all the hardware startups out there, I think there's well over 100 at this point, along with, the typical vendors like NVIDIA and Intel and AMD and others, providing different types of accelerators. And that's just going to continue to, explode, whether it's training accelerators or inference, or on-device acceleration, like for example in like the new MacBook or with the M1 processor. This whole diversity of hardware is a trend and something that we're investing in quite heavily. Model scale is something that is definitely production grade, production centric, but it's also something that fuels research as well. And if you look at some of the things that we had in our recent releases around things like pipeline parallelism, or being able to pipeline layers and components of your model to be able to speed up training, this is actually an important area overall. So models are getting more and more complex. I think the most recent models are in the hundreds of billions. I know our lab is training on the trillions of parameters, and these are incredibly complex models that take a lot of compute to train. And so the scale of what we're training these days, is on the order of, say, thousands of compute elements. Could be thousands of GPUs, could be thousands of cloud TPUs. But then also, like, large-scale inference is important as well, because these models are incredibly expensive to serve, right? To actually do predictions and applications, and they might actually be large enough to split across multiple compute elements. So you might actually have distributed inference as well. So this overall model scale is something that we're also investing in. And then I mentioned on device. And I think in the last session, somebody also mentioned mobile, and this is a trend that's been happening for quite some time. In fact, I think Facebook has been deploying different types of computer vision and event prediction and all kinds of other models onto mobile phones, I think for quite a few years now, 6-7 years at least. But I think we're like at the point now where we're seeing this as just a piece of the workflow. It's a deployment target. It can be something like for privacy by design, when you talk about when you think about a whole product and how you want to think about where user data resides, or whether it stays on the device, or how things transfer from the cloud to the device. So thinking about the end-to-end workflow, thinking about how to optimize that model for deployment. Again, you're in a resource-constrained environment. And then I know I'm going kind of right to left here, but the unified runtime, I think, is one of the things that we've really tried to focus on. And this has actually helped developers to just use PyTorch and not a separate framework. So essentially, when you deploy a model in PyTorch today, you can actually just use that same model. You will save your model. You might take a few extra steps to optimize it, say like quantize it to do something like 8-bit integer, or you might prune it to maybe remove connections or nodes that aren't contributing to the model, and so on. So it'll kind of fit and be performant on that device. But in the end, it's still the same workflow. So and that's really that's allowed us to really scale this across all of the apps at Facebook, and we start to see really a community start forming around on-device AI externally as well. And then, last slide on investments here. This is a bit of a complex eye chart, but this is kind of just representative and definitely not fully complete. But if you look at, like, for example, if you follow Chip Huyen over at Stanford, she writes a lot on ML ops. And does a lot of analyses on it. And one of the things that we're investing in is really this production end-to-end ecosystem. How do you, for example, do everything from loading and validating data to transforming that data, all the way through your modeling and hyperparameter tuning, distributed training, deploying to either servers or embedded on device, monitoring drift. Pipelining this, doing CI/CD, all of the things that we need to think about these days in a modern production system. And these are areas that we're investing in. So a lot of them are we have a lot of these components today, but then we're also building out a lot of these new components and really hoping to just deliver an end-to-end experience that basically anyone can use and build on top of. So definitely look for more to come here. And of course, libraries. So I mentioned a lot of these libraries already, but whether it's our team or or the community, there are libraries. Basically, if you need something around PyTorch, there's probably a library available. So whether it's things like for ML engineer productivity, things like, again, FastAI or Ignite or PyTorch Lightning, to all of these domain libraries. Whether you need something for NLP, whether you need something for I don't know, PyTorch 3D is a really cool project for differentiable rendering. So if you want to operate in kind of the 3D world and 3D, and rendering 3D objects, you can actually use deep learning in that world as well, which is really interesting, and it's a great project. And I mentioned all the privacy preserving ML. That's a super hot space right now. And differential privacy and federated learning are are really interesting to learn about and actually use. The tools are actually nice these days, and you can actually learn how to deploy this stuff actually reasonable scale with not a lot of effort. Opacus is incredibly easy to use, and you actually train on GPUs with it. And you can actually train a model differentially private, and that tool is completely open source, and it has an incredible community around it. So, what's next? I think we have a really great community. We have an incredibly passionate community. And the things, what are these things we're starting to focus on, for what's next year? One of the things that's pretty interesting, and I know I'm talking to a lot of open source people right now, so you can really understand this or really grok this, is, once your project gets really, really large, it's hard to really engage efficiently your community. So one of the things that we're grappling with is, we have a Slack channel as an example that's been, our go-to for high bandwidth, communication with our most, core members of the community. A lot of our team is on there. Key members of the community, thought leaders in AI, hang out on that Slack. But there's so many people on it. It's crazy. Same with GitHub, of course. We interact on GitHub and issues and RFCs and so on. We also have our forums, and so we're trying to just generally chart better ways to do better distributed communication around the project, because we're not actually that big of a team, but our community is kind of outsized us quite a bit. So if anybody has any ideas on that, I'd love to hear your thoughts. The second is, as I mentioned, ML ops. So this is kind of a buzzword that everyone uses these days. It's kind of like it's something that a lot of large companies have mostly figured out over the last couple of years because they've had to, because they run at scale. They deal with, in our case, we have a platform that has more than 3 billion users on it, and we have thousands and thousands of models in production. We have kind of our own ML ops, but this is something that is not just a problem for us; it's a problem for everyone who really wants to to deploy models at scale. And so our hope is that we can partner and work with either our cloud provider friends or others to really build out the ML ops piece, so that really anyone can deploy and have these tools available to them and have them open source, and you can contribute back to them or build on top of them and so on. Thirdly, really responsible AI is something that I've personally been for the last several years especially on privacy, have been focused on, and more recently in like the last year or so around really ethical AI and things like fairness and bias and transparency. This is something that I really want to invest in, and to me, this is something that is not an option. It's something that is just going to be it'll be part of the workflow. It'll be part of how we develop machine learning and AI in the future. If I fast forward 2 years from now, I absolutely believe this will just be the way things are. And so I want to accelerate that. I want us to build AI responsibly. I want us to have tools that scale, and I want researchers to have the ability to be able to use these tools to basically push things forward. And of course on PyTorch. And lastly, and definitely not least, I want to put the community first and front and center. One of the things that we invest in as much as we possibly can is really to showcase what the community does, the things that they build, whether it's blogging, whether it's libraries. We have a Twitter account that has 150,000 followers that this can be a random person that reaches out to us. We will absolutely showcase their work and help them, bring their work to the forefront, really raise their profile any way we can, because we love just building community. We love helping and helping to grow things. So that is it. Thank you so much. Thank you for listening, and thank you so much for inviting me. And if there's questions, I'm happy to answer them.
Thank you, Joe, for the really for the insight on PyTorch and AI, what's going on for this. I think it's a really good introduction for everyone here. And yeah, we do actually have one question here. So his name is Kelvin. He is asking for you to reshare your slides because he can't seem to download it.
Oh, reshare my screen right now, or?
I'm not sure. You can. So there's the shared notes tab. You can see what he's asking here. The left of the screen, right? He's asked.
I'm not sure. I uploaded my slides. I can.
Hello.
Not sure what he's asking.
Yes, I just want to say hello. I think they are asking for the slide. I think we just give them the link to Eventyr. You uploaded the slide to Eventyr, right, Joe?
Yeah, I did.
Okay, so I just give the link direct to Marcos. The link directly to Joe talk. There will be the slide there.
Okay. Yeah, sounds good. I uploaded the PDF earlier, so.
Yeah. Thank you very much for the talk. Marcus, do we still have time, or we don't have time?
Yeah, I think we actually still have quite a bit of time. The next session starts at like 3, I think.
Okay, so then I think the questions are coming, so we can have Joe a few minutes if you still have time, Joe.
Yeah, no worries.
Okay, so I think yes.
Hello. Hello. Hello.
Yeah, hello.
Yes, sorry. I'm just trying. I downloaded the slides, but it's corrupted. I can't open it. So I think that's the issue here. It's not that it's not loaded, but if I try to click on the slides, it's just unable to open the PDF.
Okay, I can try and re-upload them.
Thanks.
Is it? Did you have a question as well? I can do that offline after I log on.
I haven't really got the chance to look at your slides, and I just got the last part of your talk. So sorry. So I didn't have the opportunity to look into details, right? So once I got the slides, probably I'll just drop you an email or what, LinkedIn, and then we can discuss.
Sure.
Thanks.
The talk will be available online after the conference. We will release the stream today. If Kevin, if you want to watch again, the stream will be available at the end of the day, and this specific session will be released after the conference.
Sure. Thanks, Hong.
Okay, so there's another question here actually. So the question is, I saw that PyTorch and Wisdom are working well together. Could you share a bit more about how other projects are using Wisdom and PyTorch?
Yeah, I mean, I think so. I'm not sure about Wisdom these days. I mean, Wisdom is a visualization library, so it's somewhat analogous to something like TensorBoard. If anyone's used TensorBoard. I would say, generally speaking, like, PyTorch though is used either as a platform to build on, or it's obviously used to author natively, AI. But what we actually really look for is when we see others build on top of us. So whether it's using like kind of the generalized components that we build, and people build frameworks or tools for different domains and modalities, or they will wrap, like for example PyTorch Lightning wraps PyTorch in something that's maybe a little bit easier to configure, and provide some like tools for reproducibility or callbacks or access to cloud storage or different types of features. So so yeah, if you look in like if you go to pytorch.org, you can actually go to the ecosystem page, and you can actually see there's a number of different projects. In fact, I can do some kind of, if you want, I can actually share my screen and show you a little bit here. So if you go to like ecosystem here, there's a number of different projects, and you can see there's different types of tools that people have kind of built around and on PyTorch. So anything from like self-supervision, which is like on the absolute bleeding edge of things, you know, to I think we actually have, let me see. I think we had, so, you know, Lyft created a framework on PyTorch for self-driving cars, essentially. So, you know, it's basically doing like path planning and simulation for self-driving vehicles. That's maintained by them. I think there was a project for let me see, where was it? Where was it? Pretty interesting. There's some really interesting projects in here. So a lot of NLP projects. There's one, I believe, or where was it? Oh yeah, Penny Lane. This is a really interesting one. So for like quantum computing, so you can actually do like, you know, like IBM and I think just a handful of others have like quantum computers that you can then actually run and train models on if you can actually get access to that hardware. But this is actually an open project that basically does, like, for example, auto diff, like auto differentiation on quantum computers using PyTorch. So there's a ton of these projects. And I guess while I'm here, if anybody wants to learn PyTorch, by the way, it's actually super easy. You can go to our site here, and we have a ton of tutorials. And what you can do is actually click on this like Run in Colab, and all of our tutorials and all of our docs, all of our like recipes and stuff are immediately accessible in Colab. And so you can basically set up for free, start executing any of our tutorials. So yeah, sorry, shameless plug. You can actually go in here and start using any of this stuff basically. So I'll go on to the next question.
Yeah, go ahead. Can you see the questions?
Oh yeah, okay. So what is the long-term plan with the PyTorch community? Hopefully it keeps growing. I think, you know, currently, you know, you can almost argue like the first phase was really like growing the research community, and you know, if you look at some of like the top conferences, like say NeurIPS, I think something like 70% or more of the papers with code are on PyTorch. So the research community absolutely is using PyTorch, which is great. You know, the next phase that we kind of saw was production, and really like production and enterprise. And we've really partnered with folks like Google and Amazon and Microsoft to make that happen. And that's, I think, is doing quite well. And I think like I mentioned before, like the responsible AI is like the third phase of things in some ways. Like, you know, we have research, we have production, we have this flywheel of intelligence to product impact, and now you want to be able to build all that responsibly. And some of these areas like fairness are still greenfield. Like the tools are really early days, and people can't even really agree on what fairness actually means, like the definition of fairness. But I think, you know, that's really like where we're trying to take the community. So we want to really grow it in that direction, I would say, in like the next couple of years here.
Okay, so I just want to chime in and say that I checked on the website, the slide, and I was successfully downloaded it. No problem. People can also view it on the website. Okay. Yes. So moving on, I think there is another question, a few other questions. What are the major differences between TensorFlow and PyTorch? I guess you got this a lot.
I get this question a lot, yeah. I mean, honestly, they're both great frameworks. I think, you know, like TensorFlow has done an amazing job, you know, of building a really large footprint, building a lot of production usage. I mean, Google's prolific in AI. Like it's, I would say, you know, the major differences though, like, you know, TensorFlow started, you know, from this kind of static graph approach where, you know, you could basically, you had to do kind of like this meta programming, right? If anybody's used TensorFlow, I'm not a big TensorFlow user. I never used it a lot, but I have used it. And, you know, when you essentially create this, you know, separate kind of Turing complete VM, and you basically meta programming it, you don't have access directly to the model, in other words. And so they kind of went, from this like highly like this path of like, I want to optimize, the heck out of my model because I have the full graph, I know what it is, versus PyTorch, which is like this dynamic graph, like defined by run, which is like, it's really hard to performance optimize because I actually don't know what the full graph's going to be because it's actually being defined as I'm executing it. But it's like much more dynamic and easy to use. And so they kind of came at it from very different ways. TensorFlow has kind of moved more towards PyTorch. In some ways, we're actually moving more towards TensorFlow these days, and defining a path that's more and more static because we know performance becomes more and more important in certain cases. So I mean, the truth of the matter is they're both great frameworks, and honestly, you can't go wrong with either one of them. They both have great communities, but that's really, I would say, the major differences. Oh, who are the leading developers of PyTorch in Asia? Where's your community in Asia? Good question. So we have an incredible, like, we have a like PyTorch.org. We gives us kind of good signal on who's going to the site, but we also have community members all over Asia. So if you go to like our resources part of our site, for example, you can actually see, like we have a Chinese community that has basically translated all of our docs and tutorials and everything. I mean, the Chinese community is incredible. We also have we have communities in Korea as well as in Japan, and they've organically gone and translated everything and created essentially like localized, sites for all of these different regions. And then we have thought leaders, people building startups. Like Richie Yang, I think Richie's now, I can't remember if he's in Singapore or Hong Kong these days, but he'll be speaking at our ecosystem day next month. So like, yeah, I mean, we basically, I would say between China, Korea, and Japan, I would say those are like the hot spots for us. But truly, PyTorch is pretty much everywhere these days. So. Are there internship opportunities to PyTorch projects? Sorry, yeah, go ahead.
Yeah, so I just want to read out the question so that the viewers, we also stream this video. Are there internship opportunities in PyTorch project? Do you have a coding program for students from Asia?
I know Facebook has internship opportunities. I would need to dig up the link and figure out the timing of internships. Our team does take on interns, but I need to figure out the next cycle of when we're accepting applications. Do we have coding programs for students in Asia? Not that I know of, although I know in Korea we do have a team historically that does work with developers, because we did do some events in Seoul a few years back, but we ourselves don't really do much in Asia. We'd love to, but I think at the current time we really don't.
Perhaps you can collaborate with FOSSASIA. We can do some program together if people really want to have coding program for students.
That sounds fantastic. We'll talk after, Hong. That sounds great.
So I think that the next question is somewhat related to the previous panel. Do you have any women in your team?
I do actually. Well, in my team specifically, yes. I have a product team, and absolutely. Our team, our engineering team is actually led by a woman, Lin Chao. She leads a very large engineering team. So yes, I think we have pretty good diversity, I would say, on our team. So.
Okay, thank you. So I hope that people are happy with the answers. TensorFlow has distributed machine learning strategy API framework. Each PyTorch has the similar, and this is from Jun Yeo.
Yeah. Let's see. I see the previous question about of distributed communications. Yes, good first issues is absolutely a wonderful idea. I love doing that. I love defining issues that provide like really nice entry points for people who are new to your project. So, +1 to KN there. Yeah, to number 9, absolutely, we support distributed training. So we have a torch.distributed data parallel APIs, which are probably pretty much the workhorse for distributed training. We've scaled models, very, very large models using those APIs. The next wave of APIs we have are around remote procedural calls, or RPCs, and those are being used, for things like model parallel or really large, like language models and transformers and so on. And so if you look at the torch.rpc framework we have in pytorch.org, you can kind of get an idea. Although those are pretty advanced APIs, they're not really that easy to use. So we're working on a more abstracted version of that. But absolutely, like distributed training is a core piece of PyTorch. Let's see, how many full-time Facebook staff on the PyTorch team? I actually don't think I can tell you on that. It has grown a lot though. It started very, very small when I first started, and it's grown significantly. And it's grown because the project itself has grown in importance, and we've realized the importance of building community around the project. Yeah, I can't tell you exactly how many. I think I'd get in trouble, but absolutely, it's now a pretty large team, and actually it's growing pretty fast.
Question number 8 is still open. I thought that did you already answer number 8, Joe? Do you have any advice for someone who'd like to get started as a contributor?
Yeah, I think I think the good first issue is is absolutely. So we actually have a nice getting started or like contributor guide on our website, on our GitHub site. So if you go to like github.com PyTorch, you'll see, you'll scroll down, you can see how to contribute. We do have like good first like issues or small features or things that are very clear that somebody could like jump in on. So this is something that we pride ourselves on, because this is how we've actually been able to grow essentially our community of contributors from maybe a few hundred to now like almost 1,800 at this point. So
thank you very much. And I also want to announce that later on there is a workshop on Cornea. It's also PyTorch related project. There will be a workshop. Joe, do you know about this project, Cornea?
Cornea, absolutely. Edgar, yeah, absolutely.
Yeah, so he's giving a workshop later. Yeah, so this is also for the audience. If you are interested to learn more, please join the workshop. Okay. Okay, so I think people are continue to ask questions about your team. Are you working remote, working in the office these days, or fully distributed?
Oh, yeah, so my team is all remote right now. We're not back in the office. I'm in Menlo Park, California, and that's where a lot of our team is. But we also have teammates in Seattle, Washington. We have a large team in New York, in kind of Manhattan area. And then we also have teammates in London and Paris. That's kind of like where all my teammates pretty much live. So, and they're all working remote from their homes at this point. So hopefully we can get back together sometime this year, because we love to hang out and yeah, grab dinner or do stuff together. So we haven't been able to do that for the last year. So.
Okay, so I think this is all the time we have. We also need to get ready for the next session, but thank you very much for your presentation, for answering all the questions. And I believe that you said in the beginning that you would visit us in Singapore or in Asia, right? This is related to question number 2. Yes, so we are looking forward to welcome you hopefully next year at the FOSSASIA Summit in person.
That'd be great. Thank you so much for having me.
Thank you, Joe. Anything else from you, Marcus?
No, not really, no.
Okay, good. So we covered everything on the channels. Thank you very much.
Awesome. Take care, everyone.
Thank you.
Cheers.
Marcus, do we get ready for the next speaker?
Yeah, the next session is at 3. It's
Okay, so good.
Nikolay Shimirev.
Yeah. Okay, so I leave it to you then.
Okay.
Yeah. Thank you.
Okay, so everyone will be taking a bit of a short break now until 3 p.m. So there's like 10 minutes break. Next session is on modern open source speech recognition. So yeah, if you're interested in that, you can wait. You can just wait for that at 3 p.m. So yeah.
Okay, so since we have 10 minutes in between, I'm gonna show you quickly what are the projects we have in the exhibition. I'm gonna share my screen, and we can look, take a quick look together to see what can we learn from the list of the project. Here is my screen. I hope you can see it. And I'm gonna go here from the side panel, go to the exhibition page. Okay, so here on the exhibition page, we have different projects and also partners. I think there's a lot of job career opportunities from the sponsor and also from the partner. They are looking for developers. As I see some question on the chat, if you're interested in job opportunity, you can go to visit one of the exhibitor. So this is OpenTab, is an open test automation project. They already have a few presentations here at the FOSSASIA Summit. Actually, if you go to the exhibition page, you can find more information, and there's also the link where you can connect with the project. The project is on GitLab, and the website is there. If you're interested, please go there and take a look. We also have like Red Hat. I believe that they announced that they are hiring. There's a lot of jobs opportunity at Red Hat, and Harish is here throughout the conference to answer questions. If you have any question, job opportunities, or learn more about different technologies and solution of Red Hat, please go there. So basically, this is the first time we run this virtual exhibition. We want to provide as much information as possible on the page for you. You also find like the contact page where you can get in touch directly with the company. And later this weekend, Harriet will also give a talk. Here on the side, you see all related session of that booth, and more information, please go to the page. Let me continue to go next. What do we have? And we also have a number of user group and communities in Asia. We have Open Stack community. We have Golf Taiwan, who presented already a few days ago. We have Open Robotics. They have multiple workshops and sessions here. If you want to learn more, you can just go to their page. They will have a link to their project, their software framework, if you want to get started with Open Robotics. And again, similar to Red Hat, they also have opening job opportunities there. We have our partner, the Open Source Business Alliance Europe. So they have over 170 member companies that generate more than 1.7 billion euros annually. So if you are a company that doing open source and want to understand how to make business with open source, you can visit the page and learn more about the work of Open Source Business Alliance. And of course, we have our partner, also Cloud Native Computing Foundation. On GitHub, you will find a list of open source projects released by Cloud Computing Foundation, and it's really good for companies and developers who focus on DevOps, cloud, or continuous delivery and iteration. There's a lot of good tools, also many more monitoring tools that release under open source, under CNCF. So it's also good to learn about them. And for people who are curious about, who are in Singapore, we have our partner Lifelong Learning Institute, and you see already that we announce throughout the conference that there are program trainings, and also we're really glad to hear the support from the government if you want to improve your skill through the session we had this morning. So go to the website of Lifelong Learning Institute. This is a page you can learn more and also find out how you can get like your training funded by the Singapore government. Okay, so I think we have the next speaker here already. Hello, Nikolai.
Hello, hello, Tom.
Sorry, I did not see you, so I just tried to show people the exhibition. Welcome to FOSSASIA Summit.
Thank you, Hong. I'm pleased to be here.
Over. Nice and nice to meet you too. I'm going to hand over to Marcus. He's going to be the moderator for this session. Enjoy.
Hello, Marcus.
Again, welcome.
Hello. Would you like to upload your slides now? I just gave you the presenter, right? So you can.
Yeah, I'll share the screen. I think
Okay.
there is an issue with the slides. I'll just. Where is the screen? Yeah, share the screen.
Yeah, I can see it. Yeah, I think we're good. Yeah. We could wait like a minute or two first.
No.
So for everyone who's just joining, this this session is on modern open source speech recognition. This is our speaker, Nikolai Shimirev, and yeah, he's here to give a talk about that. Actually, I think we could just start now, maybe, if you're ready.
Yeah, I'm ready. Let's start. Hello, my friends. I'm very pleased to see you here and give a talks about things we are doing. So this is really exciting topic, and unfortunately the talk is really short, but I wanted to cover the current state of the open source speech recognition and the basics, what is possible.
Mr. Nikolai, actually, I was going to give you a quick intro, but maybe I could give you a quick intro to everyone here first before we start. Okay. Okay. So for everyone just joined, this is Mr. Nikolai Shimirev. He's the CEO of FOSSASIA. I think that's how it's pronounced.
Yeah.
So Nikolai has been in open source speech since 2003. He worked on speech recognition, text-to-speech, biometrics, and many related areas. These days, Nikolai leads a popular open source speech recognition toolkit, FOSS. So, Mr. Nikolai, yeah, you can continue from here.
Yeah. So about us, we've been in open source for quite some time. We've been working on the popular festival TTS. We worked on a very popular CMU Sphinx project which implemented speech recognition on mobile devices and kind of set the standard for open source speech. Unfortunately, Simulink technology is getting outdated, and these days everything is about neural network, and we worked extensively on the neural networks like Caldi and other neural network TTS. And these days we are working on the VOSC toolkit, a toolkit for the speech recognition, the main goal of which is to provide accessible and easy to use speech recognition on a variety of the devices. So a little bit more about VOSC. VOSC supports 17 languages. You can see the list on the slides. It's pretty extensive, and the list of supported languages is actually growing. I think we have something like 30 languages in the plans, and eventually we want to cover all possible languages in the world. You know, there are more than 5,000 of them. We provide easy installation with Python, with Node, with the NPM, with NuGet for the C#. We provide the Docker containers for the servers. So installation of the VOSC is really straightforward. And we hope that we put a lot of effort of making it straightforward. VOSC also cool that it works offline. It doesn't require any internet connection, doesn't send any data. So it can work on the Raspberry Pi, on lightweight mobile devices, on the Android, on the iOS. You know, there are also integrations with Sailfish, other mobile OSs, and of course it works on the desktop too. Cool things about VOSC that the models that we use for the languages are very small. They are just 50 megabytes, so they can be used in the mobile applications, and they can be used in desktop applications. People do not have to download loads of data. But we also have a big models for the servers, because it depends on the size of the model, you can get better accuracy. So for the servers, we have very big model which integrated a lot of knowledge. We also provide the streaming API, which enables real interactive experience for the users, something that we will talk about later. We allow to reconfiguration of the vocabulary to improve the accuracy, and support many nice features like speaker identification, something that is not something that is accessible only in the research toolkits and not in the public APIs. Of course, there are things that we are working on. There are still, you know, some issues we would like to solve. One of them is the limitation with the vocabulary. Unfortunately, the technology of VOSC is made this way that you cannot easily add new words to the vocabulary. There is only a precompiled list of the words that you can use. We use pretty big lists for different languages, up to 1 million of words, but sometimes it is not enough, and it's a little bit of the problem for our users. That's something that we work on. And another frequent request is support for the keyword spotting, something that you can say, okay, Google, and activate your application. That's one of the frequent requirements, and that's something that we work on. Hopefully, we will have that in the near future. But overall, in this presentation, I wanted to talk about overall speech recognition, because as you see, it's a huge effort by many institutions and many organizations, and a big community of the open source developers and big community of the researchers. And it's not really about VOSC, but overall how the technology develops, and how the best experience for the communication with the computer is implemented in the modern world. So the situation about the AI and speech recognition is pretty, you know, pretty well known, that this decade is the year of the neural networks. So everything changed when the neural networks were introduced, and it enabled really good accuracy of speech recognition. It enabled really good speech synthesis. It enabled shift in many other domains related to voice, and not just related to voice, related to video, to everything. So it's all about neural networks applied everywhere, and essentially providing almost, artificial intelligence like experience for the users. So they can recognize speech, they can synthesize their voices, they can use efficient voice conversion, they can identify voices, they can identify emotions, and many other things. What enabled this neural network revolution is an enormous amount of the computation and very powerful computing devices that made available mainly by NVIDIA, but also available by many competing companies. So everything changed with the hardware when we have those GPU video cards where we can process enormous amount of data, combine it, compute the averages, and create the neural network models that are very accurate. Unfortunately, there are downsides of that. The downside is that the computation like this is really expensive, and it's not really accessible thing for the small open source developers or even a small research institutions. So Google, for example, develops their own devices called TPU. NVIDIA has their own products of special servers with hundreds of video cards. And using these devices, using these supercomputers, major corporations create the best models processing the knowledge all over the world. Unfortunately, the cost of this is pretty high, and this is one of the current limitations we see in the artificial intelligence. Essentially, the research that can be done is mainly done by the big corporations, and smaller developers can only use what the big corporations produced. Because, even training a simple, powerful model these days, it can cost millions of dollars, and that really, huge scale that is mind-blowing. So this is the world we are living in. Also, the technology that we are working on, the voice technologies, develop very quickly. Here you can see the progress of the neural networks and the architectures that appeared over the years, and each one changed the situation drastically. Each neural network that listed here totally redefined the quality of the results and redefined the accuracy of the speech recognition, the quality of the voice synthesis, and redefine the capabilities, the computing power too. So you can see almost every year there appears a new framework. Usually it's a framework developed by the big corporations like Google, Facebook, or DeepMind. And essentially everything changes every year, and you need to stay on the top of this technology and follow it. That's why there is a variety of approaches, variety of the packages, and variety of the software platforms doing voice recognition. And we will try to cover some of them and try to understand how to use them and how to properly identify what is required for the voice application, what is required for the end users, and what is important. Another aspect of current AI development is that data is not an issue anymore. There is so much data around. There is a web data you can crawl. There is a partial annotated data for the users. There is a parallel data like video combined with the text. There are parallel languages, like there is a data for the French and data for the German. So you can reuse them both to improve the accuracy for both the French and German, for example. So there are also algorithms to work with the dirty data. It means that you do not need to prepare the accurate databases anymore. You can just, dump all the collected data from the internet, and your system will learn simultaneously. It will learn both to recognize speech, recognize video, recognize text on the video. And from those cues, the system can kind of cross-learn across different multimodal domain and produce accurate models. So there are terabytes of data, and even for the speech, the recent databases are hundreds of thousands of hours of speech, and that enabled also the great accuracy and the great results of the speech recognition system. Unfortunately, it also complicated the algorithm. Like I said, you need to implement proper algorithms to work with the dirty data and work with the data in a semi-supervised way. Of course, there are still issues with the accuracy. There are still problems with the microphones. There are problems with the background noise. There are problems with unknown words. For example, not all the speech recognition systems recognize unknown words. For example, you can try TikTok on many popular speech recognition systems, and you'll see they probably have trouble to recognize it just because this word appeared last year. Of course, there are still problems with the integration. The APIs are not stable, and there is no standard API to use. But that's something that speech community is working on and hopefully will solve. So given what I said, there are essentially no single toolkit one can recommend for the speech recognition. Because of the technology development, the fast pace of it, and the nature of the algorithms, there are dozens and even more. I think about 50 different speech recognition toolkits developed all over the world. They're all open source. They claim the speech recognition capabilities, and it's really hard to kind of understand which one to use. To name a few reasonable toolkits these days, one is Caldi, a popular speech recognition toolkit, which is kind of old and mainly supposed for the academic use, but still very powerful, as we consider later. There are great toolkits from NVIDIA and great toolkit from the Facebook team, which are also mainly researcher-oriented, but at the same time, they are very capable in their features. There is a nice toolkit from the Mozilla, which is recently rebranded to, which recently forked and rebranded to Coq. Then a nice toolkit released just last week from the Canadian research institution Mila called SpeechBrain, which claims pretty great capabilities. Nice toolkits from the Chinese companies like Didi, Mobvoi. They all produce great toolkits. One of them is VNet, which is unique for the streaming capabilities. So essentially many nice toolkits there providing speech recognition capabilities, and how to understand which one to use and which one is reasonable and which one is important. Essentially, what I wanted to tell is that there is no single toolkit that provides all the required things these days, unfortunately. To use toolkit and to understand what is possible in your application, you need to understand the features, the side effects, and the internal things in every toolkit to figure out what is possible with this toolkit, and what are the strong side of these toolkits, and what are the disadvantages of using these toolkits. Unfortunately, of course, most of this is not really documented, and sometimes to use the toolkit properly, you need to understand not just the API, but also the technical limitations of the algorithms, configuration parameter of the algorithms, and related things. Okay, let's go through the features, and let's consider what is different about the toolkits. First feature is accuracy. You can compare the engine with, which is more accurate on your task. But essentially, what I wanted to mention is that mostly accuracy is related to the amount of the compute and the amount of the training data. Given the big amount of the training data, like I said before, you can get a reasonable accuracy with any toolkit because they essentially use the same neural network architecture. What is important is that you should be able to use the great amount of the compute, and you should be able to use dirty data. And unfortunately, these capabilities are not supported widely. There are just a couple toolkits that support dirty data training. Those are mainly Caldi and the Flashlight. Other toolkits do not support dirty data training, and that's something that you need to consider when you choose the toolkit. Other feature is the language support, and again, here it is important to use pre-trained models because of the compute limitations. Facebook already provides very accurate and pre-trained model for the multiple languages, which are kind of very expensive to train. That's why it's really important to have the capability to rely on the Facebook models to get a great language support. Again, not all the toolkits support semi-supervised learning and use of the dirty data, and that limits the amount of the effort required to support multiple languages. One of the reasons we support so many languages is that we can use the dirty data, and we can use unsupervised learning to implement the support for every language. Other features are reliability. For example, ability to handle unknown sounds. That's something that is provided with the keyword sporting, but also might be implemented in the toolkit itself. There are also things like ability to correct the results, ability to explain the results. Those are not yet supported by many toolkits, but it's still a research problem, and hopefully in a near time we will see this feature in one of the toolkits. So you'll be able to say that you recognize this word incorrectly, please fix that, and the system will be able to learn that. This is an important feature, but not yet so popular among the toolkits. Third feature is latency, something that is not frequently considered, but very important for the user experience. You need to produce the recognition result very quickly. You need to respond within a second or even less, so the user doesn't have to wait for the results. To provide the great latency, the toolkit should support streaming recognition. The toolkit should support hypothesis stabilization, and essentially a missing point is also the TTS, which can create results in a streaming fashion. Something that is not yet available for the open source, but something that would be really critical to provide a smart assistant. The thing like hypothesis stabilization is also not really widespread in the toolkits. That's something, for example, unique in a Caldi that you do not have in other toolkits. So essentially, when you recognize speech, you can get the hypothesis as soon as user said some words, and you can make decision based on this beginning of the command. That's something that is not available in the deep speech, for example, or that is not available in the Facebook, and something that is really critical to implement a smart assistant. Then the feature of the speaker identification, something that is already present in the commercial smart assistant like Amazon Echo, but something that is critical for the open source toolkit too. It's important to identify the speaker and be able to identify the speaker even from the short recordings. When you say, hi Susie, hi my assistant, it should learn that it is you and not someone else. And this feature is really critical to provide enough security and provide more human-like communication and related things. Of course, the simplicity of the code and availability of the documentation is important. Here, something that the new modern toolkits have advantage at. They support popular PyTorch framework, and because of that, they're easy to start for the newcomers. Then the reconfigurable vocabulary, something that is important. Some toolkits have a problem with the reconfiguration, like Kaldi. Some do not have that. Some can recognize unknown words on the fly, so you can say the word and the system will learn it. So concluding this, I can tell you that there is no single toolkit that provides the full set of the important features these days. It's more like you have great things here and great things there, and you need to be able to understand them and combine them. And also, application is missing. There are many basic voice assistants, but there are no really great and really advanced voice assistants compared to Amazon Echo, for example, implementing all the features that I mentioned before. But that's something to work on. If you understand the capabilities of the open source technology, you can create a really, human-like application and really interesting voice interface for the, for the home assistant and for many other use cases, because use cases of the voice are really enormous. You can apply it everywhere, from shop, from smart home, from the factory, essentially in many, many places. That's essentially it. That's something to work on, and hopefully I gave you like a very quick overview, and you can look more on the details of what is going on. Feel free to catch me on the internet, ask questions. I'd be happy to answer them. We have a big community on the Telegram. We have the GitHub. Now, I will also hang on the Gitter, so you can catch me and ask me if you have something to learn about speech, and if you are interested in the recent speech developments. That's it. Thank you.
Okay, thank you, Mr. Nicolai, for the interesting presentation. Yeah, so I'd just like to ask if there's any questions for Mr. Nicolai here. We still have a couple of minutes to spare here. You can use the chat notes tab to type in any questions if you want. Currently, there's not actually any questions, but we can still wait for a bit. If anyone wants to ask questions live and unmute your mic, you can do so as well. In the meantime, Mr. Nicolai, if there's anything else you want to share, like any shameless plug or anything, you can do it now if you want.
No, I wanted to thank you, the auditory, and I know there is an interest in VOSC and related speech technology. And from Michael and from Mario, thank you for inviting me here. It's kind of, it was really short preparation, just a couple of days, but still I'm happy to present this thing, and hopefully, as you see, this is a very, very active and very interesting area of and very hot area at the same time.
Yeah,
there is, you know, so much things to work on, many things, and it's really, you know, artificial intelligence is hot. And if you are interested in starting with artificial intelligence, speech technology is something to play with for sure.
I saw Michelle typing some comments there. I wonder if he want to come in and just comment himself. Did you see that, Nikolai?
It's okay.
On the chat.
Thank you. Thank you. Thank you, everyone.
Yeah. So, hey, Nikolai. So, thank you so much. It's really exciting to see this project and also to learn about your insights. So, I'm definitely very happy. And yeah, maybe we have like a couple of minutes left. So what do you see as the overlap, for example, the SUSE AI project or our other projects like so far? Is there, or what do you think generally? I mean, there are a few open source assistants, but as you said, there's nothing comparable to the proprietary system. So where do you specifically see the opportunities?
I listed quite a few features that we need to implement, and yeah, we need to work on them, both on, you know, on our side, on the technology in the VOSC, and on your side too, to support all those features in the assistance. So it's kind of hard work ahead.
Yeah. And my question is this, like, how do you think we can overcome the challenge? Of course, like Google and Amazon and so on, they have like kind of unlimited resources compared to us. So they can just employ like, you know, hundreds of engineers. And of course, we have the open source community. However, like some resources are needed. What's your roadmap? I mean, like, do you think we can cooperate, for example, with some manufacturers to make like small kind of devices, or what's your idea?
Yeah, absolutely. We of course need to, you know, move small and implement important things and focus on what is important. But I see no problem. You know, all the great technologies are implemented just by the team of 1 or 2 people in practice. So it doesn't matter how many engineers you have. In the end, it's always 1 or 2 people who need to do that. So yeah, let's work on that.
Okay, that's a great final work, and we continue the conversation. It's great to be in touch. By the way, where are you based? In Russia, apparently, but where?
Well, we recently moved from Moscow, from the big city. We moved to the small rural city called Kostroma. It's on the Volga River, and it's pretty nice, you know, rural village area. So
yes.
Yeah.
Very nice. So you are a great link between Europe and Asia, and I hope this will be like, you will be continuing to do this, and like we make a great, like our own kind of road between Asia and Europe, and Russia is the great unifier. Yeah.
Thank you. Yeah, exactly.
Okay, well, thanks a lot, and we keep in touch. It's great that you could like make it on such a short notice, but it was really interesting, so we were excited to get you into the program here.
Thank you. Thank you.
Thank you. Bye-bye.
Bye.
Was we done? Yeah.
Yeah.
Okay, I think the next speaker is already here. Mr. Alvin Putrevu. You can unmute yourself and yeah, hi. You can. Yeah.
Yeah. Hi, Marcus. Hello, everyone.
Hi.
I'll just turn on my video.
Yeah.
Okay. I hope you could see me.
Yep, I can see you.
Perfect.
Let me give you presenter rights.
Yeah.
Okay.
Hello, everyone. I think like it's my fourth time at FOSSASIA, and I'm really glad that to meet all the good friends back here. Unfortunate that we couldn't, meet like all the time. But I wish that we could all again do a great open source event or a FOSSASIA summits very soon. Yep. So I just share my screen.
Okay.
So
I'll just give you a quick intro first before we start.
okay.
So everyone just dropping in now. This is a session on crawl code search, a new way to build search. So this is a talk with Mr. Arvind Putrevu, and he's a senior developer advocate from elastic.co. So Alvin is passionate about evangelizing technology, meeting developers, and helping solving their problems. He's a backend developer and has 9 years of development experience. Currently, he works at Elastic as developer advocate and looks after the developer relation function of India, Southeast Asia. Previously, he worked at McAfee Antivirus as senior software engineer in cloud security domain. So yeah, Mr. Alvin, you can continue from here. Mr. Alvin, you are muted.
Okay, I guess you can hear me now.
Yep, I can. Okay.
Great. You can also see my screen, right? It's full screen now. Marcus, can you see my screen?
So yeah, it's working.
Oh, okay, great. So thank you, Marcus and Hongfu or Mario, everyone, like our volunteers who help set up this event every year. It's like an annual, pilgrimage to me to come to FOSSASIA, meet all the people. This is my fourth time as an attendee as well as a speaker. I spoke at multiple places, multiple topics I spoke. I meet all the different, community folks from different companies and all. I'm really glad, and I'm also sad that we're not doing this online, but we would definitely go ahead and like kind of do an in-person event very soon. That being said, the topic today I want to cover is about how do you build a search experience also by kind of like, using a crawler, using, by crawling the code, crawling and building a code around it, and then also providing a search experience. So I'm going to take an interesting example, but I also will show you some things that you could probably like, we'll cover the theory part and then we'll come to the thing. So in the interest of time, because it's a very small talk, so what I have done is like I'll create a cloud deployment, and then I also have a backup deployment just in the way like if demo guards wouldn't help me. So this is a simple UI. So forget about it if you are like, if you couldn't like, get it very quickly, but then because in the interest of time, I'm just trying to create a deployment, come back to the theory, and then again we'll go to the code and we'll look after everything. Okay, so basically I'm creating a search deployment in Elastic Cloud, and we'll name it as FOSSASIA, and then I'll click create deployment. You could also customize this, create how much you want, etc. You could also create it with the API or a Terraform module. But I'll just simply go and create deployment. It will create it while we complete this particular presentation. So basically, I'm Arvind. For those who don't know me, I work as a developer advocate at Elastic. I'm an engineer. I love speaking to developers. I love helping the developers. I should also say that I'm an average engineer who's trying to make an impact and help people in the way. So that's how about me. And then you can find more about what I do, what are the projects that I take part, like Kubernetes, etc. in my Twitter handle, etc. So the agenda is why search, how to build search, and I'll try to explain in quick terms, and then like I'll also share some resources. The code is on GitHub, so don't worry, you don't need to note anything. I'll also explain parts of the code, etc. So it's also there. So all that you need. I'll also tell you how you need to download and do all of this. So that is there. So, but why search? Why is it so important, right? So when you go to say, I think some of these are a bit Indian specific, but then like if you see some of these services like Deliveroo or all this Go Food or Grab Food, or a lot of these regional places where you kind of like search for food or search for groceries, or you might be searching for really code on GitHub. End of the day, whenever you go to an app or any experience, you're literally searching for it. Search is a fundamental piece for all of us, even though we don't really realize that. I realized that a bit later into my career. I realized that, okay, I'm really searching most of the time. I'm working on search most of the time, and more than writing interesting logic. So and also, like, you have more interesting search experiences everywhere in every site. For example, if you go to Stack Overflow, or most of the time we might be like coming to a specific question from from Google, but then otherwise you could also go and search in Stack Overflow, or you might be looking at dev.to, and then you might be searching for a specific sort of different articles, or very well you might go to PyPy, and then like you might be searching for a specific package that you want in the Python. So search is like omnipresent. It's there all the time, and it's what you run a lot of things using the search. But how do you build that? How do you build a large scale search engine, or like even at least for a small side project that you are probably building? There are very good open source tools. One of my colleague has written a fantastic blog post. I'll share this in the chat later, about a list of several open source projects which are free and open source projects, which are definitely like which comes at like small to very large scale use cases. If you see something like meal search or a different search libraries that are there, you could definitely go and look at that blog post. I'll share you that. But also, like, you might see veteran projects like obviously Elasticsearch. It's a free and open largest search engine that is there, and you could simply go and download that and build. The only thing that you need to know is, like, it is a massive thing, and then you might need to really know a bit of like backend dev knowledge, and then like you need to learn a lot of this. But I've been dirtying my hands with a lot of front-end tech recently, and from the last 6 months or so, and then I really feel that it is sometimes difficult for a front-end dev to kind of like become handle everything around a distributed system and look into all of these things. So sometimes it is not easier search. So on top of Elasticsearch, and then does all this handling again free, and you could download it, you could run it anywhere, you could run it in Kubernetes kind of environment with Elasticsearch. In fact, actually you have a Kubernetes operator through which you could run Elasticsearch and AppSearch as a side by side, and when you can scale both of them. So that is the premise, and then but the idea is to create a easier quicker search experience that is friendly towards the UI, and makes it pleasurable for people to do it by just limiting all of this relevancy part. I'll show that what relevancy and everything I'm talking about. So to come back to the basics again, AppSearch is not new. AppSearch is built on the same stack. It has the same search backend, which is the same stack, which is Elasticstack, and it has on the same search backend, which is Elasticsearch. It runs on any cloud on your data center. You could host it on your, Raspberry Pi, even if I think Pi 4 has a cool specs. So you could do all of that, and it's quite easy to do that. So I just want to like cover 2 slides about architecture, and then like we'll go back to the demo part. So if you see here, I have architecture without AppSearch, like how many people were building AppSearch right now. And I also will show you what it means, like if you have an AppSearch server, and then you have the same sort of clients or your app to consume in your application. be it Python or like, Ruby or all of these clients. And then like you could connect to App Search Server and then like, Elasticsearch easily. So, but then that brings you to the question, like, I need two things. I need to run two things now. Is it like overloading what I'm already doing? So definitely yes, but not so difficult. So I'll tell you how this entire thing works. So before getting started, so what I'll do is like I'll show you where you could download this. So if you have any questions meanwhile, so please keep it in the chat. I'll come back and then we'll take it. So you could go to elastic.co/downloads and then like you will see Elastic obviously, and then you also see this app enterprise search. So don't think enterprise search means as like paid version or something. The name of the product itself enterprise search, because enterprises want to use some sort of like search appliances inside. So that is the reason it's enterprise search. You can download. There are instructions how to get started and various stuff. So enterprise search is like a bundle. It contains two things. One is workplace search and another is app search. Both are different search variants. I'll show you how what it is different, how it is different. So this is a deployment that I have created previously. Now I have showed you the downloaded version that I could run on the laptop. I am not doing that because I don't want to put my Mac on fire. So I just want to like use the cloud version for the time being and showcase you everything in a cool manner. So if you see here, like in the cloud, you also already have this getting deployed, and it deploys this Elasticsearch Kibana. So all these UI parts will be moving to the Kibana, and then you will see everything in Kibana. But for the time being, there is a separate UI that is built up specifically to manage this search engine. So when you click on this enterprise search, you will see these particular things. I'll click on launch app search. I'll quickly navigate to this if you are feeling like, oh, it's a lot to consume. Don't worry, I'll quickly navigate, and then you could always, I'll give you resources where you could always go and look into that. So here you create a search engine. Unlike your Elasticsearch, you don't create an index, you create a search engine. Say, for example, the search engine is FOSSASIA, and I have universal, I click on create engine, and then I have all of these. You could paste a JSON, you could upload a JSON, you could use a web crawler. Remember, this is the same that you get in your downloaded version as well. Just this is the UI that you are seeing in the cloud today. And then you have this, whatever, the local host or something, like because I deployed in the Singapore GCP region, you see all of this. And then this is how you do it with the, the ingesting the documents. There are many things here. But because I want to show crawler, and because it's a new thing, new shiny thing that I really want to showcase to you all, we'll get to here, and we'll use the crawler. You could obviously upload a JSON file. There is some limit, like 10 MB or something, and then you could also paste it. It again like contains some 10 MB. The EBA way. But let us use the web crawler here. So through web crawler, what you could do is like you could crawl a domain and build the search experience. Sounds like Google, but this is for your own website or for your own thing. So how does one crawl a site? Like what makes it different? So for example, how does people do it? So even for elastic.co site, you could go and see robot.txt, which tells the crawlers what needs to be crawled, how it needs to be crawled, and what are allowed and what are not allowed. These are the rules that set by the company. I mean, the site, informing the crawlers not to crawl specific stuff. Okay. Now see here, if you also see something called sitemap XML. So sitemap is something like I'll show you this one. Hopefully this will be small, because sitemap is like how the site looks like in a large scale thing. Like if you see, these are the various links that are there in our documentation. I mean, for each, and it's like a sitemap XML that is there, and it carries a lot of details, etc. So it also shows like what is the change frequency, what is the priority. So using crawler, the data keeps in sync, and we pull all the data, and when you update on your site, we keep pulling the data from the site, and like we keep it fresh. So now what site I'm using to crawl, and is it permissible to crawl anything and everything? Might be not, because not all the sites allow you to crawl everything. Thankfully, today we have GitHub CLI. I chose this one because specifically the reason we all use Git, and it is very easy for us to relate to what I'm trying to build. So that's why I chose Git, and that too GitHub command line. I tried GitHub SCM documentation as well. It's a bit tricky. I also crawled. I'll see if I could show you that as well, if the time permits. But otherwise, I have this cli.github.com. So what it contains is like the manual for the GH client. So the various commands, etc. But do you observe there is no search bar? And this is a simple site. I don't know why GitHub didn't include the search bar. So I took it as an opportunity to create a search UI for it. So what I did is like I just copied the cli.github.com and then I'll paste it here. So you could always like kind of add specific crawl rules. Like say, don't crawl this particular domain. Like see, you can add a crawl rule saying what is what. You could click on this to show what crawl rules are allowed. I mean, how do you design this crawl rule? For example, you could go and see allow or disallow. Like, you know, allow only begins with /manual. And you can save it. Or you could, this also has an ordering thing. So if you have multiple rules and the ordering takes precedence, to do all of that. So this is just about crawling. So I'll just click start crawl and it crawls all the data. So, and then the documents are coming into this particular pane wherein you could crawl this particular site and like the documents keep coming into this area. It takes a while generally. Yeah. So you see more and more coming up. And that's how you need to build. It might take like 5 minutes. It's the site is as small as this. Again, in the interest of time, what I did is like, as you see, I have this deployment that I have created before you. I have already a CLI search deployment, which is created in the same region. And then I would use this particular deployment further to kind of show, because this call will take 4 or 5 minutes. I don't want to waste the time. I have the same replica, which is a CLI GH client I called yesterday. And then I'll just use that to show this particular thing. Now, how do I get started into this project? How do I use this crawler, this thing? So what I've done is like, we already have a React UI experience wherein you go to the reference UI, you select the title field. Okay, I'll log into this. So somehow it was logged out. Okay, so you have this React thing, and then you select all the options, like say meta keywords, etc. Then sort field, nothing, URL field, yeah, URL. So this is a document structure. In the schema, you have this document structure, like say how the document is that is being crawled from the domain cli.github.com. And then the documents looks like this. Like if you go and see, it looks like it looks crazy, to be really honest. You can also massage this data, and you can also tell from the point of if you have this idea of this will be crawled, you could also design it in that way that you could make it better. However, you can still at the end make it better in your search experience. So if I click on generate preview, it kind of like shows me this search UI. So if I say PR, and it also shows me autocomplete, and then like I have this PR thing, and I can click, and then it will take me to the sites where is this there. You could make it inbuilt to this app. Now I'm using a different React app. You could download this package, go npm start. You just open up React app, it looks very similar, and then you could apply the GitHub. I mean, GitHub could apply the GitHub CSS, and then make it very relevant to whatever you have. So that's how it is. It's as simple as it, right? But this is not the end. What if I am not a React developer? What if I am someone who has a Python experience, and then I don't want to do this. I just want to go ahead and do my own stuff. So what happens is like you could build your own app actually. So what I did is like there is API, so you could build your own app. So there is this particular repository that I've created. You could go ahead and like kind of you use this as well. So this is again previous to crawl search, I used to do normal sessions on this particular topic, and then I used to do this. Now I created a special branch on crawl search, so you could go and do this crawl thing as well. So you could simply clone this repo and then like start doing everything. So let me go and do that particular thing. I hope you're able to see my screen, and I'll delete the old. Okay, so that we are good. Okay. Okay. Then, so I hope this is smaller, and I'm trying to make it big so that you could all see. Okay, great. I hope you could see this one now. Marcus, please let me know if there is any problem seeing my screen. I just moved over to a command line interface. I hope it is okay, right?
Yep, you can see it.
Great, thank you. So we went to the test category, and then I'll just do git clone from this repo. So I made it all ready, and so that we don't need to worry about all these things. So I'll do git checkout crawl search, because it is anyway. Okay, first of all, I need to get into that. So I'm in the master. I'll just kind of check out the crawl search branch. So I move to the crawl search branch. As you could see, I'll open the the Visual Studio so that we'll see what is there in the branch and everything. So you could forget this particular, the static and VS Code. I have some statics like in a CSS, etc. I'm using spectrate.css. If you are interested, I tried Tailwind. It's getting some time to configure, so I stopped it there. Then you also have Git attributes, templates, which is a HTML template that I used it. This is a Flask-based app again. And then I have something called config.json. What is this? So let us take a look at this, and where we configure all this data, etc. I have a Docker Compose file. Yes, you could use like Docker Compose to bring it, this application, this thing. If you want to deploy it, I have a Docker file. Use it using like App Engine, container service, Kubernetes, anything that you want. Then this is the main.py. I'm using these three things: the client, and the Unicorn, and then Flask. So you can see here, I have this. I have this main.py, which contains several methods. For the time being, we'll remove this thing that is not needed. And if you see here, I'm opening the config.json, reading the data from it, base endpoint, API key, engine name, and then I have these two methods, which is search and looking into it. So let us go to the config.json and then kind of add all the details that we need to add. So where do I find those details? So, okay, now I'm getting confused. Let me open the right site. Okay. So you have this credentials bar wherein you could find out the API endpoint. In the either case, like you would find probably like the basic some sort of the thing here, like you would be able to like use lost here. So API AS v1. Okay, that is the endpoint that is there. I should add this thing so that like I don't need to add it again here. So generally I could do that, but I didn't. I will as an enhancement. So I have a search key and a private key. As you could see, search key can only search. Private key can read and write. So if you have a specific admin UI you want to write to it, you could also do that using this into the search. So you could update the document or like do all of that. So this is search key, and then my engine name is CLI-GH client. So I write CLI-GH client. So you have all this, and the app search is set now. So this will initialize us with the data. So I already crawled the data from cli.github.com. The data is already in the search engine, and I'm using a Flask app to interface and create a search experience. So if you see here, I have a template.html which contains some card types UI, and I have a home.html which has this pretty simple, very basic, all the ampersand based like Python code here, very little. And then I also have a results page, which is a copy of it. When I click on search, it redirects and shows the specific stuff. That's it. Nothing more than that. So like I'll just simply go to the terminal, install all the dependencies. Oh, before that, I think because it's a new I have to create a virtual environment, VENV, and then I'll name it as ENV. So I just want this to be in Python 3. So now we have created that. This might be smaller, and then I want to make it bigger for you. Okay. I hope it gets bigger. Okay, I hope it is visible. So now you have VNV, like the virtual environment. Let me go to ENV, bin, and then source, activate. It will activate the Python for me, and then, okay. So I'll clear off this, and then we can get started with the pip install -r requirements. So I'll install all the required packages and all the things, and it's also there in the requirements, also there in the GitHub client. So I'll just do Python main.py. So it's not recommended in the production, just need to like be sure of it. And then I have this one particular running in this stuff. Okay, I already have this. So I just have this particular application that is there. I just use this, and then you have got all the data at this scroll. So if I search for PR, right? So I should see PR. If you are searching for, say, like Elias, right? So you have Elias. If you are searching for list, you go to list, and then if you want to like click on this, it will take me to that particular command and details. So this and all is configured. Now the special part with all of this, I guess I'm out of time, but I'll just show one last thing. The special part of all of this is you could tune the relevancy, you could tune, like, say, for example, if I like PR edit is coming, like, but I want more preference to be given to the body content, right? Then I could, like, like increase this one. So that particular this thing will be given more preference, or I could simply turn on text search on that. So it is as simple as it. You could also go to the synonyms and create a synonym set. Say, for example, if you have say, this is again an Elasticsearch feature. Again, it's so easy to use here. So I guess my name doesn't exist in this search engine. So if it is there, I am not sure. Okay, it's not there. So, but if I want to do Aravind, and I want to give like Aravind means PR, okay, and then pull request, and then I simply want to like kind of type every time Aravind, and it want to search this particular PR, I just simply get it. So these are the some things that you could, without restarting your app, without changing anything in your data, you could create a nice search experience by this kind of SEO console. You could do more, like, promote a specific document. You could think, like, in the phone number search use cases, mobile app search use cases, or several other search cases. You could also use this, but this is much easier than your large scale search use case, and it's helpful to do all of this relevancy tuning functions, etc. So yeah, give it a shot, try it, let me know what you think. The code is here. I also have, if you want a guide, a specific guide, like what you are doing, so I have my site here, and then I have a guide for you. So you could go and try to use this. You could do all of that. So that's it from my side, and if you have any questions, I'm happy to take. So remember that one last thing, like, remember that we are deprecating and making it better, the client. So we are trying to add more APIs, better things. So we have a newer client here. So make sure that if you are using that, you use that client. That's very important. And again, it has all of this stuff that we are talking about. Cool. Thank you for the opportunity, and always it's been a pleasure to present at FOSSASIA.
Yeah. Thank you, Mr. Alvin, for coming to FOSSASIA to give your presentation and this useful demo. So yeah, it seems like we don't actually have any questions here. But I guess if anyone wasn't really following the demo just now, you can always check out his slides and check out his guide as well.
Yeah, so what I'll do is, like, I'll just simply paste the I mean the presentation and everything here, so that you could go and like you can do all of that. I'll also paste my Twitter. You can DM me anytime if you have any questions around it. Cool.
Yeah.
Thank you.
Thank you for coming. Okay, it's 4 p.m. So up next, I think right now we are starting on the future search engines and the Internet of Things. So this is another talk, and it will be given by Michael Christen, who is a freelance consultant from Yasi.net. So I think he has already been in chat for quite a while, actually. So yeah, Michael Christen. Michael, you could unmute yourself and turn on your camera now. Yeah, it's been here for like, what, 2 hours already, maybe. Yeah, I think he's rejoining the session. Just wait for a while. Michael, you can try and turn on your camera again. Yeah, hi, I can see you now. You are muted though.
Oh, okay. Yeah, I had to reload the page, so sorry for being late now. I'm so amazed by the previous speaker. He's shown so much practical things in such a short time. I learned a lot. So big applause to him.
Yeah, okay,
Now,
so do you have any
slides? Can I share my
Okay, you can do that as well.
All right, I think they are visible. So in contrast to the previous presentation, this is a more philosophical if I'm talking about search engines and future search engines. So Marcus, can I start?
Yeah, I'll just give you a quick intro for everyone here.
Okay.
So yeah, okay. So this is Michael Christen, freelance consultant of Yasi.net. He's the founder of Sushi AI, Luck, and the creator of the P2P search engine Yasi. So he's a big data engineer consulting for some of the largest corporate players in Germany and on search engine technology. So yeah, you can continue from here. Michael, you are muted again.
Okay. So now can you hear me?
Yeah, but okay, yeah.
Okay,
yeah.
and there are my slides.
Okay,
everything is working. So thank you for inviting me here, and I'm so looking forward for FOSSASIA 22. It will be so nice to and such a kind of festival, if this is possible in 1 year, to meet everyone again. Until then, I'm looking forward to enhance our SUSI project with that amazing WOSC speech recognition. And it just happened some days ago that this came to our knowledge. and it's inspiring us so much, and I will show you why that's so important. I'm talking about future search engines. So the question is, how can this be related to the Internet of Things, and what are we doing in this field? First, I show you a quick demo of WASC, actually. So I pre-recorded the following on a Raspberry Pi, and I read to WASC the following sentences. Future search engines will give answers to all kinds of questions, and instead of a user interface, they will possibly interact with us using a smart speaker. This talk links the aspects of search engines, artificial intelligence, and the Internet of Things. There is a big breakthrough for privacy. Voice can now be decoded with free software on device without any internet connection. So these are the only lines that I'm reading to you. I did this only for the purpose to show what kind of experience it is if you see that you now can do a voice decoding with high quality on device on a small machine like a Raspberry Pi. This was made on Raspberry Pi on this on this device with that microphone that's right here. And we had been waiting for something like this when we started with Susie 4 years ago, or maybe about 4 years ago, because we thought at some time in the future this will happen, that it will be possible, and this is right now. And all the philosophical aspects we explained in the past come together with the idea what a future search engine is and what you can do in your home with it, and there is the idea of Internet of Things. So in the last 20 years, we had been using a lot of different kind of search engines, not only Google and Bing and web searches, but also specialized search engines, social search. You're searching for persons, you're searching for news, for products, and other kinds of aspects, file sharing, multimedia, and so on. So a search experience has been changed from the past, from just looking at web pages to something like what we see now, what Google is producing. If you ask a direct question, then Google is giving you a direct answer. So you don't need to click on the results and read what's on the page anymore. You get a direct answer. You can see this in many examples. A direct answer can also be a video. And this is all something that can be seen also for the general question, what is the search engine of the future? I made a big talk about this topic, and the result was that in the future we are disconnected from all these questions. Is it a web page for a person search, or for a location, or so on? It's just about asking the questions and getting an answer. So the whole experience boils down to this graph. A search is like asking a question and getting an answer from any kind of machine that you can think of. And we know this from science fiction movies, because people had been talking to machines all the time and not doing typing on keyboards. So what you usually do if you're searching for information, then you have a question in mind, then you know what kind of search engine is the best one to answer that question. You select the search engine. Then you are thinking about keywords in your question, and then you type in only these keywords to do the search on that specific search engine. Then you get a result list, and then you need to click on the results and read all the documents, understand the documents, and then you finally have an answer to your to your question. And if you want to put this into an algorithm, then it doesn't work like this, because selecting a search engine is something where you need some intelligence as well. So doing this automatically would mean that you change the process a bit, like this. You have a question, then you select for specific keywords in your question. That means if you're looking for a location or for a person, then you see this as keywords in your question. And accordingly, from these words, you can select the search engine automatically, then look at results from that search, do an understanding, a technical understanding of the content, and give an answer. And what we had been thinking of was, how can this be, how can we do this automatically? And that search engines or machines or computers should act like this is known for a long time. And this is an iconic example where Scotty tried to get an answer from a computer by talking to the mouse. There are also actually these machines which can do this right now. So this is the future as seen from the past, and that future is right now. These machines are actually search engines in speaker form, and they're sometimes called digital personal assistants, or in the market they are selling as smart speakers, because one of their main purposes is to play music. So these devices are decoding speech by sending the speech to the home server, because that was the only way to do speech to text, and then producing some kind of answer, and everything is closed source. And we ask ourselves, where is the free and open source personal assistant, and how can we create such a thing? And therefore, we created what I call the development device. That's the SUSE development device. It consists of, I have one here, it consists of a Raspberry Pi, now Raspberry Pi 4, just with a printed shield on top with a speaker. And then we have a microphone head. This is here. It's put on top of the Raspberry Pi to get a better quality for sound input. And this is able to understand voice with VOSC very well. I did this test by running Raspberry Pi under the table, because the cable was too short. I had to put it under the table, and was still able to understand when I was talking with low voice. So there are other projects which provide frameworks for personal assistants, and they all require coding to create skills. So if you see, look at all these different kind of personal assistant technologies, also for the free software options, they all require that you do programming, either in Python, Java, JavaScript, Node, and so on. And so the barrier to do something in your home, to create a smart home, is it's only possible to do this if you are a programmer, but this should be possible for everyone. So we have been thinking, how can this kind of technology barrier be lowered? And there is a very successful example when the web was new. If you wanted to have a web page, you had to learn HTML. People had been very proud to learn HTML, and I was it as well. So the next step was to make it easier to publish content. And then there came wiki engines, the Wikipedia, and introduced a language which makes it possible that everyone writes documents that can be seen in the web. It's now very natural 20 years after Wikipedia was introduced. But our idea is to do something else, very similar for personal assistants, and it's a markup language for SUSE. I called it the SUSE language of thought. So you don't need programming, and the most easiest example is the Hello World example. This skill waits until you say hello, and it answers with the word world. Susie's skills are always made up of 2 lines only in text. So these text lines, this is the skill, this is the programming language. It's just text. And it's a markup for a skill. The first line is the utterance, and the second line is the answer. And we try to boil down every aspect of skill development to this kind of schema. 2 lines. Sometimes the second line can be more complex. It starts with a bang and then with a keyword showing what kind of plug-in element you want to use. In this case, you can plug in JavaScript and use some variables to compute the result. And then finally, that's the example how the personal assistant is connected to search engines. Here we want to collect the variable for a search term, that's the star, and then we address a search engine, which is a tweet search engine, here our log tweet search engine. And to address an external resource, you need only 2 elements. One is the URL of the API, and the second one is the JSON path to the object that describes the result. And then you can put out the result as an answer, and the answer can be spoken or written. So the development environment needs only a text field, because SUSE skills are simple texts, and we call our development environment a SUSE dream. Yeah, you can tell SUSE to dream about a topic, and what SUSE does is just to look at an Etherpad page. So you write down all your skills into one page or several pages of an Etherpad, and then you tell SUSE just to dream about that topic, so it can answer about these topics that you put in that pad. And it's interactive. You can just change anything on the fly and use it either in a chat window, or you can speak it if you do this on your smart speaker. On that smart speaker, we are running also an Etherpad, and we are running a chat interface, and we are running speech to text and text to speech, and the SUSE server, which is giving the answers. So there's also kind of debugging. You can say explain, and SUSE will explain how it got to the latest answer. It tells you where the skill is, where it took it from, and what it used. Oh, and everything is created by an API where you can just send in a query and you get a JSON back describing how the answer is constructed, and the answer can also be an audio file. It can be a link to a YouTube video and so on. It's not only that you can get spoken answers, you can also get media answers. So the Raspberry Pi is just one element of our ecosphere of elements that we put into the project. We have also Android apps, iOS apps, and so on. But this is for Internet of Things, our most important device, and it's the most amazing thing because of the speech-to-text aspect, which we can now run on device only. We always like to say we want that this is able to travel to Mars, so it must be completely independent and offline operable. So what it does is it takes a question and it gives you an answer. But inside it's not so easy. It needs to understand the question, find an answer, and talk to you to give you the answer. And in detail, it means you need hot word detection, you need speech-to-text, and natural language understanding, maybe a memory and rules how to operate with the memory, so you can ask questions about previous things. It can store information for you that you can tell it. So you can use it to create your personal log. Tell it just to write a log. And then it does text to speech. It speaks the answer. And the connection to Internet of Things is here that you say, this is something in my home. The Internet of Things are devices in your home, and in your home you want total privacy. So we connect the ability to address external search engines together with the ability to address external devices. And we want to do this in the same way. That's the important connection. And devices that are that fit into the schemes are such which have a Wi-Fi endpoint, and that devices that can plug in your home Wi-Fi and can be addressed over an HTTP request. One very good example is the D1 Mini. This is essentially an Arduino with a Wi-Fi interface, and it can be programmed in the same fashion as you can do with an Arduino. And other devices, the Node MCU, it's just in a kind of packaging of the same device. It's also important to know what kind of software is running on this. So it's easy to plug it into the scheme of SUSE. So we created this script that you can put on all these devices, and what's doing is it's generally creating a web server and initializing all the I/O ports. It's selecting some ports for input and some ports for output. And that HTTP server can pass a GET request to set these I/O ports and return a result with the status of all the I/O ports that are inputs. And what you can see here is the complete server with everything. And you can put the same script on all the devices. You don't need to change it for the different devices. You just need to know which kind of ports on that device are input and output. And so if you have things in your home that you want to switch on and off, you don't need to have different scripts. You only need to have this one script. And this is how it works. You can test it in your browser, and it gives you a JSON result with the status of the ports. And that's the skill. So the skill is doing the same as attaching an external search engine. Instead of attaching it to an external search engine, it's going to one of these hardware device APIs. And here we have the example of switching on an LED and switching off an LED. You can also use this with the chat interface. So if you want to operate devices in your home and you don't want to speak at this time because child is sleeping, then you can type in the same phrase that you would say in the chat window that is also provided by the smart speaker on an API of the server. So I have here an example. I don't know if the video is running here. And if you can hear the voice, I can hear the voice right now here, but what I'm doing is I say, SUSE switch on the LED, and then I say, SUSE switch off the LED. It's just a skill that you have seen on the previous slide. And it's switching on and switching off the LED. There are also commercial devices like the Shelly plug, and there's also the Shelly 1 PM, which has a nice ability to measure the current which is going through the device. So you can measure how much power the device is taking up. You can maybe I was thinking about monitoring the fridge because if you open the door and if you close the door, you're using more power, and then it should be able to do a statistics about how often the door is open and closed. So because the fridge is using more power, but it's just a silly idea. So you can do many things. And this is an automatic switch which had a clock inside, and I just took out all the elements and put in this Shelly switch, so you can easily put in this kind of device just anywhere in other devices. So that's my talk. I'm finished. I hope I gave you some inspiration, and I got a lot of inspiration by this new WOSC speech-to-text ability, because this will make it possible that we finally have a complete privacy-aware device at home. So thank you for listening.
Yeah, thank you for the interesting presentation. So we actually have 2 questions here, I think,
Okay.
in the chat notes. So the first question is from Veyron. He's asking, what is the roadmap of SUSI AI?
So the roadmap right now is integrating WOSC, because it came to our knowledge just a week ago that this is now possible. We had been waiting so long that this is possible. We tried to integrate deep speech from Mozilla, and it was too resource intensive, and the error rate was too high. And I was so amazed when I did my first try and spoke to the device with a small model, and it was completely right. It got every word. The complete sentence was completely right. I was so amazed. So the next on the roadmap is integrating WOSC and presenting then complete privacy-aware in-house appliances. But if you want to have this in your home and want to disconnect it from the internet, then you need to put knowledge on top. And here the presentation of Aravind is relevant for this, because he presented how to acquire knowledge for yourself. You can create a search engine for a specific topic. You can collect knowledge and then attach it. So the next step would be to have a whole catalog of knowledge providers that we can put on the device. So you can create appliances that provide knowledge for you with sources that the community created. So this is inspiring altogether. and then it creates the device that can travel to Mars.
Okay, we're starting to get more questions now. So another question is, what is your plan with the Android app of SUSI AI?
Oh, I don't know. I've seen that WOSC is also available for Android, and that it runs on all these devices. So maybe we put it everywhere.
Okay, next question. I participated in some SUSI AI meetings a few years back when you discussed to set an alarm and play music. What is the current state of such features?
The alarm feature. Yeah,
I'm just asking.
Yeah, we created something that I would call schedule everything. So the SUSI answers are made of actions. And these actions cannot only be answers, but also like playing a video or playing an audio and showing something. And we put another layer on top, which is called a scheduler. You can create a skill which says, this is the action, but don't do it now, do it in 10 minutes. Okay, so the alarm feature is part of that idea. Yeah, you can put in any kind of activity and schedule it to be executed later. Of course, we need a framework is doing this, and there's a Python framework on the device which is now executing this kind of setting. So the SUSI server is just declaring that this is the action that has to happen, and then any kind of client of this has to execute it. We have the client that's implemented on the device, and so this is how it's going.
Okay, I think it's the last question from Harish. He's asking, one could put in an offline version of Wikipedia to have it run offline. Have you tried that yet?
Yeah, that's of course one of the examples that we should create. Wikipedia is, I think the dump is some gigabytes, and it shouldn't be a problem for a device like this right now. you need to run another search engine, creating an API to this. And as we have shown by Aravind, it's not so difficult to do this. And I did this 10 years ago with the Yassi project, but we can use this as well. But I think there are now many other frameworks available.
Yeah, okay. I think that's all for the questions so far. Okay. Yeah, I think the next session will be starting soon. So I guess if anyone has any other questions, maybe you could ask Michael in the discussion room if you will be there after this session. Yeah. Yeah, so thank you for coming here to FOSSASIA, Michael.
I'm so looking forward for next year. So this will be great. Hopefully in Singapore. Yes.
Yeah, so I think Shubnam here will be taking over for moderator for like the upcoming session. So yeah.
Thank you, Marcus.
Bye.
It was a nice session, Michael. So on next, I am Shubham Patel, back, your friendly neighborhood moderator, with one more person. We have today on our panel Mr. Edgar Riba. I request Mr. Edgar to switch on his camera and mic. Thank you.
Yeah, sure. Hello, how are you?
Hello, I'm good. So first I'll give a short introduction about you, then I'll give you the presenter right, and you can start with your awesome workshop. So a short introduction about Mr. Edgar. Edgar Riba is a research scientist at Grid AI, leading the Cornea project and the other open source initiative. Before that, he worked at the Institut de Robótica e Informática Industrial, Barcelona, as research and interned at Area Inc. Enthusiastic about the free and open source software culture, he became an active member and contributor of OpenCV community after his participation in the Google Summer of Code from 2014 to 20 as a student and later as a mentor. He is the creator of the Cornea library and co-founder of the Cornea.org and LibreCV.org, which are non-profit orgs. So we are already impressed by your open source contributions, and I'm sure we'll impress by your presentation too. So I'll give you the presenter rights now. And you, okay, yes, you have the presenter rights now. And you have shared the screen too. Awesome. So I wish you all good luck for your presentation and all the best. Sorry, Edgar, but you are mute. Yeah, your mic is mute, just.
Right now, it's okay?
Yes, it's audible now. Perfect.
Okay, thank you. So, thank you so much for this warm presentation. And thanks also the organization for inviting me here to give this workshop about cornea. So I'm very excited about it. It's the first time. I didn't know before about the FOSSASIA organization or even this Summit that has been running, I think, almost for a week. So amazing work from the organization. I love the interface, this event AI thing, so everything amazing. So thanks again. So yeah, let's get started. I would like to introduce myself. Well, the presenter before did a short introduction about myself, but let me introduce again. So I'm Edgar. I recently joined as a computer vision researcher at Scikit-learn, company that founded by the creators of PyTorch Lightning, where we are trying to foster the open source ecosystem and in AI, providing tools for training neural networks or open source. And today I'm going to talk about Cornea. Cornea is a library that has been existing for a while, that now it's more or less aligning with all this Lightning ecosystem. So this talk for today, it's going to be a long talk. So it's a 90 minutes talk. So I'm going to take it very slowly. And if you have any questions anytime, just feel free to ask. I'm not sure exactly what's the proper way. It's my first time using this. I guess through chat. I'm not sure if you can even interact by voice. But yeah, I will try to keep looking at the chat if in case anytime you want to ask some questions. So as I said, it's going to be a long session, 30 minutes, a hands-on on Cornea. So the first part, I think it will take around 15-20 minutes to introduce the library, explain what's Cornea, motivations, a bit of history. Then I will go through the different resources we have. We're going to go through the website. I'm going to show you all the repositories we have with the main source code, the different examples. And the other part of the session, I guess, going to be more or less 1 hour. I've compiled different examples. So all of them are in Google Notebooks that I will run it in Google Colabs, and I'm going to show you very initial examples about how to use Cornea with very simple functionalities for doing computer vision, doing PyTorch. And in the end, we are going to also see a bit more complex example about how to integrate Cornea with an end-to-end system for training neural networks. In that case, using PyTorch Lightning. Okay, so let's start with this introduction. So as I said, this talk it's called Differentiable Computer Vision, an introduction to Cornea. So for those that are not aware what's Cornea, so the name itself, it's defined as an open source differentiable computer vision library for PyTorch. That basically means that we implemented from scratch different existing algorithms, classical image processing and computer vision techniques in PyTorch. So this library has been highly inspired by OpenCV from the very beginning, since I started this project with one of the creators of OpenCV, Gary, during an internship at one of his companies 2 years ago. And that's why our API and more or less the design, or at least the initial ideas how to organize the code was very inspired by OpenCV. So Cornea as a library provides several features. So most of them inherit directly from PyTorch. So as I said, Cornea is built on top of PyTorch. We've implemented everything, all the computer vision algorithms using pure torch tensors. And the library provides different functionalities for doing mostly classical computer vision. And now as I said, one of the big properties that inherits from PyTorch is differentiability. So with Cornea, you can introduce all these implementations of vision algorithms as a layers inside your neural networks, and you can use it as a nonlinear operations, or even to compose complex loss functions in order to optimize your models. So the library has a transparent API, so means that any line of code, so it's transparent in terms of the devices, so you can run any operator of Cornea in different devices like CPUs, GPUs. Now we are exploring TPUs, and you can do that as the same as you do it in PyTorch, just calling a dot device, and then you send your operator into the device. Also, we enable parallel programming. This is another feature from PyTorch. So all the operators are compute in batch. So, but as a user, you don't have to do, you don't have to care about this, because PyTorch do all this job for you to parallelize internally all the computation. In addition, we can integrate all the components using the distribute API from PyTorch. So this means that you can define complex vision pipelines, and then using that distribute API, you can send these operators through distribute system. You can send it also to the cloud. And finally, this is one of kind of recent features that PyTorch provides, which is the Torch script compiler, which means that using Cornea, you can also integrate this feature and compile this code so that you can export it to a more optimized devices like embedded systems, or even you could create from that C++ interfaces. So these are more or less the core features of the library. And now let me go very quickly through the different functionalities. So Cornea, it's a full library. So we have defined it or group the different routines in the library in different subgroups. This is very, as I said, very inspired by libraries. So if you are familiar with different computer vision libraries, you probably might find a pattern here. So we provide modules for doing data augmentation, techniques for doing image enhancement, color conversions. We provide a set of 2D feature detections, techniques for doing filtering, edge detection, then strong model for doing geometric transformations. And finally, recent one that we are promoting is the module for 3D geometry. So I will go now to the different modules that we provide. Here I will just list the different algorithms that we have. This one, the data augmentation module, it's a promising one. So initially, Cornea, we didn't have the plan to provide a module for data augmentation, but it turned out that using the core features, the community just started to contribute on that. So that's why kind of decided to go for this data augmentation model. And one of the features that we provide here, comparing to libraries that are doing data augmentation, is that we provide for free differentiability on that. We can also apply these augmentations into not only images but also in 3D. So the 3D imaging, it's a field that it's very common for medical imaging. We try to have the API compatible with Torch Vision, which actually was kind of the first library in Python that were implementing data augmentation. So we were inspired by them. And we also enable to do the data augmentation in batches and also in any device, as I explained before. Can be CPUs, GPUs, or not TPUs. So here we propose also another feature that is very useful for research, that when you do the data augmentation, usually you apply some transformations, mostly when you are working with geometric transformations. And in our API, we are able to return these transformations that sometimes when you are doing research, you might want to keep all those informations in order to later use it in the loss function. So the module of image enhancement, we provide different algorithms for doing any kinds of normalizations, algorithms, the ZCA widening algorithm. We can compute different types of image histograms, and we provide several features to adjust properties from the image, like the contrast, brightness. We can do equalizations. I'm gonna show in the end of this introduction, we are now introduce a very interesting operator, which is the CLAHE. It's a technique for doing equalization in local patches of the image that really helps the algorithms to converge. As for the color module, we provide the classical things to convert between RGBs, grayscales, HSV, HLS. This is not very fancy, but I think it's more a utility that all the libraries that doing computer vision provide. So here you can have it right now using Cornea. And I would like to notice here one of the recent one, which is Lab, which is something that it's very interesting from the point of view of the research community working on color. Then we have the Cornea 2D feature detection model. So this is one of also the strongest modules in the library. So in here, we provide classical implementations for the Harris corner detections, the Hessian detector. We also provide the DOG detector, which is the detector used by SIFT. Or we provide utilities that are very handy for people that works on this field. For example, operators, all of them, of course, differentiable for doing non-maximal suppressions on 2D tensors and even 3D in case you work in scale space representations. Have a set of utilities for doing geometry, local affine frames. And finally, we provide an API for doing image matching using different techniques. And in addition to that, this is something that we started to introduce again. So initially, we implemented this differentiable version of the SIFT descriptor. And we recently started to introduce more descriptors using CNNs like HARNET, TFIT, and even more advanced descriptors that are used by the community of local features. The module for filtering, we provide a very basic API for filtering, for applying filters, 2D filters and 3D filters to images, 2D images, or as I said, the medical images in 3D. But the interesting thing here is that, as I said, we provide a very basic interface for applying filters. But not only that, but we provide an API with different kinds of kernels for applying Gaussian blurrings, Laplacian. Then we have other advanced implementations for applying median blurring. And very related to that, it's the module for edge detection. So in here, we provide a set of functionalities or more high-level implementations of known algorithms like the Sobel edge detection. We provide, it's not this here, but we provide an interface to do it using the first and second order derivatives. That it will be later the Laplacian edge detection. And another operator that I find very interesting is this special gradient. So we implement this operator computing the gradients on tensors. So I would like to remark here that compared to existing libraries, Cornea, all the operators, it's are fit in this TITO pattern, which means tensor in, tensor out. So all the functionalities in Cornea assumes that your inputs are all the time tensors, high dimensional tensors. And by doing that, it's interesting because, for example, as I was mentioning here in this operator, you can compute just your spatial derivative on learned tensor. So that's why I think that some of the functionalities in Cornea are quite different and interesting compared to other libraries. So then, as I was saying at the beginning, a strong module for geometric transforms. We have implementations for doing fine transformations on the images, very useful for the transformations and implementation parts. An API for doing crops, resizes, different kind of flips. And then we have this group of operators for doing different warpings using fine transformation, the perspective that uses homography, or even to work with 3D that assumes as input rotation and translation matrices. As for the 3D geometry, so Cornea geometry, it's kind of split in different parts. So we have their combination of 2D geometry and then this more advanced 3D geometry that have implementations of algorithms to be used in epipolar geometry in extraction from motion. With that, we have an API that is directly related to work with perspective cameras. We have operators to convert between quaternions, rotation matrices, and then some operators that can work with images and convert it to point clouds or even compute the normals. Then we have recently introduced in this last version Cornea morphology. So now we have a whole dedicated module to do morphological operators. So for those that are more or less familiar, I think one of the most very basic and known techniques for computer vision. So that was one of the key missing features in Cornea. So now you can implement those operators. We have started with these very basic ones, dilation and erosions, open closings, and then more advanced like top hat and black hat. And again, here, if this one here, a bit aware of morphological operators. So that's the cool thing on Cornea. So traditionally, morphological operators were designed to work with binary images. But instead, here in Cornea, you can apply all those morphological operators in non-binary images. But not only that, it can be applied to high-dimensional tensors. So here, I think it's super cool. I haven't seen these kind of implementations before, but I would like to know if there is any library doing that. But as far as we know, right now, it's the first time we see this, that you can apply just, in this case, I think it's as an opening operator to an image. But as I said before, instead of being an RTB image, why not a tensor of features that your neural network is optimizing? So these were more or less the features of the library. So now I'm gonna go very, very quickly with some numbers about our ecosystem. So as I said, Cornea started 3 years ago from now, and we got some attraction in the ecosystem, the PyTorch ecosystem. So now Cornea is of the official PyTorch ecosystem. You can go to the website PyTorch. There is an ecosystem with some projects that are more or less with some action in the community. So, and in terms of number, yeah, we have a decent number of stars or popularity in GitHub. People have been forking our project. We have been receiving some contributions recently. And the library, it's in our case, it has an Apache 2 license. So it means that it can be used for commercial purposes. Then in terms of community, we have also a Slack channel. So now when I'm going to show you all those things. So in case anyone is interested later to interact with us. And then in terms of development or how to start using Cornea, so in each of our releases, we provide a pip package. So you can just start using Cornea with a pip install Cornea, or if you want to try the master release, you can just clone the project in your local device and then install it from there with this command Python setup install. Another thing to notice here that I'm kind of proud is that Cornea doesn't have dependencies, so it's only depending on PyTorch. As I said, our design principle is a tensor in, tensor out. So we do not accept any operator that gets us with, for example, NumPy arrays or even other kind of image representation. So we're very strict that. So which in the end helps us to reduce the number of hate at the time of maintaining the library. So okay, so as I said, has been there for a while, and we have recently introduced the version 0.5, and this one, as I was mentioning before, we introduced this module for doing morphological operators. We included a new algorithms for computing local descriptors using CNNs. We introduced also an interesting operator in the data augmentation module that enables the users to perform or to reuse the existing data augmentations operators in order to be applied in video sequences. And then another interesting functionality that we have introduced in this release, it's a small functionalities to draw different, in that case, rectangles. So it's very common that you want to debug your images or even your metadata for people that's doing object detection. So we have introduced this operator to draw and to output this kind of drawing functionalities. Another interesting algorithm, this is the thin plate spline warping. So in here we introduce now this operator that enables to warp this kind of non-rigid structure. So now we can apply these transformations to tensors in order to be fit in this kind of non-rigid grids. And finally, another interesting operator that we introduced is Clahe, as I mentioned in the image enhancement module. We are able now to equalize images or tensors using this algorithm that it's really, really handy when you have images with very interesting pattern in the histogram. Okay, so this was more or less the introduction to the library. So I hope you got an intuition what's Cornea, the things that we can do, how you can start using. So I don't know, I'm not sure what's going on with the chat. I've been seeing some noise here.
Yes,
okay,
so, so there was one thing in the shared notes. So basically we have shared notes for registering questions. So every participant can write their questions in the shared note. There is one question for you. Could you share the link to the collab notebooks?
Yeah. I'm going to do that. So so that could be the second part of the talk. So it's been 30 minutes. Yeah, as I said, this was the introduction now, and now we are going to go to the hands-on part. Okay.
Yes, the interesting part.
Yeah, sure. Yeah. Okay. Let's do this. For that, I need to share my screen, I guess, because I have all this prepared here. Okay. Here. Okay. So yeah. So let's go with the practical part. So let me go very quickly. So this is our website. It's cornea.org. So here it's our entry point. So sorry for news, it's not really updated. So we are on the work of upgrading this website right now. And here you have different links. You can go to documentation, tutorials, discussion that links to the PyTorch forums. We have also blog or GitHub. So very quickly, you have here the documentation. So everything that I've been explaining, it's all here. So we try to keep the documentation very clean. So you have all the API, We try also that for each of the functions to provide just a small snippet. Everything is tested, so yeah, feel free to go there to know how to use Cornea. And then let's go to the interesting part, tutorials. So as I said, here we have tutorials. Sorry, this one is not really updated. I'm going to share in the chat right now, that one. Okay. So this is something that we are working right now. So we are migrating all the tutorials to our new website. So and for today, I have compiled very few examples. So I'm not sure if I will have time for all them. Well, we have still 1 hour. So yeah, I have prepared here 1, 2, 3, 4, 5, 6 examples. That I have this hello world. I'm going to go through that now. I'm going to show how to start loading images with Cornea and PyTorch. I have a short one with color conversions, the morphological operators, and then the warping to perform geometric transformations, a small one with semantic segmentations, and finally, I'm gonna show this end-to-end thing using aligning. Okay. So let's start. Okay, let me check the size. Okay, here. Okay, cool. So let me know if you have questions in the meantime. So I'm gonna try, or maybe you can give me some feedback if it's too boring. But I'm gonna try to go to line to line and executing everything and trying to explain more or less what's happening. Okay. Okay. So what's this? I done here. Okay. So in this first demo, what I'm gonna show, it's that's the starting point with Cornea. So here, what we pretend is just to show how to take an image from internet, to load it, and then just apply very simple operations and display it. Oh, okay. So by default, Colab, we don't have Cornea, so that's something that I'm not sure how, but I would like to know it if anyone knows how to convince Google to include new libraries here, because I will be very happy to have Cornea by default. But for now, we have to install Cornea, so we install Cornea. Usually, Cornea works with Torch, so you have to import PyTorch all the time. And here we are just using OpenCV to load the images, NumPy just for reference, and Torch Vision also here because I'm going to show one of the recent operations of Torch Vision for loading images, and then Matplotlib for visualization. Okay, so we import images. Libraries. Here I just download one image, and then here what I'm going to do. So yeah, take your time to read this. But basically here we're using OpenCV to load our image. So OpenCV by default loads images in NumPy arrays in BTR format. So it's something that it's a particular feature of OpenCV that usually opens the images with the inverse channels. That we have something to do yet there, but okay. So OpenCV opens images in NumPy. So Cornea is Torch. So yeah, for that, in Cornea we have this image to tensor that basically just casts the NumPy array to a Torch tensor. So that's why I'm using here typing, just to make sure that everyone is aware about that. Also, notice that OpenCV opens the images in this format, high with channels in uint 8. And another thing that in Cornea, not only we work with tensors, but we require, as all the other PyTorch components, we require to have the data in batch. So that's why we attach, well, we include here this additional dimension here. One is for batch. In that case, we have just one image, so we have batch 1. And also, PyTorch work with this pattern, so channel first, high, width. And basically here, this operator image to tensor, we just do all this work for you. So having one NumPy array, you call image to tensor, and then you have your image in a tensor in the proper shape to work with any other Cornea thing. So, and here we also provide, so here we, probably this is one of the most basic functions in Cornea, BGR to RGB. So as I was explaining, OpenCV loads images in BGR, which if you try to visualize it, it's okay, but you will see that, well, actually we can try it and you will see the difference. But here we provide this for you. So you can just use the previous tensor in BGR, and then you have your tensor that it's converted to RGB. So this is OpenCV. You have to load it in NumPy. You have to convert to a Torch tensor. You have to do the conversion to RGB. But now in Torch Vision, I like very much this feature that they included. It's read images that basically do all these previous calls for you. So basically, they internally read the image and they cast in the proper format in tensor, in RGB. So yeah, it's very simple. So Torch, IO, read image, and then you will get your tensor in the proper format that we want for working with Cornea. Okay, so now we have this X RGB, which is a Torch tensor, and then we are going to use Matplotlib to plot these images. So here, one of the drawbacks here is that Matplotlib assumes NumPy arrays. So that's why we have the inverse operation, in that case, tensor to image. So in order to visualize data in Matplotlib, we have to do this bridge. So we have to convert back to an NumPy array. So that's what we do here. And then finally, you just create a figure using Matplotlib. And then here we pass the original image, the RGB, and the BGR. And you see that how the colors are kind of interleaved. Okay, so this is to me the hello world of Cornea. So to learn at least how to load images, in this case I showed using OpenCV, then I use Torch Vision, and I simply applied this very silly transformation, color transformation, and finally using Matplotlib. So I think this is kind of the pipeline for people starting to work with computer vision, at least in Python in general. So loading images with OpenCV. There are other libraries like Pil. I'm not sure if Scikit, they even have some operators functionalities for decoding images. But yeah, this is the common pipeline. Loading an image, and here we're adding the layer of Cornea that we have to cast to Torch tensor. You do whatever you want in Cornea, still in tensor, and then to visualize, you go back to NumPy, and you can use Matplotlib to visualize. Okay, Cool. So I don't know if you have any of you have any questions about this. So I don't see things in chat. So I assume that there are no questions. But yeah, feel free anytime to ask. Okay, so let's go to another example. Here, the color space conversion. So this is more or less an extension. I'm gonna go a bit fast here because, as I said, we use the same pattern all the time. Okay, here on this. To download the image, so then we load the libraries. In that case, yeah, we do all those things of loading the image in VGR. Then in here, yeah, in that case, I just use OpenCV to convert back VGR to RGB. Then here, I install Cornea. You can see that it's very fast, all this process of installing Cornea, so I don't think it's a problem at all. And we load, and then, yeah, so here. This is more or less the same process as before, so we have this NumPy array, we convert to a torch tensor. Then in that case, we convert VGR to RGB. Here I'm gonna show you something. So we're on Colab. This is the cool thing. For example, here we can compare. For example, let me do this. What's the difference of? Yeah. Look. So here, yeah. So here I'm visualizing the VGR. So this is how would the image look like when you load directly with OpenCV. So that I'm not sure if everyone. So I'm assuming a lot of things that people is aware of computer vision, but maybe not everyone is very aware what does it mean to interleave the color channel. So this is actually when you load images with OpenCV that you have first blue, VGR means blue, green, red. So this is what happens when you have first the blue channel, and that's why I mean, and the most common format is RGB when you have the red channel first. So, and that's usually or what we are used to see the images. So yeah, that's why sometimes OpenCV is a bit annoying in that sense. Okay, so here we start with interesting things. So Cornea, I was explaining before that we can or that we implement the parallel computing by default using PyTorch. And what does it mean? So basically here, let me, for that I can create a blog. So basically here, if we plot the shape of this image, you will see that this image has this shape, has 3 channels. This is the height, this is the width. But the interesting thing is that in Cornea, we can not only apply the operators to an image, but we can apply it to a batch of images. What does it mean, a batch? So basically, we can take one image, for example, this one, RGB, and then Torch already has this call view, okay, and we can say, oh no, wait. So here we have first to include this, and you will see what happens. So RGB shape, Okay, so here you will see that we have included this additional axis, and then what we can do is create a batch of images. And batch of images means that you can stack different images, or in this case, what I'm going to do is just to replicate. Well, let's try with repeat better. So now what we can do here is we say, okay, in the first axis, let's create 4 copies of this axis. Okay, and then we want to keep the others the same. And I don't know what's happening. Oh, maybe I did something wrong. Okay, so demo effect. Whoa. Okay, I see what's happening. We'll have to load again. Here, I think no, I'm just gonna. Oops. Okay, something is really wrong here. Okay, so in theory, yeah, I'm sorry about that. I'm just I didn't try that before. But in theory, using the reshape, the repeat function, you could replicate to create a batch here. I just was trying to explain what's going to happen next, but because here I'm creating a batch of images, I don't know what's really wrong, but okay, we can skip this because here, okay. Yeah, let's skip this for now, and let's see that everyone works as expected. Okay, maybe I can show you here differently. So here, what I'm doing in this line, I'm just creating this batch of images. I don't know why it was not working before, but here, and I can show you the shape. Yes. Let's plot again. Okay, yeah. So you can see, if you remember before, we had just batch 1, and here this XBBGR. Now we have 4 images, okay. And in here, I just apply different operations on the original image, like this horizontal flip, vertical flip, and then I rotate it just 180 degrees. Okay. So basically, here we are creating a batch of images, which in the end means just a stack of 4 images in that case. Okay. And what I wanted to show here is that how we can not only apply color transformations, but the cool thing in Cornea, as I said, is that we can do it in batch. So and without touching any line of code, we can apply these transformations in batch. So all the parallel programming, it's done transparent. You don't have to do anything. So actually, all those operators here. So this XBBTR, as we just saw now, it's batch. It's a batch of images. So we can just input this batch into the image, into the function, and then you will have your color conversion done in batch. Okay. What else? So here the same. So all the operators. This is more or less what I'm showing here. That all the operators can be done in the same way. So you just need to input your batch of images, and then you will have for free these operators applied to all the images in your tensor. Okay, and let's try something if we are lucky and it doesn't break. So the cool thing of Colab is that right now I think by default it's in CPU, but let's try GPUs. Okay, I think we have to run again everything. Okay, so now we are in Colab GPU mode. Okay, this means that we can use GPUs. What I want to show now is how easily we can run these things in GPU. Okay, let's go, for example, here. That we already have the badge, so let's make sure that everything is as expected. Okay, so we have this image, and then what we're going to do here is just send this tensor to the GPU. Okay, we're going to verify one thing first. So torch is available. So we are going to make sure that we have a GPU available here at least. So you see that's true. So this means that now we can use all the CUDA implementations from PyTorch. And then we are going, okay, what's happening here? I don't know. Let's print also just to make sure. Experiments here. Okay, so yeah, so each of the torch tensors has this property member device. So you can check all the time the device. Also, you can check the data type. So these are the most common, I guess, properties that you want to check all the time in your tensor. So here, yeah, you have usually the shape. This is to know if we can use the CUDA implementations, the device where is your tensor. In this case, it's still now in CPU. So by default, when you create a tensor in Torch, it's in CUDA. In the CPU. And in that case, when you load images directly using OpenCV or any vision library, you get the image in that format. Okay. So what I'm going to do here, and I'm going to show how easily you can use Cornea with CUDA, is just this. We have our tensor, and then we can just say XP, BGR, CUDA. Then in theory, I haven't tried this, so in theory it should work. Okay. Let's now print the device. And if everything went as expected, we have now our tensor or image in the device, the first GPU. And now again, if everything works as expected, we should be able, without touching any line of code here, Cornea internally should compute everything. Okay, it worked. So yeah, so now what happened here is that without changing any line of code, Cornea just made this operation in CUDA. So I think that's super cool. So that's why I meant in the introduction that we are a transparent API. So if your tensor, your input tensor is already in a CUDA device, then internally you will get the implementation of that algorithm in CUDA. So, and just to verify, we can just plot here. This is the RGB. This is the output of this function. Yeah. So you can see the output that we just got here. it's also in CUDA. So I think that's super cool. Yeah, and we can do the same for the others. So so you see here that I haven't changed anything, and yeah, everything works the same as before, right? But now all it's running in the GPU. Now not only one image, but we have a batch of images. And yeah, all the magic happens inside Cornea and PyTorch. I think that's the most coolest thing about Cornea. Okay, yeah, so this is the end of this tutorial. So here I just showed a more advanced version of the initial hello world. So I showed how to apply different color conversions, how without touching almost any line of code, you can run the same algorithms in batch and in GPU. So, which I think that are the main, I think, interesting features in Cornea. Okay, so yeah, this is the end of this second tutorial. Again, if you have any questions at this time, I don't know the moderator has any question or comments.
Yes, Edgar. Yeah, there was one question. Could you give some more examples of API use case of Cornea?
Yeah. That's next. Yeah. So
okay.
Yeah, I'm just covering the very basic how to load images, how to apply it now in GPUs, CPUs. So yeah, I wasn't sure about the background of the people attending to this workshop. So I was assuming zero knowledge of computer vision. So that's why I started with these very basic things.
No,
but yeah.
It was good. Like as a beginner speaking, I really liked it. Cool things which you showed, which we can do with Cornea.
Yeah. So yeah, because these are usually the things that I mean that people that more or less work with images do usually an OpenCV or Scikit or PIL or all these libraries. But here we're introducing how to do the same things just with Torch. So yeah. Okay, so we have still 40 minutes. Yeah, so more interesting things. Morphological operators.
Edgar, one more thing. Can you just share the Google Colab link in the chat?
Yes. Okay. Yeah. I should be sharing more things, right?
Thank you.
Yeah. So everything, all these collabs are in these tutorials. So the tutorials page. So yeah, you can go to any of these tutorials and you get the badge of a Google Colab. You just click and it will open for any of you the Google Colab, and you can start playing offline yourself. So I think that's the cool thing of Google Colab. No? In theory, I have tested everything yesterday, and if you click here, run all, in theory, you will get everything. So, but if there is anything that's not working, yeah, just send a message here, and I will try to fix it. Yeah. Okay. Yeah. Okay. Actually, I'm gonna do that to go faster. Yeah, run all. So yeah, morphological operators. This is something that we recently introduced. I don't know why we didn't introduce before. I guess just because we didn't have time. So in Cornea, I mean, we're a quite small development team. So, and yeah, sometimes we don't have enough bandwidth to cover all the things that we would like. And this absolutely is something that for people that has been working with computer vision, it's a very basic thing, morphological operators. And that was really missing key features in Cornea. Okay, so as I said, morphological operators are just operators that were meant to work with binary images. Okay, but here in Cornea we introduce the concept to apply these operators in floating point images or even learn features. Okay. So let me skip maybe these first things because yeah, all this, as I said, I'm just doing the same thing every time. So I'm just loading images here. Yeah, so here is the, that case, okay, we have RGB already here. Okay, and here we define this kernel. We convert the image to torch tensor. So we have the image. Okay, I don't know if you are aware about typing, but we use quite a lot typing in Cornea. I think it helps a lot to understand the code, even in our case that we switch to torch tensor and NumPy arrays, or you have even other types of images sometimes. Yeah, so here I have an image tensor. Whereas here we define it this plotting image. And here, yeah, we show how to use the morphological operators. Yeah, so now we have Cornea morphology. We import here from Cornea morphology. We rename or put this alias CorMorph, and then just simply as that, you can apply in this case a deletion operation, just giving as input this image, this cat image that we have here. You can play with other images. Here I just actually this one I didn't do myself, just for the audience. So this was contributed by Julio. Julio was a student from the, I think, the Computer Vision Masters in Madrid, I think, and as a master's project, he just did these whole modules. So I think it's super cool to have this kind of contribution. So we're all the time very open about those things. So yeah, I didn't mention, but I mean, we are open, super open on this and GitHub. So if anyone wants to implement any feature or just have any need, yeah, I think just try to reach us and we can talk. So we're very open. Yeah, and in that case, I think this is the ideal case as Julio that had this idea as a master's project. He just implemented this module, and it's working really well. So yeah, feel free to play with other images. Here is the image of cat. We define it this kernel. So I'm just noticing now that yeah, maybe we should include some theoretical background, just in case people is not really aware what it's happening under the hood here. But yeah, to work with morphological operators, we have to define kernels. So kernels that will be applied here along with the image. So yeah, in that case, we take as input this cat image, and then with this defined kernel, you will get applied this deletion image operator in this image. Okay. So again, I really like this idea here of morphological operators because in here we are showing different things again, no? That we can apply morphological operators in batch in GPUs. Well, here I'm running CPU, but if you want to play now, you can just change here the device to CUDA. Remember first to change the runtime to GPU, and then you can start playing all with this notebook in the GPU mode. Okay. So yeah, again, batches of images, GPU, and here the cool thing is also that we apply these operators in this case into an RGB image. Okay, so an RGB image in the end it's so the dimensionality of channels it means that it's a high well, not high but multi-dimensional image. So and that's the cool thing about Cornea. That we can apply these morphological operators, not to only binary image, which usually are one single channel, but here we can do it in RGB. It can be a tensor of features with, I don't know, hundreds of channels, and I think it could work. Okay. Yeah, so yeah, and then here I just show that the different operators. So have erosion. I think it will be interesting if you want to play to see different results. Actually, we can try now to play with the kernel. So here, yeah, maybe it's easier if I put it like this. Okay, yeah. So here you can see the kernel. In the end, it's a 3x3 thing. In that case, it's called a cross kernel because it has the shape of this cross. But I'm pretty sure that if we change this, again, I haven't tried this. See, let's see what happens. Let's try something like this. Here, let's try this kind of cross. Actually, I'm very interested to see what's this. Okay. Okay. Let's try. Actually, there is not much difference. How can I do it? Well, yes, some parts. And here, yeah. Here it's the difference is much bigger. So you see that I don't know if I zoom. Can I zoom? Yes. Yeah. So yeah, you will get like pixels augmented. Yeah. Yeah. So yeah, with morphological operators, this is the things that you usually will play with. The type of kernel. Yeah, so here we can show also the gradients using that that kernel. Okay, yeah, so I encourage you to play with with different images. You can also try to create a batch of different images. Here it's just one image, right? Let's try this. I think it's a good practice to keep printing shapes of images, the devices, all these things to debug, just to understand what you have here. Yeah. So here we have this image. It's batch 1. Yeah. Okay. But yeah, again, you could try to just download different images and then stack them, apply the operators, and also I encourage you. Where was that? Yeah, the kernel to play with other. Oh wait, I think I was missing something here. Let's see if it's different. Probably not. Kind of. Yeah, you can try also bigger kernels. Like now it's 3x3. So this is 3x3. Other kernels that you can try, it's 5x5, 7x7. 11 by 11. You can try different things. We don't have yet, but we have to talk with Julio. Because if you tried before this, for example, in OpenCV, I think they already provide like a small API for different kernels. So this is something that yeah, I think can be useful in the future, like to provide with just a call to generate for you this at least a common kernels. Okay, I think there are shapes, yeah, this cross, and I think there are 4 or 5 standard kernels. Okay, yeah. So this is morphological operators. Again, if you have questions, so this was one of the most common computer vision things that I really find super interesting to have. I'm super happy to have in this new release now morphological operators, because as I said, was one of the missing things in Cornea from the beginning. And yeah, just feel free to play with this demo and try yourself with different images, different kernels, sizes, values. Okay. Okay. Yeah. So I'm gonna go to the next one. So let me share to you. Okay, I see Korean people here. Okay, hi. Okay, so I would like this will go fast because I want to spend more time with the last example, which is a more end-to-end example for doing data augmentation with aligning. But here, I think this is one of the kind of the most used operations in OpenCV, or other libraries have other names, the word perspective. So here we are going to see how we can project back and apply geometric transformations to images. So again, run all just to go fast. Okay, so let's see that everything goes as expected. Yes, load. Here we load the image, and then we're printing here. Okay, yeah, let me show first the output, and then I'm gonna go to the details, because I think it will be easier to understand what's going on here. So the main idea here, we're going to use this word perspective, which basically takes, it's an operator that applies transformation, in that case a homography. Okay, an homography, it's a transformation that maps pixels from one image to the other, assuming that your scene or anything, objects or whatever is in your image, it's a plane. So it can work for very roughly in outdoor scenes where some things are kind of very plain. So, but the ideal case will be like this one, that a wall, that it's plain. Okay. So this is the most common use case for homographies, when you have a plane and you want to map one point to one image to the other. Okay, and that's actually what we are doing here. So basically, what I have done is I defined it in this input image, the image on the left. I have defined these corners on the image. Okay, 4 corners. To the coordinates. So, and then what I've done is I have used this function here. So let's go to the code. So here I defined these points. Maybe I can do that to show everything. So I have defined these 4 points here. These points are those points. And what I've done in the next line is, okay, I said, okay, I want to convert these points, these 4 points, I want to convert them to be the corners of this image, okay? That's why I have defined these destination points. For example, this first one, which is this one, I've said, okay, I want you to give me the transformation that converts this first point, this corner point, to the 0, 0 on this image, okay? So that's basically what's happening. So the second one, it's this, and I said, okay, convert it to that corner, to the top right corner, okay? So basically defining this mapping, okay? I've done this, this is usually done for image registration, okay? So I've done that just entering numbers, but you could implement an app just to click, and then passing these tensors with points, we will get this transformation, and using then the word perspective, I just input the image, I pass this compute transformation, I define the expected output of the image, and then I will get this working thing, okay? So, and that's actually the result. So basically we have rectified this, and we have put like this, no? Well, I don't know, like this. And then we have rectified, okay? So that's basically what it does, word perspective. So assumes an image, assumes the transformation, in that case, a 3x3 homography, and then it rectifies you the image. So, and the cool thing is that this operator, it's also differentiable, which means that this input image can be tensors from your neural network, or even this transformation can be something that it's in your optimizer, in the optimization loop, and you can refine. So, and then you can create a loss function based on that, and everything will backpropagate. So that's a cool thing. So I really like this example. So, and if you go later to the example repository examples, you will see more advanced uses of this working perspective. Okay, yeah, I have few minutes. I want at least to point to you to this end-to-end example. I will skip that one that explains more or less how to apply data augmentation, in this case for semantic segmentation. So I'm gonna go to this one, here, so basically here, okay, here, yes, I want to enable GPUs, it's already enabled. Let's run all. So here I'm going to show how to use data augmentation with Lining, Python Lining. It's a framework that allows to easily train in an organized way your code when you want to train models. So here I'm going to show how to combine Cornea for doing data augmentation and pre-processing within the Lining framework. So again, here we install Cornea, Lining, torch metrics, a new package for computing different metrics during your training. So these torch metrics, we have released this very recently. So this torch metrics was part of Lining. Now it's a standalone package, and it's agnostic to the framework. So yeah, you can use even outside Lining in any other package. Okay, so here we are importing libraries, and here what we are doing is we create this class that inherits from NN module. NN module is one of the most basic classes in PyTorch. So everything that you want to implement any neural network, you will usually create a class and inherit from NN module, because it has internally all the for computing gradients to cache the gradients during the backpropagation. So that's best practices in Python. So you want to do something, a class, inherit from NN module. So we're doing the same. We're going to do the same for data augmentation. And here we have we define different operators for data augmentation. We define this sequential here. So we are going to assume in the forward pass that we have a torch tensor, and we are going to apply these transforms. And you can see here that these transforms, it's basically two operators. You can, we have way more in Cornea, so you can try to place here any transformation, play with parameters. In that case, I use the most basic ones, normalize, which means that it will normalize the image between 0 and 1. This is something that actually we require that in most of the operators in Cornea to be the inputs in between 0 and 1, which is something very common also when you want to train neural networks. Okay, so yeah, here we normalize. Then here we apply, we have this random horizontal flip. So here what will happen is that first it will normalize, and then eventually, so this is the probability of occurrence. So we'll have, yeah, we will normalize, and then eventually the image will be flipped. So that's what's going to happen here, okay? And then we have another member here that is color that will be randomly applied. If you remember in the enhance module, we showed different operators about how to change properties of the image, like brightness, contrast, hue values. Okay, so color jitter, it does all for you. Okay, and yeah, and basically here you assume your input a batch of images. That's very important. And then we will apply the transform. And here I just put this if else, because that's a cool thing about being inside a class. You can have a state, and you can, based on desired behavior, you can switch this on off. So that's something extra that I added. Okay, so this is for the augmentation. Then the same for pre-processing. I created a class for pre-processing. This will be used, I'm going to show you where now, be used when we load the image from the data loaders from PyTorch. So here we assume that we have an image that we convert in NumPy array, and then using this image to tensor that we have been seeing all the time, we can convert to torch, and then we return. Okay. Then here, I'm not sure if any of you is familiar with torch lining. In torch lining, you can define your module. So here we define a very simple model. This is the actual model that we will train. So I'm not going to give details, but because I don't have time, just 5 minutes. And then we define these classes for pre-processing, data augmentation. This is for getting metrics during the training. And then the interesting thing here, it's in the training step. So in PyTorch lining, you have to overwrite this training step where you get your batch of data. And the cool thing is that here, our batch of data, it's already a batch. So as we were seeing before, in Cornea, we can operate everything in batch. So that's actually the perfect use case here. Okay, so when we have the batch, this variable x, we apply this transform that, if you remember, is this data augmentation class here. you will go here, and it will apply these different transformations. Okay. And this will happen only during training time, because this is that's the data augmentation theme, right? That you want to apply variability in your training data. Okay. Cool. Yeah. So that's for training and the transformations. And then the other thing I wanted to show is that here self-process, this self-process class that it's implemented here when we prepare the data and load the data loader. So these are the data sets that we use from Torch Vision, and they have already they have their own transformations. I think it's good to use their transformations, but you can also use Cornea. I mean, it's just two different ways of doing that. Okay, so yeah, so here in transforms we pass this process, which is this class we created here that just converts the pill image to an MP array and then a tensor, so that we can continue with the process. Okay, and again here, yeah, feel free to play changing the model. You can go. We have more examples how to use with end-to-end systems, and also play with aligning if you want, or if you have any question, yeah, you can just ping me back. Okay, I think it's time. It's been a long time. I don't know if I covered everything, but yeah. Questions?
Yes, Edgar. So I am sure all attendees have loved your workshop from beginner to advanced, all levels. And at the moment, I cannot see any more questions in the shared notes, but we have some appreciating sentences for you in our chat section in different languages too. So one is in Vietnamese, Hindi, Korean. So I hope you had a good time at FOSSASIA, and you wanna give any good words?
Yeah, sure. I mean, I now in the chat, I can stay here some minutes more. Yeah, if you have any questions, like I will be in the chat responding. Or if you have other questions, we have also a Slack channel in Cornea, so feel free to join. Maybe let me share very quickly the link to here to GitHub, and you can find on the bottom the Slack channel. Yeah, if anyone is interested, yeah, there's I will be here now, but we mostly interact in Slack or in GitHub. So yeah, if you have more questions, yeah, we are super happy to answer those questions. New contributors. And yeah, we are super active in Twitter, so follow us on Twitter. Oh, yeah. And thank you very much for inviting. Okay, hi. Yeah, so yeah, thank you for inviting. It's been a pleasure. And yeah, good luck with the rest of the talks. And I hope I can be here next time, or here, or wherever it's happening.
Thank you very much for the workshop. Actually, I also just learned about this computer vision today. Really, really nice. I think people need more time to practice, and I hope that because we also regularly run the workshop, I hope that we can welcome you in another session where I think that it would be better if we do it on Jitsi the next time, where you can actually follow the computer of people and more interactive. So this is something that we could do in the future, because I don't know, maybe other audience also similar to me. This is the first time we get into this, and it's really cool what you can do with Cornea. Really good, really nice. Thank you.
Yeah, I'm super happy. Yeah, yeah, we can stay in touch, and yeah, we can discuss about this. Yeah, sure. Thank you.
Thank you.
Bye.
Thank you. Bye.
Bye.
All right. Hello, everybody. I think our next talk is ready. Should be Mikhail Filipov. Are you in the room? Mikhail. Let me find you. Yeah. Can you start sharing your camera and microphone so we can? All right. There you go. You don't have the mic, you only have audio. No. I believe that if you click on the audio button at the bottom, you can activate your mic.
Okay, I'm back. Can you hear me now?
Yeah, perfect. Cool. We can hear you now. All right, so let me introduce you. Are you sharing screen?
No, I will be sharing the screen for a quick demo, but I already uploaded the slides, I think, on the site. Should I upload in here too?
I think you have to upload in here again, yeah. So you can do it at the bottom. You know how to do it?
Yeah, there's supposed to be a plus sign.
Yeah.
But I don't see it actually here.
You should have it in the bottom left. If you, oh, let me. I need to give you.
Now I have it. Okay, cool. Thank you.
All right, so I'll start presenting. Mikhail Filipov is a chief scientist at Quad AI and research fellow at the University College of London. At Quad AI, he's applying natural language processing, deep learning, and statistical models to explain source code in plain English. And today he's gonna give us a talk about what machine learning can tell from your software development history. Please go ahead.
Yeah, thank you, Marco. Yeah, good evening, everyone, or good morning, wherever you are. Today, I would like to talk a bit about what machine learning on code, and not just on code, but on more of your code base can tell you. And as Marco said, I'm a mathematical physicist by training. Really spent pretty much all my time in academia before Quad. And what we're doing is pretty exciting, and I think there is a lot of opportunities right now for machine learning in very different disciplines, and I hope that I'll be able to show you how much we can actually do and take from the software engineering history and from code and metadata too. So I'd like to ask with questions that whatever I tell you that your company really has a treasure full of data which can help to answer both technical and non-technical questions. And the fantastic thing is that nowadays almost every company is an IT company, at least partially. And the database which we'll have in Git is fantastically rich with data. I mean, it doesn't just contain code, but also documentation and all the interactions that we have between the different developers, between different members of the team, the discussion and the timestamps and etc. So in all these different types of data and metadata can tell us a very interesting story of the codes and the whole project's evolution. So for example, who is the best person to talk to about the new feature or a problem that arises there? Why did we implement the solution in some particular way? These and many other questions could be answered straight from your code base using machine learning, actually. And if you think that these questions are just really not critical, but just like nice to have the answers for them, then let me ask you a question. How much time do you think software engineers spend on code? So I'll give you a second to think about it, and then I'll share with you some of the studies that we were going through. And according to the very different studies, from the very big companies like Microsoft and Stripe to the universities, here in Singapore, for example, software engineers spend from 5 to 28% of their time coding. So you can imagine on how much more time they would love to spend actually on coding if you would ask them. Big contributors to what eats up on this time are code comprehension, which is basically reading code, and documentation and navigation through the code. So engineers waste about 13.5 to 14 hours every week on technical debt, and about 70 hours per week also on code maintenance, which is usually inefficient code and errors and debugging. And together, if you just summarize, then you will get almost 4 working days per week, which is quite impressive. And with the COVID situation, actually became only worse, didn't improve much. Although developers started working from home, we all working from home these days. The number of their working hours went up, but the productivity didn't go up. And it's seen from many studies that's been conducted, and I think many more still to come to give us the real objective picture on that. But you can see from this graph that the study that was completed just a month ago, about 73% of technologists were reporting that out by the end of April already. And this is far above the 60% that we had about the mid-Feb. So this change into COVID regime really affected the developers' activity. And developers' activity includes everything: it pushes pull requests, reviewing pull requests, and commented issues. I mean, we can see that these numbers, they suggest that the developers has continued to contribute and their workflows have remained resilient during the crisis, but the patterns of activity have implications for burnout. So with all these problems and challenges and the questions that I hope you agree with me that we have in front of us, and the vast untapped data that I just mentioned in the very beginning, imagine how great it would be if we could have all those lines of code and the patterns in all different ways to solve the problems that we already have in GitHub, just now mined while we are writing code or changing code. Well, probably not all of them, but only the good part of them. And machine learning can help us with that. So let me quickly walk you through what we can do right now, actually, and how we can do that. And I'd like to start with code completion, but basically, machine learning on code is related to different subdisciplines, related to NLP, to programming language structure, and social and historical analysis of code, such as, for example, contributors graphs and commit time series. And what we aim to do here is really to learn from the large-scale source code databases in order to automatically perform some software engineering tasks. And I will mention just a few, but you can imagine how it may work in others too. So the code completion really, just sometimes called auto-completion or intelligent code completion, it speeds up the software engineering quite a lot. I mean, it's because you basically don't have to memorize the names nor the types of the whole names. And even more importantly, with the code completion, basically helps to prevent errors coming from typos and confusing method names, variable names. And finally, it also allows for less references to external documentation, as an interactive documentation on many symbols in the active scope, analysis dynamically in the form of toolkits while we are coding. And there are many tools out there. Probably you know some of them already. They're coming from very different companies, from IntelliJ to Kite and Codota. So another, you can see here on this example, from the solution that's been done by Tab9, you see the example of how useful the sensitive code completion tool can be really. So just the difference of just one letter, get users instead of get user, changes completely the suggested output, and that's what really makes the difference. Is that when the very critical differences are clear and picked up by machine learning tools. So another area is code optimization. It is a bit vague term, and it's often used to address a program transformation techniques, which tries to improve the code by making it consume less resources. But some ways to get there are through replacing high-level general programming constructs with a very efficient low-level construct. However, very often, it's been shown in many studies also, that changes in habits of developers can help more than just any solutions or the change in the code languages. For example, clarity and style and coding efficiency and test efficiency and profiling, etc. And machine learning can help with some of those. Code review. So automated code review is one of the very, very interesting parts where machine learning can be applied. So classic code review is, as you all know, is a developer's systematic check on each other's code for mistakes. And it's been very many times actually it's been shown that it accelerates and streamlines the process of the software development. So the only problem, it is very time consuming. So many companies that are working on automated code reviews, they're really trying to approach it in order to minimize the time that the team spent on the code reviews. But it really depends from team to team. And the problem is that it's a very developer-specific process. Also, it's tricky to address. The next one is bug detection. So you can imagine that there's a holy grail, and it's been a holy grail for many, many years in industry. So typically, the goal of such techniques for the bug detection and automated bug fixing to automatically generate correct patches to eliminate bugs in software without causing any software regression. And although this problem is vast and there are very different types of bugs, as you can imagine, some studies show very interesting results. For example, debugs. So this is a deep learning approach to fix the bugs, and it specifically works through the name-based bug detection, and it yields bug detectors that have a high accuracy, so around 90% accurate, which are quite efficient. So with less than 20 milliseconds per analyzed files, they reveal about 100 programming mistakes with about 70% of the true positive rate on the real world problems. But unfortunately, it works only, as many other solutions, also on a very limited scope of problems. And finally here, but as I said in the beginning, there could be other areas too, is a code documentation and code generation. I mean, ask any developer. I would love to ask you, but probably, unfortunately, I won't hear your answers, is whether any developer likes to write documentation. And I'm pretty sure you won't get a positive answer. And even less, we all like updating the documentation, which results in semantic voids and errors and the growth of a technical debt and many other problems, really. Until very recently, it was very difficult to tackle this problem, also because it does require quite a combination of quite a few things, quite a lot of data in order to train the models, and some very powerful computational abilities to run the complicated and complex architectures of the models that really can help us with that. So what we did is, when we're approaching this problem, is we developed a set of models that allows us really to generate documentation straight from the code and keep it always up to date. And I would love to share with you what we did really and how it looks like. So apart from documentation generation, what we also do is we help one of the problems that I pointed in the beginning of the presentation, that engineers spend almost a quarter of their time on code navigation. So how do they do it now, and where is a better way to find context? So there are roughly two groups of solutions which software engineers are using right now. The first one is the classic documentation platforms like Wiki, Confluence, and all your classic documentation organizers. We have decent discoverability, but they require a lot of time and effort to be filled and to be updated. Once they are not updated, then they're almost useless, really. And the second one is communication channels. So Zoom, Slack, and all other channels that you can think of, which are very fast, and they good because they help to sync quickly, but it's almost impossible to rediscover the information afterwards. So what we do is we, on one hand, help automatically generate the content and speed you up on this, and keep it always up to date. And on another one, we also allow you to discover the content pretty fast with search and different filters and intelligent suggestions. And I'll show you in a minute on how it looks like. So basically, when you submit your report to Quad AI, it breaks every file into code snippets, and every snippet generates documentation on which you can search. For example, here we see the results on a query update password, and the content here, except for original code, everything is automatically generated. So the questions like where do I change the user password is automatically generated straight from the code. As well as this semantic text, so the HTTP API, ORM query, validation, etc. So they're supposed to summarize the code as well as provide a way to discover the group content. And on the left side, you can see a panel which allows you to filter the search results with the use of semantic tags. So we generate two types of the tags, technical. So you can see here, in this example, the HTTP API, ORM query, Mongo query, and tests, and the business-related ones. So here, the user updates, uploads, etc. You can also work in a code browser mode, and I'll show you in a minute how it works, which is very intuitive for software engineer. At least we were trying to make it so. And if you have to file tree on the left side here, and code and ascent and generated content on the right. So apart from the questions and semantic tags, we provide also more content on each snippet. So for example, who are the experts? And the experts, they're basically the developers who you might want to talk to if you plan to use or change the code and you need deeper understanding. So we look into contributions in the files, on the snippet level, the commits, and how the experts really are answering, creating the commits, closing them, and answering them, and how often one's code is using similar technologies or business problems, really. So if you want to see even more context, you can always look at the related snippets of code suggested by our models here, and they might help you to understand the code base better and quickly identify next steps. So as you could see, most of the intelligence generation and context discovery on our platform is really coming either from code or from the text in natural language. And natural language processing has been an extremely popular part of machine learning recently. But on code, it works very differently. And I would love to tell you on how many exciting problems are there, but I'll probably just quickly give you a quick overview of what are the differences, and if you would be interested to tackle the code also with the use of machine learning, then what you probably have to keep in mind and what will be the problems that you'll be facing. So although there are many similarities between programming code and text in natural language, there are three main differences, I'd say. That one is that code in almost every language has a more regular structure than in text, which helps to avoid relearning. Relearning all those regularities. And the second one is that code syntax also allows not to relearn structures of standard grammatical constructions. And finally, the semantics. The code semantics allows not to relearn the semantic role of variables and scoping rules, etc. However, having said all of that, there is still no silver bullet when it comes to semantic representations of code. So as with all other machine learning problems, when you are working in any domain, what you have to do first is to build a mathematical representation of it. And every representation here comes with a trade-off. So wherever we are trying to capture the functionality and the meaning of code, we have to balance learning effort, which basically is the amount of training data and training time, and analysis effort, which is semantic depth. So in two extreme scenarios, we have a code representations which are language agnostic, which requires quite a lot of work, and versus language specific, something that requires much less work. So let me now quickly show you on how we manage to balance all this and how you can really see these different models in playing in real time, and probably we can solve one of the small problems here. Okay, let me share the screen. Can you see my screen now? Okay, I hope you can.
Yeah, we can see it.
So let me quickly go. So this is a Notepad repository. One of the repos is basically an open source version of YouTube, and you can see one of the issues here was not being able to change or recover password. And no wonder, because if you just search for recovering passwords in GitHub, then probably you're not going to get any code on that. But let's take a look of what how Quad can help you with it. And as I showed you before, everything that you will see here is automatically generated. So all you have to do in order to get the Quad to process your repo is just basically upload it there with one click, and then it will process it automatically. So once we search for recover password, then we will probably find, so this will be the top outputs, and although they are related to password and probably not perfectly related to the recovering password, but let's take a look at what are the search suggestions are here. And probably resetting password will be a better one. So let's take a look at what it does. Now, whether I post account reset password. Okay, so this one looks already much better. Let's take a look at it in the code browser. So as I showed you before, we can show all the same results in a code browser mode, where we will see the okay, cool. We will see the file tree here, the code in the center, and everything, the all generated content on the right. So this is our snippet that is we are automatically directed to, and our models detected that this snippet is answering the question, where do I post account reset password? And indeed, we see that there is a reset token here, and there is some email confirmation here. So it's probably exactly what our fellow user has been looking for. So if we need more information on this, then we can always ask Greg. So Greg is one of the experts, and as you remember, which I mentioned before, so we see that he wrote 79% of this file and 65% of this snippet. Probably a good person to talk to about this problem. And if we want to actually do any changes on this code, then we might want to check what could be the other places which might be affected. And then we might want to take a look at the related snippets. So let's take a look at what it is. So immediately our models show us that there are 4 different snippets that are related to this one just here in this file alone. And for example, this one is posting a, so this one is, but where do I post account password and update current password? And we can also see that there is another related snippet in account.js file, which is also related to the same problem. So as you can see, just in a couple of minutes, we were able to go from from a blank Git issue without any actually search results in GitHub to the place where we have already now relevant code, and we know even how this code is related. And hopefully this will give you some feeling of what machine learning can do now on code and how helpful it is. I just wanted to show you a small anecdote in the end of the presentation. So this plot represents all the functions that are present in a very popular and famous repository that you probably all are familiar with. And the closer they are, the most frequently they are committed together, and the further they are, less frequently. And when we were doing a statistical analysis, we were very interested in what are those specific outliers. And it appears that some of them are those that are probably lost and forgotten, have these kind of names. The secret DOM, do not use it, you will be fired. And you will probably be surprised that this is a React repository, which so many of us use and some of us even rely on. So I hope that machine learning will, that this talk will inspire you to try code, to try machine learning on code, and help you with these components, and in general with understanding your and other code bases better. Thank you very much, and we would love to hear your feedback. Also, try us code and send us what you think and what we should be doing next.
Thank you very much, Mikhail. Very interesting talk. I think we don't have much time for questions. So there's a few questions on the shared notes. So I still invite you to you can either answer them directly on the shared notes so people can read them, or you can also move to the discussion room and see if someone joins and answer a few questions from them.
Sure, thank you, Marco. Yeah, I'll answer the question so that everyone can see the answers.
All right, yeah, thank you very much. Yeah, very interesting work. I hope more people work in this direction. Not many people doing this. Thank you.
Sure, thank you.
All right, I think our next speaker is Norbert. Are you around? Norbert?
Yes, I'm around.
Perfect. There you go. All right. So I'll start introducing you. I think you should be already familiar with the how to do stuff here, right?
Can you give me presenter so that I can upload the stuff?
All right, yeah, just give me a second. I'm looking for your name.
Yes,
all
thanks.
All right, you got it. All right, so Norbert is a mathematician and logician by education. He's now working for FOSSASIA Research Labs on machine learning and open source. And his core interests are mathematical logic, computer science, machine learning, AI security, software verification, and specification. And he's gonna talk about machine learning with Scikit-learn, a very interesting library for machine learning. All right, all yours, Norbert.
Okay, thanks everyone for joining. It's my third talk during the FOSSASIA, so I'm quite happy that this is the last one because it's quite tiring but I don't envy all the FOSSASIA organizers who are doing a great job. Thanks a lot for this. So today I want to talk about machine learning with Scikit-learn. So this is yeah, let's go straight into it. So probably most people, if you say machine learning, then what comes to the mind of most people are things like GPT-3 or AlphaZero, or I don't know, like huge arrays of NVIDIA graphic cards rambling away with deep neural networks. It reminded me somehow of the good old Asterix and Obelix stories, where there's this small village that holds out against deep learning. So it is true that deep learning is very strong and has huge success. But it's not everything in the world, right? It's just deep learning is a part getting more and more important, and has huge success within the machine learning. So, and within the machine learning is again a part of the much larger area of artificial intelligence. Artificial intelligence goes back to like 40, 50 years. I mean, Marvin Minsky was, I don't know how many years ago, experiments, well, actually it goes back even further, trying to mimic human intelligence with algorithm in the most basic way. And machine learning is, well, now, I mean, it's very broad at the topic and encompasses a lot of things. So normally it's learning from data with statistical methods in many cases, but not also. And deep learning, which, well, nowadays most people associate with machine learning, is where you actually try to mimic what the human brain does. Well, whether it's actually this what our brain does is a different question. One big difference is that, I mean, within in no standards, so let's say statistical machine learning, you often have to create features, feature extraction, and while with the deep learning, often the features and the training are involved in one. Yeah, so you could talk about this topic between these here for a long time, but I don't have that much time. So deep learning has huge success. This is obvious, right? I just give you 3 images, 3 things that have really impressed me over the last years. I mean, YOLO, it's now, I don't know, version 5 at the moment, as far as I remember. I mean, I remember when I started and I saw a James Bond movie with very fast chasing around, and YOLO was online registering objects there, all kind of types. So that was very impressive, right? Then, of course, AlphaZero for everyone who plays any, let's say, strategic game like Go or chess or anything in this area, learning from absolutely nothing, right? Learning rules from, so there was nothing pre-programmed and learning everything. That was a great achievement. And very recent GPT-3, the language model, I mean, it's impressive what they create. Very convincing articles, right? But all of these have one problem, right? Do we understand why this happens? If the system gives you an answer, can we explain why this answer was given? And that is one of the things that is, I mean, this is also a big topic, of course, in deep learning community now, explainability, interpretability. But due to the, and I would say in some areas, like in image processing, there is a huge progress, like that you can register within the layers of a deep neural network, like a CNN. You can see what is actually detected, so that helps. But I wouldn't guess that we know how GPT-3 finds out what is typing next. So that is one of the things that is some problem. Think about next time you submit your application for insurance and get rejected with the comment, well, a deep neural network rejected you. This wouldn't be very satisfying, right? So that is where classical machine learning comes in. So there are a lot of advantages of classical machine learning in contrast. First of all, it's accessible to everyone, right? You don't need supercomputers. None of us here can even think about using GPT, I mean, and recreating GPT-3. And it is the recent trend with lots of models that have been created is with that the models need a huge computers. Sorry, everyone. My daughter just joined. You need huge computers and huge system to actually compute these models, which is a rather challenging task. While standard, so classical statistical machine learning, you can do on a lot of devices. It works often with far less data. I mean, all these huge models require a huge amount of data. We have the data is available, but it's not available to everyone, right? None of us has the access to the Google crawlers. One more thing that is quite common and quite often in recent time is the bias. Implicit bias in implicit bias in the models, which is hard to detect, while due to the next interpretability of the classical machine learning, this helps a lot. So there is a huge area for machine learning and for classical machine learning, not deep machine learning. And this is something where Scikit-learn comes into play. Scikit-learn is probably the standard machine learning library in Python. It has and it has sorry everyone. Yes, so Scikit-learn is one of the big machine learning libraries in Python. It's used, well, we have no statistics about how far it's actually used, but counting the amount of projects and contributors is quite far. It is simple, very efficient tool. It's very fast for a lot of tools and features. It is accessible, reusable. It is built on standard libraries that like NumPy and SciPy, Matplotlib, standard, very widely used libraries within the Python community. And it has an open source commercially usable license. So it's a BSD license, which with some, let's say, setups, it's getting more and more complicated to use certain libraries also in a commercial setup. So you have seen that I'm from Fujitsu Laboratories or Fujitsu Research Labs. So what is the relation between Fujitsu Laboratories joined the Scikit-learn consortium in 2019? What we are working on is topological data analysis, and our aim is to integrate topological data analysis into the Scikit-learn library, participating in development sprints and organizing also development. So we will have a development sprint for Scikit-learn also in Japan in the next months. So what is the Scikit-learn consortium? So this is located by the INRIA Foundation. It's about growing the infrastructure. I mean, if a library gets so many users and so many people working on it, you have to have some governing body. And so there is an advisory board, technical advisory, community management, because this is our important things to grow a library across a first research project to a widely used in commercial setups, widely used library. Okay, so I mean, I don't have that much time, so I will not give you cannot give you an introduction to machine learning, right? This is a course, well, several courses that you can take. I cannot give you details about the API. I want to give you a feeling about what can be done with Scikit-learn and a bit of code about this, right? So there are a lot of components within Scikit-learn. All of them are very well tested and have been, so there is a high level of requirement to enter into Scikit-learn. It's like you have a lot of publications, citation index, usable projects before this algorithm will be included in Scikit-learn. So the typical classification tasks, so everything around classifications like handwritten signs or spam detection or fraud detection from credit cards, regressions, all kinds of regressions which are usually used in financial trading, all kinds of clustering, dimensionality reduction used for recommender customer segmentation, genetics where similar genes are clustered together, dimensional reduction that is used for visualization. We cannot visualize like 20-dimensional, 100-dimensional stuff, also for image denoising. Model selection, something very important, right? I mean, getting the right parameters is something that is not trivial, and that is also automatized to some level, we'll see later. And in addition, also further important things like the data pre-processing, which is something very important for data processing, cleanup of dirty data, discretization, scaling, all this kind. Everything is provided within the same framework and the same API in Scikit-learn. So I won't go into details about installation or whatever, just one slide. So it's available for practically every user's system. There are compiled modules there, so it requires like a bit of adaptation to new system, which nowadays new users, as users of the new MacBook, have a bit to struggle with. Normally, you can install it with pip or the distributions. It's included in all distributions as far as I know. So let's go a bit into detail what Scikit-learn provides. One of the things that they provide, and that is also quite nice to learn, but also to try new algorithm, is there are a lot of data sets. So there are a few toy data sets and real-world data sets about all. I mean, I just listed what I found there. They are quite nice because they are between a few hundred to a few thousand entries, which can be used for actually training or developing a new algorithm. So having this data right at hand, like already more or less pre-processed and ready for testing or training or evaluating algorithm, that is very nice because it takes off the burden to accumulate and find data yourself for now. Yes, so it's very easy to use. So you just import these data sets and then load, for example, Iris, the Iris data sets about sunflowers, right? So that's very easy. You can then, after you have loaded it, you can easily plot this. I won't go into the details here. So you can plot, for example, here two features of the stuff you get, well, here this stuff. And we will look into this data set and see how we can use Scikit-learn and how easy it is, because it has all the different methods have a consistent API, which makes it very easily accessible and very easy to exchange methods and try different methods. So this Iris data set, there are three target groups, and well, you want to categorize them, right? I mean, typically task, yeah? You want to classify the stuff, maybe new measurements according to the data you have, right? As a typical example of supervised learning, so the data set has the correct classification available. And well, what you do is just load it in. So the first approach we are doing logistic regression. And so what I showed you before already is we import the data sets. This time we load it in a bit different way, that we have the X and Y. So the Y is the target, so what is the actual value? And then the next is, okay, I just shuffle around. I just want this a random set of entries I want to use for training and for test setting. So I'm just separating this. And here comes the, so to say, the core part. Here, right? We load the logistic regression, and here, I mean, there are a lot of models. I mean, you have to study this. We will see a few today. So logistic regression is one, and so the typical style is that you create an estimator, instantiate an estimator like logistic regression, but we will see SVM or naive Bayesian or whatever we see later, and then you fit the stuff, this estimator to the data. And after you have fitted, you can predict stuff. So these are the steps, they're always here. So here what you happen is, well, you just call the estimator logistic regression with some parameter. I don't go into details for now. And then you fit it. So that's very straightforward. And after that, what you can do, you can predict values here. Well, you see it works quite nicely. Besides here, this is the one. So this is the actual value, and this is the predicted value. So we see it's not perfect, right? I don't show you the plotting stuff. What you would get with logistic regression is more or less this. Well, this distribution of items. You see there are, of course, some errors here, here and here. And this part is quite nice. So, of course, this is not optimal, right? You wouldn't expect that here, like a linear model linear regression would give you a very good separation of this stuff. Now, Scikit-learn makes it very easy to switch here, because all these models, all these estimates have the same API. So and that means that all the procedures you have to do in Scikit-learn is always the same. Just load the data, whatever they come from. Yeah, that can be a data set, but can be something else too. Then instantiate an estimator, right? That can again be a lot of different estimators, right? There are like, I don't know, I didn't count them, 50 or something, different types of estimators. Well, then you fit the estimator to the data. Well, it's usually for supervised learning, you have the target values, this Y here, what it should learn. So you teach, so to say. And then after this, you can predict onto test data or new data and see what comes out. And so if we do the same before, as before, but not with logistic regression, but with k-nearest neighbor. So a different method for classification, very common. Then this part is completely the same. Nothing has changed, right? And the only thing what has changed is that, I mean, I normally wouldn't put it within the code, right? I put the imports always at the top, but for presentation here. So, well, we just import a different estimator and instantiate a different estimator here, right? But actually everything else remains completely the same because the interface, the API is completely the same. That means with only just one simple change, you can change your model already. And we will see this later on also for model search. So at the same, yeah, you get actually the same outcome. If you plot it, you get some definitely better approximation of the actual data. Yeah, well, better, it's whatever. So you have seen it's very easy. It's always the same. Like you have this data coming from either you massage it somewhere or you get it ready, made somewhere, get an estimator and fit the data to fit the estimator to the data, and then you do predict. These things are what is the basic procedure. So for the next, I want to give you a bit more advanced. It's not so complicated, but something that is quite common, let's put it this way, that you have to put together several items, right? The data we normally get in machine learning is not tidy. I'm also doing a lot of R programming, and there's this tidy verse, and I like this quite a lot. So it's really dirty data. And so you have to pre-process this, or you have to extract data from raw material. And so here, Scikit-learn allows you to create pipelines of this kind of stuff, and the pipelines behave like estimators themselves again. So how does this look like? So in this example, we have data from news groups, from actual news groups. I think there were like 50 or 20 news groups. And we want to somehow get a message, whatever, and want to categorize this in which of the news groups it might fall with highest probability, right? So it's a typically text processing pipeline here is, well, you have to somehow evaluate it. The first step normally is that you count frequencies, yeah, to count the words. And after you have the frequency, as if you make them relative, because if you have a long document and a short document, only because in the long document the same word appears 10 times and in the short times only 2 times, it doesn't mean that the 10 times is much more. So you need relative frequencies. So this is called term frequencies. That is one step that normally is taken when you do text processing. Well, then in our first instance, also in this instance, we could also, actually, I'm not sure, I think also I do it afterwards SVM. For example, train a naive Bayesian classifier, very straight ahead, and then use it for prediction. So how can this be done practically, right? I want the code actually, later on I summarize also the code is actually, you can run it. So what is this count vectorizer, for example, is very common procedure in text processing that you have to count words, but it's actually much more versatile. So you can count not only words, you can count n-grams. So 2 words or 3 words. You can, so the unit must not be words, it can also be a character. So if you, for example, want to look at n-grams, like 4 grams of the genetic code, like for GTD, whatever that was, again, forgot it already. You can also give patterns for tokenizing, how to tokenize your words. So this is a very powerful and helpful that you approaching, and we will have tonight, I think in 2 hours or something, on natural language processing for Indic languages, where these kind of things are getting very interesting because, well, it's not byte-based anymore, the encoding and this kind of stuff. So it's so this is a very, very nice stuff. So what you do, you throw in your data and you just fit transform this count vectorizer. It does everything, not everything, what you ask him to do, this counting stuff. The next is to get these term frequencies. As I mentioned before, there is this wonderful TF-IDF transformer. So what is TF-IDF? It's hard to pronounce, actually. So it's term frequencies times inverse document frequency. So this is about what I mentioned before. This is about if you have long documents, like with 10 appearances of a word, and a very short document with 5 appearances of a word, then actually this 5 appearance should be much more important. And then this is the one thing. And then you have one more thing is you could say if there are words that are appearing everywhere in all documents very often, like in English you would say are and we and this kind of words, then you automatically decrease their importance. So these are things that you can do with this TF-IDF transformer. So it's very easy. You just load it from, well, feature attraction text, well, and transform it. As I said, there are several options you can throw in. The API documentation on the website is very detailed about this. And then you just transform your data through it, right? So that's a typical step. And then what would be the last step is, in our case, is a naive Bayes classification. In this sense, as for text, most commonly used is one of the multinomial classification, naive Bayesian. And, well, this is, you can right ahead just, again, import and instantiate it as estimator and fit to the data. There's some smoothing parameter. I just mentioned it because we will use it later. So that's very common. Now we have these moving pieces together, but I mean, you don't want to program out everything, yeah? So what we normally do here is to make pipelines, yeah? And that is something that's quite nice. You can create a text classifier by pipelining these things together. So you have here the count vectorizer followed by this TF-IDF transformer and then the Bayesian, native Bayesian also classifier. And that all together actually has the nice property that it works like normal classifier, as I mentioned before. So you can fit it, you can predict with it afterwards. Just to mention here, these names, they are arbitrary, but you need to be unique. We will see them later on. And as I said, you can use them like fit. You just fit it to data, whatever. This is, yeah. So it makes it easier than shuffling all the data through the yes, time is running out. So putting it all together, I think this is a bit cut off. I won't go through it. So we load this fetch 20 news groups, fetch the data, define the pipeline, and fit the data, and then predict some samples. Yeah, I don't show you the output. It just tells you what you expect from which news group it is. Actually, it fits also correctly. So actually, this code, as it is shown here, works as is. So quite short, quite concise, and easily to change. How we want to evaluate, of course, our models. I mean, this is the good thing. We can all easily check. Also, there's one option with this 20 news group is there's also a subset or a test subset where you can actually predict and compare the prediction against the actual values, where we get an accuracy of about 80%, right? It's not spectacular, but okay, for a naive Bayesian, this is quite good because it's very fast. So now, as I said before, all this stuff have the same API. You can easily try new models, and that is a nice thing. It's there's not many things to do. You just say, okay, try something else. A typical change for the typical model you can try to in here would be a support vector machine. The only thing you have to change is, well, the final classifier is now not the naive Bayesian, but a support vector machine. So I don't go into the details of the arguments, everything documented, but anything else than this stays completely the same. And with this, you get a much better, like 91% accuracy. So playing around with different models, different approaches is very easy and very fast. And last but not least, we have seen that all these steps in the pipeline have parameters, right? So for the count vectorizer, for example, you could look at n-grams, like, for example, 2 grams. We don't look at single words, but 2 words, so following n-grams, 2 grams, right? For the transformer, you can use this inverse document frequency that you reduce stuff, or you not use it. So there's a parameter that you can either use or not. And for the classifier, there are a lot. We have seen on the previous slide, there are a lot of parameters. One of the one that has a lot of influence is this alpha, which is some kind of smoothing parameter, where we could play around. And what is the nice thing? So Scikit-learn allows you also to do a grid search, like an exhaustive search over a certain set of parameters, also in a very easy way. So what you do, you define the parameters, and the range where you want them to be. And here you see, so the parameters where you want to search, you define. So you see the unique name in the pipeline before appears here again, right? So that's the reason they have to be unique. And then here, the other part is just the parameter for the actual object, for the count vectorizer, and the values that are passed in. So for example, this is 1 gram and this is 2 gram. Use these inverse frequencies, either true or false. And for alpha, A to minus 100 or A to minus 2 or A to minus 3. So, and then what you can do is you just do a grid search CV, which takes the original pipeline you defined before, then the parameters. And okay, I mean, I don't go into details. You can parallelize this really if you have a lot of thread rippers with 60 threads or something, you can tell them to really load your computer if you want. And the nice thing, what comes out of this, again, behaves like an estimator. So you can, again, do fitting on this, right? So what this does is searches the whole space for the optimum values, and then on these values do the fitting. So that's a very easy way. Putting it together, this is now not complete code because that doesn't fit. So as I said, you just load the classifier and the grid search. You define the pipeline as before, the parameters, and then the grid search, and fit it to the data. So this is really straight ahead. You can, on this object here, you can actually query a lot of the results. What comes, so how was the testing, and how really which was the best, and which are the best parameters, and this kind of stuff. But so let's put this to an end, because I think the time is running out. So I have scratched only the surface, right? With a bit of code, a bit of examples. Scikit can do a lot more, of course. Yeah, I just mentioned a few examples of standard stuff like supervised learning areas. So we have SVM, we have seen Gaussian, naive Bayesian, decision trees, there are even neural networks. So you can do neural networks with. You have support for unsupervised learning in different kinds, manifolds, clustering, a lot of things. The model selection I showed you before with grid search and cross-validation, all kind of key-fold validation are there. There is support for visualization of the data, not only the matplotlib, of course this is fully supported, but also internal to the plotting properties of the models. And then, as I said, pipelines, inspection, persistency, stuff that helps you to actually work on this data. So finally, for the end, some resources. So the website is very good. So there's a lot of user guides, tutorials, API documentation is excellent. The issue tracker on GitHub is also nice. It's also good if you want to get started by development, because they tag issues with a good starter issues and this kind of stuff. So if you're interested into getting into development into there, there's also a very good development guide. So if you want to be interested in contributing, please go ahead. I just finished also what Fujitsu does with if you're interested in the topological data analysis. I would like to talk about this on a different. So there's a web page online where you can actually use TDA to analyze data and classify data. We have a website. It's unfortunately by now only in Japanese. It's my job to translate it. It's one of my jobs also to translate it. I have to do this in the next weeks. And yes, so thanks everyone for your attention, and I'm open to questions and answers and remarks. Thanks a lot.
Thank you very much, Norbert. Very informative as always. And very nice project, Scikit-learn. It's one of my favorite projects. I used it a lot when I was teaching machine learning. I think there's a few questions, and I think we have some extra time because there's a bit of a gap until next talk.
Okay.
Yeah, so let me address the first one from Harish. I think he said the answer is fine. So yes. Does Scikit-learn have an opportunity to provide explainability?
Very, very interesting question. So this is actively worked on. We had in February, we had a workshop exactly on this topic, explainability or interpretability, because this is very important. I mean, I didn't go into details about what, for example, the consortium, the Scikit-learn, there are big insurance companies like AXA, and for them it is extremely important to get, or banks, national banks, for them it's very important to get an explanation why this result came out. So there is work going on. I wouldn't say it's perfect by now, but it's proceeding, and it's definitely of top importance for most of the core developers.
How are you guys planning to address this? Is this through documentation, or is there any functions that can provide this explainability somehow?
Yes, so there are a few projects that try to extract from the model an explanation of the decision. So we have seen during the workshop there were interesting presentations. Actually, I didn't put the link, but if you search there, I wrote also an English blog about discussing a bit of the topics there. There are ways. It's not documentation. That doesn't make sense. So it should be for a very specific decision. Why did the system came to this decision? That is something that is important, because if you want to argue in contracts and this kind of stuff, you cannot say the system just said to it, right? You have to give an explanation for this specific topic, and that is based on enriching the model with information so that you can get an explanation what were the important factors, what were the critical factors, in which area, so why the cross, so to say, cross importance, yeah, if this factor would have been less important in a different decision or this kind of stuff. So there is work going on, and there are some libraries currently in work and evaluation of different. So there is actually a lot of work based on top of Scikit and independent of Scikit, but used in the Scikit-learn area to analyze this question.
Oh, nice. Very interesting. It's a lot of work to do in explainability. Next one, it seems although Scikit-learn has many features, it is viewed as and used as an accessory and used in conjunction with other modules like TensorFlow. This is moving. And Keras.
Yes.
Why is that?
Now everything's out here. Good point. It shows that the algorithm implemented in Scikit-learn are really good and well developed. It is true, and I used it myself, right, for deep learning projects. I used parts of the Scikit-learn for some transformations and stuff because they work so nicely. That shows that the library is really good, and it shows also, I mean, I've done quite a thing with TensorFlow. I know there is now like TensorFlow pipelines that you can do data massaging within the TensorFlow framework, but it's not easy, right? And this is, let's say, rather recent development. There is a reason why Scikit-learn is often used for this, but it's not. It is used for helping in the deep learning setups, but it is also used for purely machine learning projects. So I wouldn't say that this is a bad thing. I'm happy to see that Scikit-learn is also used in connection with different frameworks and deep learning frameworks, because that shows that there are actually useful algorithms in there.
Yeah, true. I was one of them. Let's see. Next one's. What is the roadmap of the project, and who decides on the roadmap? I think this is related to the organization that you were.
That's a good question. So normally there are two times a year there are meetings between the consortium. So there's a group of core developers, technical advisors, and the consortium members, and together with the community. So there's also the community feedback. They decide on where they concentrate for the next half year or for long-term planning. So that is the normal procedure. It is not. I wouldn't say that is not just the core developers. Of course, I mean, who does the work, right? We know how it is, but in the end, it's not the core developers say, no, we do this and everything else is forbidden. And if the consortium members or a strong interest from user side is there, and impact and code feedback, then this will be taken up. And so there are twice a year, there are meetings within the consortium together with the advisors to see how it should be, how Scikit-learn should proceed and in which direction should go and what new development should go on.
Nice. And is this consortium mostly companies?
No, the consortium, well, it's INRIA from France is the head, right? Yeah. And then there are some companies like AXA, Microsoft, Fujitsu, so a few others, I don't remember now. So they are consortium members. And then there are the INRIA, and then there are the technically, they are independent. They are off from universities. Many people are from INRIA, but not all of them. They are across the world, from Australia to America. There are independent developers, and yeah.
And can other entities join the consortium? Is there any procedure?
Oh, it's a good question. I don't know about the procedure. So, sorry, that I don't know. But surely they can. I mean, that is definitely possible. I don't know what are the requirements or the procedures. Sorry.
Yeah. Okay, next question is, sorry, I missed the first part, how Scikit-learn is used inside Fujitsu. Could you mind sharing a bit more?
What we are doing in the Fujitsu laboratory, so Fujitsu Laboratories is not a name that I like. I would call it, the Japanese name actually is Fujitsu Research Labs, which is much more fitting. So we are working since long on topological data analysis. So it's like analytic geometry, topology, they applied to data analysis. And so there are a few libraries out there, and we have developed several libraries. I speak now as Fujitsu researcher, not as myself. Libraries for TDA that is used actively in several, I cannot go into detail, sorry here, but it is used in several collaborations and products. And so it is, so we use Scikit heavily, but we are also contributing in the sense that regularly we contribute code, pull requests, bug fixes, this kind of stuff. So I think there are at least 4 to 6 people working quite intensively on Scikit-learn and development. And what I said before, so we participated, like 4 people from our team participating in the February development sprint and workshop of Scikit-learn. And I'm organizing now in Japan a workshop and development sprint over 3 days in end of May. So for the Japanese developers. So for the first year, we do it in Japanese. And my plan is for the following years to make it more internationally available for, especially for East Asian countries, where the time zone difference is really a pain if you want to participate at the live development sprint that is happening in France. So our aim is here. So Fujitsu has a high interest, because it also has a high stake, because we use it a lot, and also a high interest for improvement of Scikit-learn, and also great adoption, and yeah, also for our processes like TDA. Does this answer your question?
Is this workshop open, or is it internal to Fujitsu?
The workshop is open, but it will be in Japanese. So
it's open to Japanese speakers, right?
Yes, for Japanese speaker, right? I mean, I'm not Japanese. So it's because it's the first time that we organize such a dev sprint, and so we don't want to go like big and then make a huge disaster, right? So we do it first in a bit local, but a bit smaller scale, and in follow-up years, we want to make a development sprint for Asia. I mean, this is not Asia, it's also Australia. People from Australia, there's one of the core developments is in Australia. For them, it's also time zone different. So it would be nice to have a lot of activity here too. And this is our aim on this workshop in the end of May. So everyone feel free to join if you feel comfortable to.
You speak enough Japanese.
Yes.
And we have one question from Mario. Maybe Mario wants to join. I think he's asking about projects at FOSSASIA that could benefit from Scikit-learn.
Good question. I think PS Lab has a high probability for that there is a way to use Scikit-learn and the mechanisms. You don't want to reprogram everything, right? If they are highly tested and highly efficient solutions for data processing, and well, PS Lab gets you the data. And I mean, that would be something what you can do with the data later. So that would be something where, so like an edit layer for PS Lab where you can provide machine learning, getting some information out of the data, like typical regression stuff, temperature development in your fridge or whatever, measuring whether your aircon is breaking down or whatever because suddenly some sensors change, right? There are some things, and that would, I mean, besides getting the actual data out of the PS Lab, that would probably work for Scikit-learn. Also, Scikit-learn would be very helpful for that.
Yeah, I maybe also for tuning parameters. I don't know how many parameters can be tuned in PS Lab, but maybe some parameters tuning can be machine learning can be helpful there. I think. Next one. Could you share more examples of what people or companies use Scikit-learn for?
Okay, so what I know and what was in public discussion, so that is, I know that it is used in AXA, at least in parts of AXA for insurance evaluation. I know from one of the financial institution, I think it was in France, but I'm not sure, that used it for evaluating and, well, getting decisions on financial data. And that was about financial instruments, like not for clients, like not personal, but it's between banks, how banks are using. It's about regulating, especially regulation between banks and financial institutes. So it was one of the national banks. And the point here is that you have, that was within this explainability workshop, I mean, you cannot give a different bank, I mean, rules when you not explain also what is the reason. So that's a few things I know about, right?
Okay. Yeah, I think that covers all the questions for now. Thank you very much, Norbert. It's always a pleasure to have you here. Very good.
Hopefully in person sooner,
Yeah,
sooner than later.
Hopefully, yeah, that'll be great.
Okay, thanks a lot, everyone.
Yeah, thank you.
I will go over to the discussion room for a bit of time in case someone has some questions.
All right, thank you very much.
Okay.
All right, I think we have a little bit of time until our next presenter. So we'll wait around 10 minutes until the next presentation. All right, we're gonna start getting ready for the next presentation. Jack, I think you're the next one in line. Jack Urbanek, can you start sharing your camera, testing your mic?
Hey, can you hear me?
Yeah, we can. Perfect.
Cool.
Great. So you sharing screen or?
Yeah, I'll be sharing a screen.
All right. Great. Okay, I think we're right on time. So we wait a few minutes.
Thanks for the welcomes in chat, guys.
Okay, and I think we have 1 more minute. I was looking at your bio. I have a small question. Is FAIR a group inside Facebook AI research? Oh, is that the FAIR?
Yeah, FAIR is Facebook AI research. Yeah.
Sorry.
No worries. No worries.
Okay. Let me say I. All right, I think I'll go ahead and introduce you. So Jack Urbanek, I think that those
Urbanek.
Urbanek, yeah. All right. Jack Urbanek, he's a research engineer at Facebook Research, working on dialogue systems.
I think you muted yourself.
Got muted somehow. Thank you. Okay, let's start again. Research engineer at Facebook AI Research, which works on dialogue systems and crowdsourcing tooling. And most of his work sits in open source software or is published research. And our presentation is Wisdom, engaging an open source community. Please go ahead.
Cool. Yeah, so I'm Jack, and I'll be talking a little bit about engaging an open source community, specifically as a small project. So bit of background on me as far as how it relates to, well, I mean, actually, let's start off with just an overview of what this talk is going to be about. I'll give a bit of background on Wisdom, my involvement in it, and you know, where it's going from now. I'll talk a little bit about how you know, someone can grow a project, especially when it's a smaller project. There are obviously many larger projects than the one I'm about to talk about that have their own strategies for maintaining large communities and things of that sort, but it's not necessarily always clear how to get there and the methods to really get there, especially if you're just a small team or an individual. I'll also talk about building and being a good open source contributor. So there's a little bit of something in here for those who are more contributing to repos rather than being, you know, leading one or doing something of this sort. And then I'll have some time at the end for people to ask questions. So I'll start off with Wisdom at a glance and my experience with it. So, you know, what is Wisdom? So Wisdom itself is a dashboard tool that lets you keep track of plots and any sort of data that you're collecting live for running jobs. So frequently we would use this on, you know, on machine learning training jobs, especially if we were doing sweeps or something of this sort, we could plot any sort of information that we wanted live and be able to interact with that data. So all of these plots are rendered using Plotly, and they have interactive components. It supports setting up custom layouts, reorganizing, searching, and then folder-based browsing of your results. It also supports having interactive components, which is a really cool feature of Visdom over some other plotting tools, where you can directly send back signals to your backend, doing things like canceling jobs or reorganizing how the data is coming through. Very much up to customization, and you can script pretty much anything you would want. At the moment, we're at something like 8.2 thousand stars on GitHub, and we have almost 3,400 dependent repos on Visdom. So who works on Visdom? Well, it was originally created in FAIR. It was a team of 3 internal contributors, including myself. It never was really my main project. I didn't really have the time to put into it being such, but nevertheless, we were able to scale this to 86 external contributors, many of them who delivered real and expansive features. And now it is a FOSSASIA project. We've moved the repo over into FOSSASIA and relicensed it under a very open license. And so perhaps, who works on Visdom, it might be you next. This is one of the things that's nice about having open source software is that really there are contributors everywhere, as long as we find people who are interested in the project or in what it is that the project is able to contribute to other projects and other goals that people have. So I'll talk mostly in this talk about what we've done that successfully led to our project growing. And especially like when it's no longer just your project, when there are a lot of people depending on it and things of this sort, and when your time is limited and you might not necessarily be able to deliver every single feature yourself, which is, I think, a very important part of a project's growth phase, being that if there are a lot of people depending on it, you can't just let the project go. The best thing you can do is trying to get the community engaged and get them to own a lot of the parts of it. So, I mean, I'm going to talk assuming that the bare minimum is already covered. In this case, you'll want a useful project, something that people out in the world have some reason to be using. You'll want things like a landing README that's really describing what the project is and how it's being used, a contributing guide so that people know what your expectations are for contributors, things like templates for pull requests, a license for the project, and then documentation regarding the project layout. You can see the templates for these on Visdom for some examples of what we've used. Really, these are just kind of the bare minimum for someone to really be able to engage with the project and to some degree not be scared away from just a monolithic pile of code. So if you want engagement, you definitely need to start at least here. But then from that point, I'd say the most important thing beyond anything else that we had done as a project were efforts that we had to enable first-time contributors. So I personally believe that first-time contributors are the most important part for growth. If you are starting out with a team of just 3 core contributors who are actively working on the project, the only way to grow is to have first-time contributors in the first place. So getting these is not necessarily always clear, but I've kind of thought of it that everyone who opens an issue is potentially a first-time contributor. It's someone who is interested enough in the project to really reach out and try and either resolve a problem or to suggest a feature and an enhancement. And when you're getting started, these contributors might not necessarily have the context that they need to unblock themselves or to really solve the problem. So for this group, you really need to be a guide for them into the code base and potentially encourage them additionally on, where they're supposed to take their code or how they might be able to solve what they're doing. I'll talk a little bit more about what we found really successful in doing this a bit later. And then also, the other side is you might have some brave souls who will jump straight into committing some code and opening a PR, and then they have a direct contribution in there where you were completely blindsided by this feature coming along. And I think that this is a particularly interesting case because it's not always right to simply accept that code, but at the same time, preventing what appears to be a fully fledged feature from being merged in can be somewhat discouraging. So you need to find ways to be like an open gatekeeper, someone who really describes the vision and the reasons why some code might not be accepted exactly as it is. So I'll talk a bit about each of these two and what we found successful. So for those who are issue openers, I'd say the best part of what you can do to turn them into contributors is to be providing context and scoping solutions. So even if you don't have that much time yourself to jump in and implement a solution, or in some cases, it might be better to not jump in and implement a solution, the better thing you can do is to really describe and make it clear how someone might be able to solve an issue or to implement a specific feature. So anything that you can do would include things like actually outlining code paths, suggesting with small snippets of maybe pseudocode what might be done and where it would go. And things of this form really can help enable someone to have a grasp of what they can do to solve the problem on their own. In fact, even just taking this effort that you initially put in to scope out that path and to make this clear, it might be that the first person who opened the issue doesn't really resolve it, but having the context there with the problem may lead someone else to come along and feel empowered to really close that problem and help their fellow users of your platform or of your project. So there's the other side of things where some issues or feature requests are for something that's way larger than any individual can be doing, or especially a first-time contributor might be able to do. So for these, there's still a way to open them up to the community with a call for investigation or discussion to really ask those who are present, especially first the person who opened the feature request, what it is that they really would want to see out of it and why it would be valuable to the project, and places where they might look to see how to enable it. And so engaging the community on these larger issues can encourage involvement, but it's a little bit trickier. You'd more want to be steering that discussion as much as you have context into steering it and as much time as you have to be putting into it. I'd note one thing that is somewhat unexpected, or I found somewhat unexpected, is that sometimes it's a good thing to leave easy bugs for the community to resolve rather than doing it yourself. And I found that those who contribute a small change and have a good experience doing so may return for trying to contribute something larger or providing real features or things of this sort. As an aside, in Visdom, we had a lot of luck using tags for issues. Things like help wanted and good first issue are fairly well known and used in many open source projects, but we also added these two tags for things that need investigation and things that have a fix proposed. And those we found really directed people to the places where they could help the most. We had people who would just do investigations of things and not really do the implementation, or people who jumped in and only helped out when some fix was already proposed and things of this form. So then the other side is dealing with PR revisions, which is a place where I think the most important thing for us has been communicating our vision. So every time a contributor's work needs to be revised, you need to give positive feedback to make sure that it's clear that you appreciate the work that was contributed, but it needs to be either of a certain quality, or it needs to understand the context of how the project is moving forward, and maybe that it might not fit in the way that it currently stands. I'd note that, for instance, we had someone who contributed a fairly large feature that we weren't even expecting. This view that let people compare two different pages of their visualization, and it was a fairly hard to maintain and sprawling feature, and it required us to provide a few rounds of feedback into why the initial contributor should probably add things like testing and documentation such that it would be able to be maintained in the future. And being as positive as we could during that process, we feel is really an important thing to be doing. I mean, we appreciate our contributors. We appreciate people who are, willing to jump in and actually solve problems. So the the other two bad cases are when a contributor drops out after receiving the feedback, and if it's just a minor change that you can do to bring it the rest of the way there, then you can always commandeer the PR and make the last commits before you merge. Be sure to thank contributors for what they did contribute at least. And then in the very worst case, if a contribution can't be accepted at all, if the feature really goes against the design path or something of this form, it's still very important to explain your reasoning as to why you're rejecting someone's work and to remain as encouraging and thankful for that contribution as you can be. So building beyond this point and expanding beyond this scale is really something that we didn't do too much of. I'd say we're at the point right now, an inflection point, where we're trying to get more of the community to own parts of this vision, especially as we've transitioned the project into FOSSASIA. So, I mean, it's important initially to get those first contributors by engaging directly with places you may see using your tooling. So we shared Visdom with university students who were working on ML projects and demonstrated methods that it could be used to really clearly track your experiments and see how that works. And that led to some of our initial contributors, and we gained some growth from that vector from the beginning. Well, once your project is continuing to grow, like, only parts of this model will hold, because you can't scale yourself to be doing this all the time. So you can really try to encourage those who are already providing contributions to the repo to try and provide others with the same kind of help that you provided them. So asking your core contributors to try and scope out issues for new people and things of this form. And then with a large enough project, core contributors, those with merge access, will eventually own key components of the vision, and things will grow from there. So I'll briefly talk a bit about building contributors, either for yourself or by encouraging others. So before we can really talk about what it is to build someone into this, it's good to note what matters in being a good contributor. At least what I've found matters really a lot in being a good contributor. So these are things like providing a lot of context and expectations with feature requests and bug reports. It's sometimes hard to understand as a project owner what it is that a specific user might actually want, or what they're really expecting the project to do. And the more that this is provided upfront, the easier it is to start conversations about what can be done to resolve these issues. You should also be trying to request context on what a feature is trying to solve before actually jumping in to address it. So this often leads to situations where if someone doesn't do this, they may have a working solution where they implement it or open up a PR, but it either breaks in the near term or doesn't actually work for that kind of way. It doesn't actually be something that you can implement, and it really leads to a lot of churn, and it can be discouraging if you jump in and you work on a feature and you deliver it, and then a project tells you, hey, we can't accept this, right? And so this is an important thing to really be able to be a good contributor. And then the last part is trying to encourage good behavior in other contributors where possible, participating in discussions. If people are opening issues and you have ideas on what can be done, this is something that's really seen as a positive. And then the other side of this is knowing what it is to be a good contributor to a project. You'll want to try and create good contributors within your project. The people who are already willing to contribute, it's in your best interest to help the people in your community grow and to help them become better, because as you do so, you'll help the growth of your community itself and the growth of the project. So always be treating contributors with respect. They're learning as much as anyone else is. If you try and provide those repeated contributors with insight into the overall project vision, you tend to get more of a response and more involvement from them. So as much as they'll listen to, I'd say is the right amount to be doing. And then also encouraging contributors to provide summaries of their thought process in issues and PRs helps you give them clearer feedback as to ways that they can improve or places where they might be able to grow in. And I'd say one of the biggest learnings across all of what I've done in Visdom is that growing a healthy community is as active of a responsibility as writing the code. I, at a certain point, was putting more time into making sure that I could foster a good community of contributors as I was putting into writing code and solving the problems. And I think that actually was time better spent towards making Visdom something that the community needed and wanted to use. In fact, I found many more of those stars that I noted initially came after the point where I stopped writing large chunks of code for Visdom, and more when I started growing the community and focusing on the community side. So that's actually all I really have to talk about here. There are definitely examples of what we've done in the Visdom repo. If you go, you look there, you look at some of our past PRs. I think it's really interesting to look at PRs that have been closed and see the kinds of conversations that we've had there. But otherwise, I'm happy to answer any questions that people have. We have around 6 or so minutes. That's.
Thank you very much for your presentation. Very nice. We have a lot of questions indeed. A lot of them are more about like Visdom. People are wondering, can you give some example of how Visdom is used? You said thousands of projects depend on it, Hannah?
Yeah, of course. So I think one really good example that we've had is visualization of how training progress is going for vision-related models. So for instance, we could use this in trying to train GANs to generate some nice images. It's nice to be able to view the training curves and view the loss curves for maybe all of your, all of the models in your sweep, and then actually have the images appear of, where the current model is, as far as its best generations go. And then the reason why this has proved to be pretty helpful is you can pan through many of your, dashboard views. And if you have a job that's like really just not successful, you can kill the job, save your compute, maybe, your karma on the cluster or whatever it may be, and then start new jobs on just the ones that have been doing well on your sweep, right? So, I mean, this is one use case that I think was fairly heavily used internally and externally when we talk to university students and things of this form. But really, you could use it for any training job where it is worthwhile to be seeing your results live. And if you want to be plotting metrics that wouldn't necessarily be available in TensorBoard or other pieces of visualization software.
All right, and then how does it tap Visdom with PyTorch, and what are the use cases specifically? I see projects online with different libraries. What is the role of Visdom as a component here?
Yeah, okay. So one thing that is nice about Visdom is it doesn't have any dependency to a specific machine learning, platform or library, or the underlying library doesn't matter. So for instance, you could be using Visdom with Scikit-learn, you could be using it with TensorFlow, you could be using it with PyTorch. You just want to specify the actual data that you want visualized, and Visdom can do it. So training curves or loss curves are very much the bread and butter of machine learning visualizations, but you can do things that are more complex than that. Comparing the wall time that it's taking to train individual epochs and things of this sort. You can really, as I mentioned, you can plot in actual images and show how they're progressing. We have a feature that lets you scale forward and back in time with the the generations of a model. Really, there is the idea is that Visdom lets you introspect into what a model is doing or what it's thinking over the training process. You're not necessarily even constrained to, using it only after a job is done. It is receiving this data live. You can investigate something during the training process and have some insights as to how your model is doing and how everything is performing.
All right, and then the next one is which are the projects that Visdom is competing with? I guess like Matplotlib or like something like that. Is it similar? What are the differences?
So we actually integrate Matplotlib support. So if you want to use any Matplotlib plots, you can add them directly to your Visdom dashboard and view them there. I'd say in that way, we're not necessarily competing as much as serving slightly different roles. We definitely appreciate all of the different kinds of plots that Matplotlib can generate. And we just think it's useful to be able to see all of your data in one place, to be able to get that point of reference. I'd say probably the more easily compared competitor would be TensorBoard. And I'd say the big difference between Visdom and TensorBoard comes in two ways. The first way is that TensorBoard is definitely easier to set up because it has its baseline standards of what it will be plotting if you are starting a job. But Visdom has more flexibility in what you're able to do, which it's kind of always the trade-off is like if you're just getting started with a project, it might make sense to be using TensorBoard, but if you're really trying to build something out and you're having trouble understanding what's going on, and you have a few bits of data that you want to just plot and see what's going on and reorganize them, well, then Visdom is definitely the right choice. And then the second thing is that Visdom has kind of a back channel for being able to directly communicate with your with the running software. So if you, as I mentioned before, you can directly send commands to like stop a training job, or you might find that one is going really well and you want to launch additional sweeps off of that one seed or something in this way. And all of that is something that you can build into Visdom and make it more of a workflow that helps with that visualize, understand, and then iterate loop than something like TensorBoard might.
Would you say that Visdom it's meant for developers, or does it also lie into the basket of like the data visualization tools kind of thing?
I'd say it's more of a data visualization tool for developers is probably the best way to describe it, is that if you're a developer, it lets you have a lot of power in creating components. We had someone who practically turned their entire plotting and like training and that whole iteration cycle into something they could do just from their Visdom dashboard. They never needed to go and log back into their cluster. They just did everything from there. And I thought that that was a pretty impressive example of what could be done with this kind of software. But that isn't to say that the core of it is still a visualization tool. It's not something that you need to be a really strong developer to be able to use, but more that if you are a strong developer, then you can do something pretty incredible with it.
All right. Let me see. There's a lot of questions here. Next one. Let me see. I'm lost. This one was useful. Oh, what is the interest of Facebook in the project today after they released it as open source and giving it to the hands of the community? How could Facebook continue to support the project? Any mentorship programs plan? I guess like this yeah, after it's class to FOSSASIA.
I mean, the biggest thing I think we're trying to contribute is what it is that I've learned and built out, and the kind of support that I've given the community so far. I want to continue to do so moving forward. Like, the project is certainly something that we had grand visions for, but didn't necessarily have the support for, didn't necessarily have the capability to continue to contribute to in the way that we wanted to internally. And we found that since there were so many people depending on it, it didn't make sense for us to just give up the project. And there's more that can be done by having it be something owned by the community where, I'm able to help, I'm able to, mentor people along with solving the problems that they have and make sure that it has strong owners in the community and not just myself. And I think that that's probably the biggest contribution that anyone can make to a project.
Nice. True. That's very true. Next question. I saw Google Research project used in Showcase for video manipulations. Are these typical use cases why Google uses Wisdom instead of alternatives that might be developed at Google?
Yeah, I mean, it's kind of interesting that you have people at Google using Wisdom when they're the ones who work on TensorBoard, but this is kind of the idea that they're built for different things. Like, if you have something that is more complicated and less, your generic standard machine learning task, like, it is easier to use Wisdom as a quick way to build up and to mock and to show what that visualization would look like. So yeah, these are the kinds of use cases that we were really going for, and it's nice seeing Google and other labs be using Wisdom for this kind of purpose.
And I think I'll go with this last one. How could Wisdom be useful to visualize data coming from open science sensor devices like Pocket Science Lab?
So, I mean, again, this is the idea that if you know that the data or some elements of the data are something that you want to examine or look into, you can plot it. And that's where Wisdom really comes in and is helpful. If there's something that you're just, it's deep in your code and it's deep in whatever experiment you're running, you can just, write a Wisdom plot line and have it appear on your dashboard and have it appear in line with all of the other things that are going on in a training job or in really anything that's happening over time. And this is what lets you better understand what's actually happening.
All right, thank you very much. I think that covers all the questions. Many questions. A lot of interest for this project, and very nice talk. I really appreciate your time.
Yeah, thanks everyone for attending.
All right, I think that will get us moving to our next talk, and should be Chip Huyen. I hope I read it properly. I'll give you presentation rights. Hello. And if you can start sharing your camera and your microphone, please, so we can start going.
Hey there, can you hear me?
Hello. Yeah, perfect.
This is great.
All right. So I'll be sharing screen, uploading. Oh, there you go. That was fast.
Hey, can you guys see me? Hear me?
Yeah.
Everything?
Yeah, everything good.
Hey.
Yeah,
I'm
we see.
Otto.
Yeah, hello. All right, so I'll just go ahead and give you a quick introduction. Chip Huyen is an engineer who develops tools and best practices for machine learning production, and she has done a lot of work with the largest organizations like Snorkel AI, NVIDIA, and Netflix. with machine learning, and she teaches machine learning systems design at Stanford. She's also published 4 best-selling Vietnamese books, and she's going to talk about machine learning for scalable applications. All right, please go ahead.
Thank you for the kind introductions. And just a word of warning, I'm in Vermont, and my internet is like might be unstable. So at some point it might cut out, and I sincerely apologize. There's nothing much I can do about it. So I think like in the beginning, it's going to start with a fun exercise. Does anybody have a phone? And I want to see how good or detective texting on the phone work. Like if you can like type in the chat, but like no pressure. How do I go next to the, okay. So thank you, Marco, for introduction. So I'm actually from Vietnam. Anybody here from Vietnam? I was very reluctant about the time difference, but extremely early where I am. But I always would love to, hey Dan, hey Hong. So I see we're from Vietnam. I'm very excited because I really love to get in touch with the AI community there. So I'm from Vietnam. I actually wrote a lot in Vietnamese. Only I started writing in English recently. I have background in product management and AI and ML. So today we're going to talk about machine learning systems. So the first one is start with different types of machine learning systems, and then we go over the iterative process for designing machine learning system for scalable applications. And then we talk about the project scoping, which is mostly for objective, trying to like scope out objective. And then we talk about 4 phases of machine learning adoptions. Many of you like Vietnamese sometimes. If you can eat and cook with fish sauce, you're okay. So what is machine learning system design? It's a rather new term. People keep asking me about it. So machine learning system design is a process of defining the interface, algorithms, data, infrastructure, and hardware for machine learning systems to satisfy specified requirements. And specified requirements are usually really, of course, they are like specific requirements for our applications, but in general, we want a system to be reliable, scalable, maintainable, and adaptable. Of these 4, the first 3 are general software systems, and the last one, adaptable, is a requirement of systems that learn from data. Because the system is like half code, half data, and data changes a lot more often than code. So system must have some capacity to like adapt to the changing data and requirement. So that's a picture. So a system will be all of this from interface, data, and machine algorithm, infrastructure, and hardware. And so when you build machine learning system, you need to consider all of this aspect. So there's a part in this red color here, machine algorithms, is what we usually think about when they think about machine learning, but you actually need to like look for beyond that. So I thought it was funny. I'm not sure have you guys seen this movie. So when I talk about machine learning, a lot of people who are not in machine learning yet think of it like can help you build some kind of like ultra, like very intelligent. But in fact, you can get something more like this. I'm not sure can you guys can hear. Can you guys hear? Not sure. Okay, maybe I need to like not here.
Siri, what's 1 trillion to the 10th power?
1 trillion raised to the 10th power is 1,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,0
So yeah, this session will not cover how to build system like visions in Avenger, but maybe hopefully we'll cover most applications nowadays. Like, yes, it's cool, it can do something cool, but sometimes it's still buggy. So I think you guys probably, I'm not sure you guys are sick of seeing this kind of graph already, but there is this there's research by McKinsey saying the AI value creations by 2030 will be $13 trillion, and most of it will be outside the consumer internet industry. I'm not sure about the background of the audience here, but as you're going to talk to the audience, a lot of them think that you have to come from a computer science background to do machine learning. But in fact, a lot of value from AI will come from outside the consumer internet industry. So we need people from diverse backgrounds in machine learning, and we also need people from, and not just from like America, Europe, but we need more people from countries like Vietnam and Singapore. So I'm very excited about this event. So the next is so different type of machine learning systems. So before we go into different types, want to highlight the dangerous categorical thinking. So this kind of categorization is not meant to say that if you are stuck to one type, you can't change to another. So there's this really awesome article by Harvard's Business Review saying that on the dangers of this. So this type categorization is just to have you understanding like different ways of doing things, and it doesn't mean that once you like start doing it one way, you can't do the other way. So the change might be easier than you think. So the first is how the machine learning system make predictions. So there's generally two options. You do batch predictions and online predictions. So batch predictions is when you generate predictions in bulk. So you have a system like recommended system. So you have like 10 million users. So you make recommendation for all of them at once. And these recommendations don't show right away, but when users log into the systems, they even fetch the pre-computed predictions and show it to you. So that's why you do batch predictions. Whereas online predictions is when you generate predictions as requests arrive. For example, when you type when you type on the phone, for example, like you type a sentence and it shows you what's happening next. And so this predictions is produced on the fly. Only after you've typed the text, they are not pre-computed and fetched from somewhere. So that's online predictions. So I think that there's a more technical difference. For example, like pre-shipping frequency, like periodical and online as soon as they come. The useful for batch predictions is useful for processing accumulated data when you don't need immediate results. For example, like that's the case to many systems. And online prediction is useful when predictions are needed as soon as the data sample is generated. For example, fraud detections. So you can't possibly so for fraud detection, for example, like there possible way for frauds are too many transactions. You can't possibly think in advance how many predictions you have to make. So you can't generate in advance. So you just have to make the predictions as you go. So some examples is like TripAdvisor hotel ranking, Netflix recommendations. They are all doing in batch predictions, and our predictions are like Google Assistant speech recognitions. When you speak, Google can actually like recognize your speech right away. Or like for Twitter feed, ranking is happening in online. So the system can be a hybrid of batch and online predictions. For example, do you guys use some style of DoorDash or Uber Eats in Singapore? I'm actually not familiar with delivery systems, but it's basically it's a food delivery system. So something like DoorDash, when you go into the app, you go to the home, you can see recommendations of a lot of restaurants to you. So these recommendations usually generated in batch because the space of like restaurants are like too many, and so it's very computationally expensive to generate recommendations for restaurants online. Whereas when you choose a restaurant and you click on it, you might see like recommendations for like items that you might like. So the number of items in a restaurant is a lot smaller than the number of restaurants in an area. So that kind of prediction is less computationally expensive. So that's the kind of recommendations usually done online as you open a restaurant. So for Netflix, when you go into Netflix, you go to your homepage, you see a lot of recommendations for movies that you like. So all of these recommendations actually generated in batch, but like they're different rows. So maybe like the roles today have like watching now, or like the roles that are award winning. So they this is kind of roles order is generated on the go. Like when you log in to say reorder the roles is most relevant to you. So batch recommendations is also a way of going around the latency problem of machine learning. So when the machine learning model is large and very slow, like if generating a recommending a predictions on the fly taking too long and users don't want to wait, so you pre-compute on the predictions and fetch them when needed, because the time it takes to fetch a pre-computed predictions is so much less than the time it takes for machine learning model to make a predictions. I hope that is clear. But if you have any questions, feel free to let me know. So next is edge computing and cloud computing. So this one is like straightforward. So cloud computing is when most of computations are done on the cloud and servers, and edge computing is when computation is done on the edge device. So requirement for cloud computing is like when you have like so the requirement is heavily on the network connections, like availability and speed for data transfer, because like the cost of like transferring data from the device where machine learning system is used, and on the cloud when machine learning systems are hosted can be very slow. Whereas for edge computing, the requirement is on the hardware. You need hardware with like memory, compute power, and energy like for computation. So some of the examples for cloud computing is like most queries to Alexa, Siri, and Google Assistants are like done on the cloud. Or Google Translate for rare languages, English or Yiddish, like done on the cloud. Edge computing examples like Word for Alexa, Siri, Google. So if you use a phone like iPhone, or if you use Android, you can say, okay, Google, like even if the phone is offline. So my phone will always like wake up when I say that. So even if the phone is offline, Google Assistant can still hear that and recognize us. So Google Translate for popular language pair like English or Spanish, like you can actually download or so there's a pair into the phone and do the translation offline. So like on internet applications, unlocking fingerprint, unlocking the phone fingerprints and faces, and this is done on the edge. And I think that is important. So I highlight in red because applications can be actually very dangerous to be done via the cloud, because you probably like people are more hesitant to have their fingerprints and faces like stored somewhere in the cloud because they are more vulnerable for hacking. So there are many benefits to edge computing. So first, it can work without internet connections or with unreliable connections. So so if you want to be applications for people in area like rural area with spotty internet connections like where I am right now, then if the application relied on cloud computing, then it might be very hard. So also like in my work, I've seen many companies have very strict no internet policy. So like if the applications rely on cloud computing, it will not work. So you can have to build some like local data center for them, because many organizations like government agencies or banks or even like research centers, they just can't. These are not allowed to use internet for fear of security. So caveat. So devices are capable of doing computations, but apps still need device are capable of doing computations on device, but the apps still need external information. For example, like ETA, like estimate how much time it takes for you to get your locations. Like it is possible to do that on the device, but you still need internet connection to do so, because you still need internet connection to get data on the traffic information to get the best predictions. So another benefit is that you don't have to worry about network latencies. So some of the applications have built, so when we analyze the cost of the latency, we see a large chunk of latency is not in the machining component, but in the component that is sending the data from the device to the cloud, and then sending the predictions from the cloud back. So data transfer can be the bottleneck, not the machining component. So many use cases impossible with network latency. For example, predictive texting, right? So we try to predict what you're gonna type next, but if the times it takes for the machine learning model to predict what to type next is longer than the time it takes for you to type, then the application is not going to be very useful. So for edge computing, there can be fewer concerns about privacy. I think I read recently about like 81% of companies who use cloud, some sort of servers, have had some like concerns about cloud security over the cloud recently. So when you can put computations on the edge device, there's less of that concerns, because when you store things on the cloud, so when you have a cloud database, it usually store information regarding a lot of users. So when that thing is breached, a lot of people wouldn't be affected. So when you do things on an edge device, it's going to be easier for you to comply with regulations such as GDPR. So caveat, like edge computing is not like a perfect bulletproof when it comes to privacy, because now you have, when you do things on the edge device, because since the device is smaller, it's actually easier for people to just steal the device and get on the info. And I think the last reason, the last benefit is actually one of the biggest reasons why many companies want to do things on edge device, is because like the more computations you can push to the edge, then the less you have to pay for servers. So which means it will be cheaper. So because of the importance of edge computing, that many companies have been investing heavily in better chips, so you can make like hard edge devices more powerful to do edge computing. So for example, like here we have Tesla claiming, but that Tesla has been trying to build their own chips since forever, and I think at some point Elon Musk boasts that Tesla has the best chip in the world, but I think he's a very reliable narrator. So here Apple has their own chip, A14. Google also like released its own chip for future Pixels and Chromebooks. So of course, like in this type, we also have hybrid, like have like common predictions, pre-compute and stored on device, and also like rare predictions are done by the server. So for most common queries, you can still have fast predictions that don't depend on network latencies. You can set local data centers like so first of all, I have a use case that my friend was working on when he was trying to build warehouse robots for a very large company. I can't tell exactly company, but that company also has this requirement of like no internet. But like also like his robots are like not powerful enough to do all the computations on the robot. So what they do is they had to build local data center for each warehouse. So it's not a data center, it's more like server rack. Also, you can also have this thing of like prediction generated on the cloud and cache on device. I think the audience is very, very quiet. I'm not sure if my talk makes any sense, or like if this is like too basics. It's hard for me to get a sense of the audience. So if you can have some type of like, just let me know how I should pace my talk. So I have a very strong belief is that like you can speak a bit slower. Yeah, I already have that problem. So the future, I have a very strong personal belief that the future of machine learning is going to be online and on device. And what it means is that so predictions will be done mostly online, and the computation will be done on device. So I think it's gonna be depends a lot on hardware making being more powerful. So here just have some quadrant of like different types of machine learning. So you have on whether something is doing in batch predictions or live predictions is based on the model inference latency and how long it takes for the model to make inference. So if it takes too long, then you have to do things in batch and pre-compute and fetch them later. But if the latency is low, then you can just like do online predictions. And the same on the whether something should be done on the cloud, on the edge, is based on hardware constraint. Like if the device is more powerful, then you can do edge computing. But if it's less powerful, then you can do cloud computing. Yeah. So I do believe like as the hardware getting more powerful and also the software getting more powerful, as we learned more how to compress model, how to infer, like how to optimize models, then we can do things on the edge and online. So online learning and offline learning, and harder and less common. So I'm gonna go through this very quickly. So offline learning is usually like what most companies are doing right now. So you trained a model and you deploy it, and then you update it like based on when you can. For example, you can update it after months or like quarters. Whereas online learning is like when you continue learning from new samples. So example of online learning is like TikTok, right? Like when you download TikTok, and after just a few swipes, like looking at like you just see a few videos, TikTok already learn from the preference and adapt to the preference very quickly. And that's one of the reasons why TikTok is so addictive, is that it just learn from the preference like really, really, really well. So I think I have this. So a lot of companies have been trying to do online learning, and it's really hard. And as this company have seen so far, actually not in in America, but like the company have since is the most successful and usually company in Europe and Asia. I think like one reason we talk about is possibly because of legacy systems, because internet companies in the US are a lot older. So what means that they come with legacy systems, and for them to change online learning, they're gonna have to update the batch legacy system. Whereas for internet companies, like younger internet companies, they can just build things from scratch and they let bug it out and they can just jump straight forward to online learning. So the next is the iterative process. So I think this is a slide made for my students. So when machine learning productions, like before I got my first job, it has this like expectation: is collect data, it trains a model, it deploys a model, and you're done. Whereas in reality, you might first start by choosing a metric to optimize, you collect data, it trains a model, and then you realize many labels are wrong, so you have to label the data again, it trains the model again, and then you realize the model performs poorly in one class, so you collect more data for that class, you train model again, and then you realize now it has been like a month has passed and the data has become outdated. So you have to collect new data and you train model, deploy, and then you realize there's some problems in production you couldn't possibly anticipate before. So now you train again and you realize it's like the model performed well, but there's like revenues does not increase, actually it's decreased. And people are worried it turned out have been choosing the wrong metrics. For example, you have been choosing, if you do in ads, then the possibility is that you have been optimizing for paper impressions when it should have been optimizing for click-through rate. So it's just all different metrics. So you have to choose a metric and start over. So this kind of thing is called like waterfall model. Like you finish one step and then go to the next. So that's waterfall. Whereas in Ready it's more of a iterative development. So you go from one step and then to another, and then you might go back and forth, and there are many different back and forth. So the next is like we talk about project scoping. So the goals. So the ultimate goal of a machine learning project or any project within a business is like to increase profit directly or indirectly. So like directly increasing profits might be like to increase sales, like through ads or conversion rate, or through cutting costs. For example, it can through like saving the energy costs. So I think Google a couple of years ago, uses algorithm from DeepMind to like lower the energy consumptions, and it saves them like hundreds of millions of dollars. Or it can be like indirectly. So first of all, it increase customer satisfactions or increase the time spent on the website. So indirect relations can be very hard to decide. So for example, like if you build a machine learning model that gives customers a more personalized solutions. So what can happen is that either like this makes them very happy and they spend more money on the site, but another thing that can happen is that like because the solution is so personalized and so good, like they solve the problem very quickly and they spend less money on the site. So it's very hard to like decide exactly the relationship between machine learning performance and business performance. So I think this is example, like with my students, I would love to hear the thought as well. So when you build a ranking systems for news feed, for example, like a Facebook, you can have like many different goals. So one might be like to minimize the spread of misinformations. The second is to maximize revenue from sponsored content, and another is to maximize engagement. So I'm just curious from the audience, like given these three goals, like which one would you choose? You can type in the chat. I would love to see audience thought. That's why I wake up early to give the online talk instead of pre-recording. Yeah, see a three. Yeah, so that's what most of my students work with. Well, Kayan, go on. Kayan is a good engineer. Okay. Let's see. So before we go ahead with with like which goal to choose. So we've seen that most companies go with like maximizing engagement, and it has worked very well for them. It increases organic engagement and it can sell more ads. But I want to emphasize on the ethics of maximizing engagement. Because what happened, like when people choose to optimize for engagement, so they realize it's like the models realize it's like extreme content gets more engagement, because if you say something nice and neutral, nobody's gonna respond or anything. Like if you see something like women are beautiful, and was like looks like okay, right, and just like go through it, and then but if you say something like very outrageously, like what like Donald Trump might have said, right, like you suddenly just stop and look at it, like wait a second, who said that, why you say that, and then just click onto the comment. So it's just like give a lot more engagement. So we have seen this, like people, I think I realized the article say like optimizing, Facebook optimizing for engagement become optimizing for enrichment, or like you've seen this article, I think this is the making of a YouTube radical. So like it's a very nice 20-something years old guy, like who has no idea about all the radical stuff, like started watching YouTube, and it's kept subjecting him more and more radical content, and eventually he become a radical and terrify him. So yes, that's like it's very dangerous to optimize for optimize for engagement. So objective, so like goals is like for general purpose of a project, and objective is like specific steps on how to realize the purpose. I just want to say that different stakeholders have different objectives. Like in a machine learning project, there are many different stakeholders, and each of them can have different objectives. So it's not like you have one objective to like go after. You have multiple objectives. So for example, like if you have a machine in the project, a machine learning team might want the higher accuracy. The sales might just want to like sell more ads. And the product might want fastest inference, and so manager might want to maximize profit. And usually what happens is like the quick way to like maximize profit is just lay off the entire machine learning teams. And we have seen that happen with like Uber last year let go of their entire AI research team. I see with Airbnb as well, and it's not COVID related. So they're different objectives and they be in conflict with each other. So let's go back to our ranking system for newsfeed, right? So we have the goal of like maximize users engagement, and maybe we have 3 objectives, right? Here, so first is to filter out spam. The second is to filter out like not safe for work content, and the next we rank the rest of the post by engagement, like how likely users will click on it, right? So that might be our simple objective. So now we realize that we want a more wholesome newsfeed. We don't just want to optimize for engagement. We also want to minimize the spread of extreme views and misinformations. So we add 2 new objectives, like we filter our misinformations and we rank posts by quality. So now you have 2 different objectives that are kind in conflict with each other. First, we rank post by qualities and rank post by how like users will click on it, because like now it's like, so which one should go on top? So one with the highest level of quality, or the one with the highest number of click. So let's take a step back and see like what rank post by quality means, and let's assume for a moment that we have a way of determining like how the quality of a post, like a quantitative way of like determining the quality of a post. So rank post by quality is that you first predict post quality, and you want to minimize the quality loss, the difference between predicted quality and the true quality. And whereas rank post by how likely user will click on it, you want to predict post engagement, and you want to minimize engagement loss, the difference between predicted clicks and the true clicks. Are you guys with me? So one thing is that one way to do it that you combine the 2 loss. So maybe you can have like, so you want to create a function loss, which is half the quality loss and half the engagement loss, and you minimize that loss. So you train one model to minimize this combined loss. So you can tune alpha and beta to meet your need. So you might be like, today you might want to tune for like 0.8 quality loss and like 0.2 engagement loss. But tomorrow we say like, oh, now the posts have high quality but less engagement, so let's reduce the quality loss. So maybe like 0.5 quality loss and 0.5 engagement loss. So like side note, like if you want to check out prior optimizations, it's really cool. Like if you want to learn how much about like multiple objective optimizations. So this is actually quite common. For example, like you see style transfer, like it's exactly the same thing. There's the losses they optimize actually a combination of like content loss and the style loss. So the problem with this is that like every time you want to track alpha and beta, you have to retrain the model, because now the loss function has changed, and it can be quite a problem because you want to do day to day. If the model is expensive to train, it's going to be a headache. So another way to do it is like instead of having one model that minimize a combined loss, you want to have 2 different models. So you have a model MQ that optimize like minimize quality loss, and have another model that minimize engagement loss. And now you have two models that put two different rankings. So now you can rank posts by some quite like a combined ranking. So like if the model predicts the quality of the post to be like 8, and the engagement model predicts the engagements by 1,000 clicks. So you can try to combine these two numbers by using alpha and beta and ranks on the post based on this combined results. So now you can trick alpha and beta without retraining the models. So I think one practice that I think a lot of researchers disagree, but I think I've seen that more in productions is when you have different objectives, you want to decouple them. So first, it is easier for training because optimizing for one objective is a lot easier than optimizing for multiple objectives. And second, it's easier to trick the systems. Like we just saw, like if you want to change alpha and beta, you just need to like recombine the result. You don't need to retrain the model. And also, it's easier for maintenance because different objectives might need different maintenance schedule. So for example, like spamming techniques evolve much faster than the post quality is perceived and than how post quality is perceived. So it means that spam filtering system need updates more frequently than quality ranking systems. So if you have two different systems, you can update them on their own schedule. You don't have to update them at the same time. So these are several constraints when you think about how to build a model. So first, baseline. I think people always, a lot of people I see always forget. So you need to have some baseline, some kind of existing solutions or like simple solution, human experts, comparative solutions. Because if you don't have baseline, you have nothing to compare the solution to. You have no idea how good the models are or like how good they have to go. So you have like usefulness thresholds. So like how good the system has to be for it to be useful. For example, like self-driving needs human level performance to be useful because you have you have a system that's like worse than a human driver. Then human drivers still need to drive. Then it's not actually very useful. Whereas predictive texting like doesn't need to be extremely good to still be useful. So you talk about like whether the trade-off between false negatives and false positives. So COVID screening, you want no false negative. It means that like, if people have COVID, they shouldn't be classified no COVID because it's dangerous. Whereas for fingerprint unlocking, right, you want no false positive. It means that if somebody is not you, you don't want to give them, to authorize them to access a phone or like those secret data. Also talk about interpretability, and it doesn't need to be interpretable. And if it's not to whom, it's either to the developer to understand the system, or you want to like give it to like business makers or like the users to understand for them to trust the model. Also, like confidence measurements, like how it's about the predictions, because you don't just want the predictions. You also want to know like how confident the system is about predictions. So maybe you don't want to show the model the predictions that it's not so sure about. And also, once you might be involved human in the loop, like if for prediction that the model is not so sure about, then what do you want to do about it? Like, do you want to not show it, or do you want to get more information, or do you want to get human in the loop to get involved? Yeah, so that's a bunch of stuff. Privacy. I think I'm gonna go quickly over and technical constraint, but like whether it's a legacy systems. And I think it has this conversation on Twitter, and the thing is, this believes there's like a lot of the medical challenge is not the lack of functionality of machine learning, but actually because they have so many legacy systems, and we can see it a lot more in the US. For what we talked about before, is like they have older systems and it's a lot of legacy. I say evolutions. And I think like my talk is up, so I'm gonna go quickly. So 4 phases of machine learning adoptions. So a lot of companies, when they talk to me, they want to adopt machine learning, they want to jump straight to the fancier models, which is actually very bad way to go about it. So I just suggest like the first phase is like even before machine learning. So before you even use machine learning, you want to start with some simple heuristics. So like I think Martin from Google has this really awesome post on rules for machine learning engineering, and he says it's like if you think that machine learning will give you 100% boost, then a simple heuristic, then a heuristic will get you 50% of the way there. So I think that Eliza showed the example. Here's an example of a Facebook newsfeed from 2006. So you know that Facebook newsfeed nowadays uses a lot of fancy machine algorithm, right? But if you look at the newsfeed from 2006, do you notice anything particular about this newsfeed? Anybody has a guess? No ads, not personalized. I love it. It's a bit small. I like it. So I think one thing you notice about it is this own chronicle. Like so they have no fancy personal algorithms. They have no rankings. All they do is they just like shows the latest updates first. So just pure, just a simple heuristic, and it worked for them. And it's not until like 2009 or 2011 that they start using like machine learning for newsfeed. So you want to launch applications like with no machine. You might want to launch application with no machine learning, and then collect data and use this data to train fancy machine learning. So yeah, so after you have this before ML phase, you want to like use the simplest machine learning models. So you don't want to start with a very complex system. You want to with something simple. So first, it allows you to validate hypothesis. So the hypothesis here is that like you can learn something from the data. So every machine learning model is based on the hypothesis. Like from given this data, it can learn to do something useful. So when you start something from simple model, you can validate the hypothesis. Like if you try a lot like simple model, but the predictions are completely random, then maybe the data is not very useful, or the way you frame the problem is just wrong. And also validate the pipeline. Since that, so Google analyzed the outages from like 96 machine learning outages, and they realized that a lot of the problems are not machine learning, but from the pipeline, especially when you involve like different pipeline. You have one pipeline for training, another pipeline for doing inference user, or have distributed pipelines. Then there's a lot of bugs. So building a simple model allows you to validate the pipeline. So next phase is to optimize simple models. So once you have some simple models and they work, you can optimize and to make them better. So like by showing different objective functions, you can try more feature engineering, you can more data, you can try unsampling to get better performance, and then you can go to complex machine learning models. Okay, so I think 3 minutes. Do you have questions?
All right, thank you very much, Chip. Very nice talk, very informative. I think there's a lot of questions here. I have a lot of questions myself, and I think that I'll go with the first one. Like it's one of my questions. Like when because you seem to be working with a lot of companies, and there's a huge hype these days around machine learning and artificial intelligence, and I'm sure maybe I'm wrong and it doesn't happen with these big companies, but everyone in the street or everyone that is not very related to the machine learning field will think that it's kind of like magic and they can do everything with it. Do you encounter like really unreasonable questions or like some business people that will come and ask for certain things that you say that's impossible, or like it's very hard to explain that we cannot do this, but we can do this? Unless you have the technical knowledge.
Yeah, no, I think it's a great question. I think I gave a talk about like the myths I have often seen in machine learning talking to companies, and one myth is that I think it's also because of the way the media and also researchers talk about their research to the public, there is this misperception that machining is like magic. Like people say, oh, machining can do this, and that's like own hype, right? People think like now if we use machine learning, the business can be transformed overnight, right? Like they use machine learning, you can see like, oh, maybe when suddenly become a Fortune 500 companies or something, we can compete with like Google or something. And I think like machine learning, it is like some kind of magic. Like it can do help you transform the business, but it's not overnight. So you see companies like Google, right, or Facebook, they have been Google has been investing in machine learning for many decades, like even through the machine learning winter. So it's not going to happen overnight. So I think I saw this research on the level of machine learning adoptions and return on investment. So it's usually like the more the company has invested, the more times the company has invested in machine learning, the more mature the pipeline and the more return on investment that you have seen. So first of all, like in the beginning, when you start with machine learning, it might take you like a year to bring a model into productions. But then as you have like 5 years, after 5 years of doing that, now it takes you like 7 days. So you can see that because machine learning model like performance degrade over time. So you can imagine after a year, the machine learning model will not gonna be performing as well, and you will not see as much a return. But if you can bring the model immediately like a week, then you can see a lot higher return. So I think like, again, as you tell the companies that you have to have patience. You don't just want to like you can't like put some money in machine learning and expect return like 10x like in a month. Like you have to give it time. That you can just like see no return after a month and say declare that machine learning doesn't give you any return and like discard it. Or you also can't just like jump into fancy model. So a lot of people get attracted to machine learning because they see headlines like OpenAI GPT-3, have you do this, or see like BERT model, have you do this, and they just want that in the system right away. And then we look at them and say, no, for the use case, you don't need it. You're trying to do like fraud detection. You have never used machine learning before. One easy way to start is something like simple, like can you read neighbor, like something like very simple. You don't need fancy machine learning model yet. So like yeah, so I think that was the last part of the talk. I just start with something simple.
Yeah, that was great.
Sorry.
Those phases, I think that was very illustrative. Like it's very useful for a lot of people to see how you can get to the end, but doing like these phases, it's very important. I'll go through some more questions. Hi Keep, what would you say are the main challenges with online learning in practice? In my experience, it's largely depending on data mismatching client expectations and available data, which is difficult to get right.
Yes, that is like really great questions. Like yes, you're right. Like machine learning really depend on the data. So I think I did a survey of like 300 machine learning tools, and the largest chunk is like on the data phase. So like there are so many companies trying to have you collect data. There's so many to have you like clean data. There's so many companies that help you like crowdsource labels. And the company I was working for before, Snorkel, is actually a company that help you like obtain more label data from things like which supervisions. So when I say data, they don't mean unlabeled data, because unlabeled data actually abundant. Like there are a lot of like data with no labels. So the hard part is how to acquire labels for this data, because a lot of like successful machine learning algorithms in production are still supervised algorithms. So it means that you need labels. So that company like Scale AI, right? Like the company is like $1 billion, like multiple $1 billion company, and all they do is like to help you like get label for the data. And Snorkel, the company was doing is like to have you gain. It's actually open source. You can see, look it up. So like to have you to have you obtain labels for the data through which supervisions, like simple heuristics. For example, like if you want to have a system to classify whether an email is spam or not spam, one way through hand label is you just show it on the email to the human annotators, and as I say, how this email is spam, this email is not spam. But you can also, based on heuristic, you say like, oh, I noticed that like most of the emails, if they have money in it, like they are spam email. So now you have a heuristic, right? And they have another heuristic. It's like if it has something like meeting at 9 a.m. today, that is pretty not spam. So you have another heuristic. So now you have a multiple heuristic, and each heuristic provide you with some like noisy label. And then you can like so Snorkel can like combine all of these like noisy labels and put you what's most likely to be the correct label for the data. So that is with supervisions. So absolutely right. There's so many companies like targeting the data space right now.
All right, next one. Do you plan to go to Vietnam and teach machine learning to students there? They're waiting for you.
Yeah, I would love to. I'm actually planning on going maybe in a couple of months after the vaccines have been out. So I really miss home. I think I mostly miss street food. So yes, if you guys have some plans there, do you think I can participate? Feel free to let me know. I think I don't really know a lot about Vietnam anymore, so I really love to hear from people.
Nice. Which area are you from in Vietnam?
Nam Định. It's I think home with me doesn't mean that I'm like out of time. So
no, we're fine. I think we have extra minutes. I think the next talk is at 9. So if you have time, that's no problem.
Yeah. So I'm from Nam Định. Yeah, known for the oceans and a lot of fish, I think. That's and nice. Rice. I think we have I think I keep telling people that we have the best rice from Vietnam. People don't believe it because a lot of people in the US can't appreciate the like subtle differences of different kind of rice.
Oh yeah, I couldn't find fish. It was very rare to have fish in the US when I was there.
Yeah.
Okay, I'll go with the last question that we have here in the shared notes. It says Facebook recently transitioned the Wisdom project to FOSSASIA. We just had a talk about it, and relicensed it as open source. I think it's a Apache license now. Have you used it before, or do you see potential where it can be useful? Are there students of yours who might be interested to contribute to it?
I'm actually don't know what wisdom is. Again, I'm not sure who asked.
It's a visualization, data visualization tool that Facebook created, and they just moved the project
I just saw the top before. Yeah.
Yeah, they just moved the project to the FOSSASIA organization, and I think the
wow,
GitHub.
That is really cool.
The GitHub is on the. It's like TensorBoard, sort of like TensorBoard kind of thing.
Oh, great. So I think TensorBoard is experiment tracking. Does this have you track experiments and you train the models as well? Like you running multiple experiments for the models. Does it have you tracked through like artifact of different model training as well?
To be honest, I just learned about the project today, so I don't know much that I can answer. But it looks very interesting. It looks all I think it does is just data visualization. So I'm not sure what else you can.
I see. You have that. I think you have like create dashboards for like live data, inspect result experiments, or debug experimental code. Yeah, I think this is awesome. I think I have seen a lot of some tools like that, and they are very popular with my students. My friend also has this tool called width and biases. So it's of experiment tracking. So it's less data visualizations, but also this tool data visualizations I really like. It's like a facet. So I think like I think if you guys can this tool, if you can combine both data visualizations and experiment tracking, then I think it's awesome. I think you can definitely see a lot of use for it. And I just looked through like some interface, and it seems like very nice visualization as well. I wonder why I haven't heard about it. I think it must be under a rock. Let's see.
I think they had it internally, and they just released it recently. So
that is cool.
But they were talking about Google using it and all that, so it seems very, very popular somehow.
Yeah. So I just want to come in and say hello. Actually, Wisdom have been on GitHub for quite some time. They just did not license it under open source license. They still have contributors for a few years already, and recently transferred to us. They said that it like more than 3,000 projects depend on Wisdom. So we are very glad to have the projects on board. I just want to tell Chief that we do organize like tech meetup and hackathon events in Vietnam. So if ever you come back to Vietnam, we'll be more than happy to welcome you at one of our events there. And I see that today I see there are a few Vietnamese on the list. I wonder if you guys want to turn on your camera and ask questions directly, because I know that we've been you have a lot of followers in Vietnam. I was also I heard about you for a long time already. I think back in the time before even you travel. So we have a lot of common friends like Pritam or Thomas. They all nice about you, but we never have a chance to meet in Vietnam, and now we are here. We met each other online. This is really changed.
Yeah, it's been a long time ago. I think it was like the first phase of internet companies in Vietnam, early 2000s, something, and it was like the first like unconference in Vietnam on the back end. So it was very fun time. Now I remember at the time I think the number of internet startups in Vietnam can be counted in like under 50 or something. You probably know all of them. And I think every time I went back home now, I saw a lot more companies that like own this like amazing internet startups that I have no idea exist. And I'm like, and some of them are like way ahead of like companies in the US as well. So I've been very impressed.
Yes, so we do have a little bit of time. If you still have time, Chip, I wonder if the Vietnamese friends who are here, they would like to turn on the camera and also like ask the question directly. You are more than welcome to do so, because I know that some of them actually came here because of you. I got the message online, so thank you very much for this presentation. Another question that I have from my side, actually, do you have any program? So besides teaching the student in class, do you have any practical internship or getting the student to work on real projects of companies or of the open source community? Besides the work that you've done with them in class, do you have them contribute to projects outside of like university?
So one thing is like students are like very busy, and they were like a lot of them were like so like when you teach them, you can't really make them do things outside of the course. So we usually have one final. So we have a final project, and students contribute, like build their own applications. But then like it's just like all of that's like optional. So some students come to me and they was like, yeah, I want to build my resume. Like, what should I do? So I usually recommend them to like try to like I already highlight like try to get them to contribute to like open source project, because for me, I have got so much out of the open source community. I think a lot of the job offers have got through GitHub. So and like I just like try either like reach out to people who build tools, and I was like go to a lot of GitHub repos. I like look at all the issues and see what I can help with. And now, or like I look at the contributors and see like who contribute and stuff, and like try to reach out to them and say, oh my God, you're like, I'm a fan or something, and talk to them like, is there a way I can contribute? Because I think like open source can be like a bit of a strange and a terrifying place if you don't know people, because I don't know. I think there's something about like it can be unfriendly to like certain people, certain community. Like you can see like there are a lot less women in open source than men. And I see some like incidents of like very popular software engineers who actually like very, very harsh against women online. So I feel like if you know people in the open source space, then you're less terrified. So I would recommend people like getting into open source and maybe like try, make friends, like reach out to people and talk to them. So yeah, but I would like highly recommend people to contribute to open source project.
We have a bunch of
Yeah.
Chief, we have a bunch of projects under the FOSSASIA, and we are a very friendly community, as you know.
Yeah.
The reason why I asked you, we're talking to university here in Europe, in Germany, with the TU, and also a university in Hamburg. Actually, they constantly looking for real life projects where students can get real life experience, because what learning in school is one time, but the tech industry is changing so much. And as you said, I totally agree. When they contribute to open source, it's a way for them to build up their profile as well. And Marco also working on a very big open source project, Open Robotics, right? So how is the situation there, Marco? Are you friendly to women?
Yes, I wanted to highlight that it's very. I think it's very important the contributions for students' resume, because we also in our job offers we ask for a code. A snippet of code or something that you wrote, right? Some people, they give you to GitHub, or they give you a project that they did. But it's astonishing to see how many people say, no, I just did like closed source projects and I can't share anything. And we have to reject them right away, because they don't have, we can't see what they have done at all, right? So I really agree with that. That's very, very important point.
I think one thing about it, like, I think we've seen that. I think like we try to not punish people for not having open source contribution though, because as you see, like there's some group like minority groups who are like less being welcome in open source. So when we come, so if someone doesn't have open source contribution, we try to give them option like if you can check whether there's a code. So actually, when I got my first internship, I was very shy. I didn't speak English because a lot of open source people like use English, right? So I was very shy. I didn't know any. But the company was very nice. They allowed me to actually submit my code sample, not open source, and then I did, and then they like it. But yeah, I agree with you that like it's very important to see some code samples, and if the code samples like online there. I actually like recruited someone through GitHub because that person made a PR to one of my open source, and I look at his PR, I was like, wow, I'm really impressed by how like detailed he was. Like, and if he did that for free, like imagine hiring, what would he do? So I was asked, I messaged him, like, hey, are you like open to a chat? And he was like, yes. And then we eventually like brought him on the team. So nice. So I think I do things that like be more to like make thoughtful comments. So like I think like writing code is not like writing code by yourself, right? I think a lot of time we want people to see that people can work with other people, and I see it was a contribute to open source is on way of seeing people, how you interact with other people, like how you like explain the comment, because writing code is not a write code. You need to write comments, you have to explain what you do, and if you get feedback, you have to resolve the feedback, and all of that you can't really get by just writing a piece of code by yourself. And you can see all of it in the history, in the commit histories, and it's very, very useful.
Thank you. Chief, I don't know if you see the message on the chat. Who actually came here because of you, but I think Big Blue Button is not like many people are not familiar with Big Blue Button. This is the first time we use it for the conference. We're familiar with this open source tool, but I guess that many of the audience are not used to Big Blue Button. Difficult for them to turn on and off the camera and activate the microphone, as you know. But yeah, so we also have this video stream online on YouTube. The day stream will available tonight, and this video will be released after the conference. Hi, Mario. Do you have a question for Chip?
Yeah, well, of course, I have a lot of questions. We don't have so much time, but at least I want to say hello. Yes.
Hi.
So because yes, hi. So Chip. So thank you very much for joining us. And yeah, so I actually we heard a lot from you. I heard a lot from you in the past. I think we have a common friend, Pritam. Pritam Rai. Yeah.
Pritam is everyone's friend.
Exactly, yeah, and we met him many times, but like somehow we never met together because he always said, "Oh yeah, I was to this barcamp or that barcamp. I met Chip, and now I meet you guys here." And it's interesting. It seems like we have some overlap. So great that we, in the end, can connect here. And yeah, really happy to see you.
Thank you. How do you know Pritam?
Well, we organized the barcamp 2009 in Canton. Yeah, and
I organized one with him in 2008. So yeah.
Yeah, and and we went to a few barcamps, and Pritam was also like running the barcamp in Singapore, and he helped us to organize the first FOSSASIA Summit, and connected with us, and he's like an international person, and so there's a lot of overlap, right?
Yeah, I miss barcamps. I really hope that you guys can have one soonish in I don't know, somewhere in Southeast Asia in the next few months when I go back, so I can attend. I mean, I think it's really fun. It was very transformative experience for me as like a teenager. I was very shy. I never thought I would be able to stand in front of people and talk. I know, and people keep telling me it's like, oh, Vietnamese people are not gonna do it because everyone is so shy. But then we organized the first event. We had like 100 people like wanted to give talk. I was like, this is amazing. So yeah, if you guys have in this audience, huh?
Do you also remember Thomas Van Hoff?
Yes, he's in Cambodia now, right?
Yes. So he's also a common friend of us.
Yeah, this is awesome.
He also regularly mentioned you when I met him.
Yeah, he's very awesome. Yeah.
I see that Gajendra is here.
Hey, Gajendra.
Hi, Mangfuk. Hi, Marco. Hi, Mario. Am I audible?
Yep.
Yeah.
Gajendra, this is Chip. She just gave the talk, and we had a bit of chat. So you will talk about NLP, right? Like you will give a workshop, right?
Yeah, correct.
Yeah, nice seeing you here. Thank you very much for joining too. Okay, guys, so I leave this, but I hope to stay connected. Yeah. So thanks a lot, and I back to you guys. Bye.
Yeah, I think my time is up too. So
yeah, I think just thank you very much, Chip, for the talk and all the staying for the long Q&A and conversation.
It's really fun.
Yeah, I even have like more questions, but I think we don't have time. But yeah, thank you very much. I hope this was in person so we can have a chat afterwards.
Yeah, I wish next time. But yeah,
next
please.
Time.
So if anyone, my email is in the chat. If you have any questions, feel free to reach out. Have a nice day.
Great. Yeah, thank you very much. Bye. All right. I think Jendra is the next speaker, but I think I'm passing on to Subham. Yeah. All right. Okay. All yours.
Thank you, Marco. Thank you. So, hello, Gajendra. Good evening. I hope you are from
Shubham.
ISCI.
Hi, Shubham.
Yes.
Good evening.
Thank
How are you?
Good evening. I am good. Enjoying the FOSSASIA Summit till now.
Yeah.
Yes. So, Gajendra will be taking a 2-hour workshop with us. Basic introduction about Gajendra. He holds a MTech in Computer Science and Engineering and PG Diploma in Cyber Law and Cyber Forensics from National Law School of India University, Bengaluru, India. He has presented talks and posters to many conferences like PyCon, JuliaCon, and PyCon Taiwan, and many more prestigious conferences. He is a GitHub certified campus advisor and also leads the PyData Belagavi chapter and the OSAP Belagavi chapter. So this was a brief introduction about him, and he'll be giving today's workshop on natural language processing from Indian language using Python. So, and it will be very relatable to me, especially this session. Yes, so I'll give you the, yes, sorry, go ahead.
Yeah, thank you, Shubham, for the wonderful introduction.
Yes, and I'm sure it will be a great session, as I know India, we have around 22 major languages in India, like Hindi, Marathi, Urdu, Kannada, and many more. So let's see what we have got today. So yes, Kajendra, I have given you the presenter rights now, so you can upload your presentation and continue with it.
Yeah. So just one small doubt. I should start from this link only, right?
Sorry, which link?
There's a presentation link here. Share your screen. So I should start from this link only, right?
Yes, yes. You can share your screen from there too. And if you want to just upload your presentation, you can do so by clicking on the plus icon on the left hand side. As your wish. Okay. The stage is all yours.
Okay. Okay. I have very small. I have a very small presentation, so not much in presentation. So it will be based on live demo. So I'll bring my entire screen.
No problem, Gajendra. We folks at FOSSASIA loves live demo.
Yeah.
So we'll enjoy it for sure.
Yeah. Thank you, Shubham.
All the best.
Thank you.
Welcome.
Hello, everyone. I will be delivering a workshop on Indic NLP, that is natural language processing for Indian languages using Python. I hope my screen is visible. You can see my presentation.
Yes, Gajendra, it's visible.
Yeah. Thank you. So in today's workshop, we will discuss few natural language processing libraries, which will help us to perform NLP tasks on Indian languages. So first, we will introduce the concept of natural language processing. Then we will discuss natural language processing for Indian languages. Then installation of few packages such as INLTK, then Indic NLP library, then finally the Stanza. So these are the libraries which we are going to use today for demonstration of small features of these libraries. So whenever we are okay, so sorry for that. So let's first discuss the concept of natural language processing for Indic languages. We know that in the world there are many languages, and there are libraries have been built specially for English language, for text processing, for sentiment analysis, for natural language understanding, and several other tasks. So NLP has got several applications, especially with respect to sentiment analysis, text generation, and several other applications are present, including natural language understanding. So whenever we consider NLP, it is hard even for English language, because the language has many ambiguities in it. So because of ambiguous nature of a language, it becomes very hard for us to natural language processing on a particular language. So when we think of Indian languages, it is even harder. That is because we don't have much resources, and we have many languages, and as it's a great challenge because many times it happens that we use the languages from other words in our daily conversation. For example, if I'm staying in a city called as Belagavi, which is close to Maharashtra, so the official language of state of Karnataka is Kannada, whereas the official language of state of Maharashtra is Marathi. So the person who is staying in the border areas, he or she usually speaks both the languages, and many times it also happens that they tend to mix the words of both the languages. So even harder in such situations. So we will not much focus on multilingual natural language processing. Instead, we will focus only on natural language processing with respect to specific language in India. Say, for example, we will see the examples maybe related to Kannada or Marathi or Hindi. Okay, so we will not mix the languages. Now, when we say natural language processing, there are some concepts involved. So before writing the code or before seeing the demonstrations, it becomes very important for us to understand these concepts. So I will try to explain these concepts in a very simple language and as quickly as possible. So the first concept is tokenization. So what we do in tokenization is we give a paragraph of input and we divide the paragraph of input into words. So your input will be a paragraph, output will be a list of words. It can be even list of sentences. So tokenization, you need to perform based on your requirements. So either you can tokenize into sentences or you can tokenize into words. The next is word embeddings. So word embedding is also important concept. It basically converts or gives to words into vector format. So basically it returns a matrix of certain dimension, so where you can get the numeric value for words. So this can be widely used in machine learning and other concepts. The next is text completion. So this can be an application. So you provide a sentence as an input which is half complete, and your system will try to predict other half part of the sentence. The next is similarity of sentences. So here what happens is two sentences or two or more sentences will be given as input, and the output will be the similarity which will be in numeric, which will be a numeric value, and it says how two sentences are closer. So whether two sentences are closer by 50%, 60%, 80%, and so on. Then the next concept is normalization. So what happens is, let's take one example. A lot of people use messenger applications, chatting applications, such as WhatsApp, Telegram, or even SMS application, normal SMS application. So whenever we are typing, we generally use shortcuts. Say, for example, if I have to type the word good, then I'll say just GUD. Okay. So if I have to say then good night, then I may also just say GUD and NIT or NYT, like that. So in normalization, what happens is your various words, they are converted into their standard formats. For example, GUD will be converted to GOOD. Then similarly, G and multiple O's and D, that is good, right? So even that sentence can be converted into its a standard format, good. So you can perform normalization using the functions available in these libraries. Next is transliteration. So we are all aware of translation, where we provide one sentence in a particular language as input, then we convert that sentence into another language. Okay, say for example, I can write a sentence in English saying that India is a beautiful country. Then when I translate it, it will become Bharat ek sundar desh hai. Whereas in case of transliteration is little bit different. So transliteration, we literally write the sentence of one language into another language. For example, if I have to write Bharat ek sundar desh hai, so I can write the same sentence in English using English language script. Then I can write the same in Hindi. I can write the same in Kannada. Okay, so the script will be different, but when you read it, you are actually reading the sentence Bharat ek sundar desh hai. The next is analysis. In phonetic analysis, what we do is we take two letters as input and we check how they sound similar. So what is the score? So if there are two words, say two letters, a letter 1 and letter 2. Okay, so when we perform phonetic analysis on letter 1 and letter 2, it will give us this score saying that these two letters, letter 1 and letter 2, they sound similar 60%, 70%, and so on. The next is syllabification. So we know that we usually have words. So your words can split into syllables. So there's actually lots of steps where we can perform syllabification on words. So basically, one guideline is that we divide the word based on the vowel sounds, and generally the vowels are surrounded by the consonants. So whenever we are dividing the word into two or more syllables, we ensure that at least one vowel is present in each part. Say for example, postpone. So postpone is a single word, but here O is a vowel. So I can divide it as post as one word, post as one syllable, and postpone as another syllable. Okay, so there are two syllables in the word postpone. So one is post, second one is pone, etc. So like that. So whenever you are dividing the word into syllables, you should ensure that there is one vowel in it. So for the next vowel, you put in next syllable. The next is lemmatization. In lemmatization, what happens is we have again words, and we usually put lots of suffixes to the word. Say for example, if there is a word called as running, then here ing is a suffix to the word run. So in lemmatization, what we do is we give running as the input, and the program will remove the suffix and return the word run. Okay, so in lemmatization, we are going to remove the suffixes of a word. So it is challenging for Indian languages because it is not so simple, because we will be having more complex things, especially with respect to the South Indian languages. The next is part of speech tagging. So we know that there are part of speech is the inherent part of grammar. So you can tag each word with POS tag. The next is named entity recognition. So whenever we are dealing with natural language processing, or whenever we are dealing with the text which is written in natural language, we generally deal with many natural entities. Say maybe we may deal with names of persons, names of places, right, and names of various objects, and so on. Then similarly, Concept is again dependency parsing. So it shows the dependency between different words. So these are the few of the concepts which are actually required, which are actually basic for performing natural language processing tasks. Now, if you see on this slide, there are few libraries have been mentioned. One is INLTK, then second one is Indic NLP library, and third one is Stanford NLP. There is also one more library in Python, which is known as Polyglot, which supports lots of languages. Say, I think it supports around 150 languages of the world, including languages. But the problem with Polyglot is it is not yet stable, but you can use it to achieve your tasks. Now, the problem with these libraries is that these libraries support only few of the functions. So they don't support all of these functions. Say, for example, INLTK, it doesn't support all of these functions. Again, Indic NLP library, it doesn't support all of these functions. So it supports only few of these functions. So similarly, Stanford NLP, it supports few of the languages. Okay, so it majorly supports Hindi, but it also supports Tamil and Telugu languages. It doesn't have support for Kannada language. So the problem with these NLP packages for Indian languages is that either they don't support many features or they don't support many languages. Now, let's first check the library called as INLTK. INLTK is the Natural Language Toolkit for Indian languages. It is created by Gaurav Arora. So it aims to provide out-of-the-box support for various NLP tasks that an application developer languages. So in previous slide, you might have seen several basic tasks or various tasks related to NLP. So it's some of those, and it supports native languages and code mixed languages. So we will see what are these code mixed languages. We will visit the URL of this documentation and we'll see. Then INLTK is currently supported only on Linux and Windows 10 with version greater than 3.6. Then there is the next library, that is Indic NLP library. So it has also some features. You can see here the language support. It supports three types of languages basically. One is Indo-Aryan languages, the next is Dravidian languages, then third one is others. So most of the languages spoken in North India, they are classified into Indo-Aryan, and all South Indian languages are classified into Dravidian languages. Then you can also see the next table here. So there are some listed, and there's either a right mark or a cross mark. So depending on the feature, a particular feature support for a particular language. Say, for example, if you see Hindi, all these features are supported. So that is tokenization, normalization, romanization, word segmentation, script information. All these features are supported for Hindi. So similarly for Punjabi, then Bengali, Gujarati, Marathi, Konkani, right? And all of the Dravidian languages support all these features. But if you look at other languages, say for example, tokenization for Urdu. So only tokenization is supported and other functionalities are not supported. Okay. So similarly, some features are supported for some languages, some features are not supported for some languages. Okay. So apart from that, there are other features. Say for example, script conversion, transliteration, translation. So these are also supported, but only for limited number of languages. Say for example, translation is supported for 18 languages, whereas translation is supported for 10 languages. So Indic NLP library is created by Kunchukutan. So the goal of Indic NLP library is to build Python-based libraries for common text processing and natural language processing in Indian languages. Indian languages share a lot of similarity in terms of script, phonology, language syntax, etc. And this library is an attempt to provide general solution to very commonly required tool sets for Indian language text. So of course we will execute few code snippets. And the third one is the Stanza. So it's a Python NLP package for many human languages. So it's a collection of accurate and efficient tools for many human languages in one place. So starting from raw text to syntactic analysis and entity recognition. So Stanza brings state-of-the-art NLP models to languages of your. So native Python implementation is native Python implementation requiring minimal efforts to set up. Then full neural network pipeline for robust text analytics, including tokenization, multi-word token expansion, advertisation, part of speech, and morphological feature tagging, dependency parsing, and named entity recognition. So these are the various NLP tasks supported by Stanza. Then pre-trained neural models supporting 66 languages. Then it supports Hindi, Marathi, Tamil, Telugu, and Urdu in case of Indian context. So apart from that, it supports other languages from around the world. It's a stable and officially maintained Python interface to core NLP. So earlier it was known as standard NLP, but now they have renamed it and it is known as Stanford NLP. So if you want more information, you can URL mentioned in this slide. Then there is also a website called as stanza.run. So we will see how it works later. So in stanza.run, you can give any language text as input and it will NLP tasks on it and it will return the output to you. So, okay. Now coming to the part of installation. Multiple options available. So one is you can install all these packages on your laptop. So you can either install them on Linux platform or you can install them on Windows platform. So if you are using Windows 10 as the operating system, then you can go for Anaconda. Of course, there are other various options available. Then if you don't want to install the softwares on your machine, then there are two options. So one is use REPL site. So repl.it, that's a website where you can install the programs. If you want to test any program using any language, you can do it without installing that software or that language on your machine. Okay, so basically you can use REPL with GitHub. So how you can do it is write a program on your machine, then upload it on GitHub, then open REPL.it website, import GitHub repository into REPL and execute. So when you execute, it may execute successfully, show the results, or it may show the errors. Okay, so REPL is very advanced tool. So after execution, again you can push back the modified code into the GitHub. It is possible. Okay, and it is also possible that you can install Python packages on REPL. So for example, we need to install INLTK, Indic NLP library, and Stanza. So REPL supports installation of few of these packages. Then next is you can also go for Kaggle notebook. Okay, so you know that Kaggle supports basically two languages, Python and R. So create a Kaggle notebook for Python. Okay, then install these packages. Okay, so after installing Anaconda or after opening Kaggle notebook or after opening REPL, so this first step you will be doing, install the required packages. So install the required packages. You need to run these commands which are mentioned here. So INLTK has a dependency So you need to install Torque first. That is 1.7.1. Also depends on the Python version you are using. So depending on the Python version, you may have to install the either lower version of Torque or higher version of Torque. Okay. Next, to install indic-nlp library, you need to run the command pip install indic-nlp library. Then to install Stanza, you just need to say pip install Stanza. So these are the commands we're using to install these packages. So this is about the theory part. So what we'll do now is we'll move to the GitHub repository where some code snippets are stored, and I will start the Anaconda. So those who are interested, they can also go for Kaggle notebook and issue the same which I am issuing here. And if you go to my GitHub repository, there are code snippets. Of course, you can clone them on your machine. We can start executing the programs. So let me start the Anaconda here. Okay. So basically, I'm going to start the notebook. Yeah. So I'll create a new Jupyter notebook here. So I'll also increase the font size for better visibility. Okay. So let me issue the first command, that is pip install inltk. So now note here that whenever you're installing these packages using pip or conda on Jupyter notebook, you need to prefix these with an exclamation mark. So this is the syntax. So I'll say pip install inltk, then I'll say shift enter. So either you can press shift enter or you can click on option here. So it is installing. So it may take few minutes, say 1 or 2 minutes. So alternatively, as I have told you, that you can also go for REPL here. So you can type the URL REPL dot. Right, then you can see here start coding option. So click on it. So if you have GitHub account, then that's better. Login using GitHub. Okay. So then create a new REPL here. So select the language as Python. Then provide the name here. So I'll say FOSSASIA. Okay. Then I'll click on create REPL button. So now you can see here that when you create a REPL, basically your window will be divided into 3 parts. On the left hand side, you will be having files section. Then in the middle part, you can start a program. And on the right hand side, whenever you click on run button, it's going to execute the code here and show the output. Okay. Say let's write some program, a small program here. So hello FOSSASIA. Okay. Then I'll click on run. So you can see here put on the right hand side. Okay. So you need not have to install anything. Just select the appropriate version of a language. So REPL supports almost all languages in the, so when I say languages here, it's the programming language. Okay, so as I have said, you can import the code from GitHub. So you can click on it here. So it's a version control. So if you want, you can create a new Git repo, or you can go for existing Git repo. So since I'm logged in, so it shows all here. Okay, so I'm not going to select anyone because most of these are student projects. But you can select any repo here. So when you select a repo here, all the files related to that particular repository will appear here on this left hand side, and when you click on it, the source code will appear in the middle section. Okay, then next you can also install packages. So if you click on packages and start searching for the packages here, so you can see here, so it is now showing Stanza, the Python NLP library for many human languages, right? So if you click on it, it will start installation. Start the installation of this package. Okay, so in this way you can install the required packages online, configure REPL, and execute the programs. So you need not have to install software on your local machine also. Okay, so this is one way to execute your programs, that is using REPL. So second or next option is use Kaggle notebooks, okay, for Python. So here you can say new notebook. So you need to make some configuration. Say for example, you may have to provide your mobile number, maybe for validation purpose. So then only they will allow you to configure other parameters. Okay, so you can see here Jupyter notebook. So if you want a new library to be installed here, so again the same command which we had used in our previous case, so same thing you can use. So again I'll say here pip install inltk, then shift enter. So it's executing. Again, so it will take some time to download and install the package. So but this is a good starting point here. So once you install, you can start your coding here. Okay, maybe some problem here, that's fine. Okay, so you can see here on my Jupyter notebook, I think this has been successfully installed. So let me check for the success message here. Yes, so it has been successfully installed. So inltk has been successfully. So let me install other packages also. So again I'll say here pip install indic hyphen nlp hyphen library. Okay, then again shift enter. Yes, so now it says requirement already satisfied. So let me install the third package also here. So pip in Stanza and shift enter. So you can use whatever way is convenient to you for the execution of the program. So if you don't have the long-term plan, then you can go for Kaggle notebook or REPL. Yeah. So all three packages are successfully installed now. So we need sample codes. Okay. Fine. It will be in my GitHub repo. Okay, so this is the URL. So if you are interested to copy this URL, so for your visibility, I will post it in the notepad. Okay, fine, some issue, right? So I have put it here in the code cell. So this is the URL. You can copy it. So github.com/gcdeshpande/indicnlp is the URL. So where you can find the code snippets. So let's start with INLTK first. Okay, so first code which we will execute is this one, set language. So this is a script which actually downloads the language models of different Indian languages. So this is a single script actually which downloads the language models for all the languages. So you can see here that when you execute this script, download the language model for Hindi, then Punjabi, Sanskrit, Gujarati, Kannada, Malayalam, then Nepali, Oriya, Marathi, Bengali, Tamil, Urdu, Telugu, and finally the English. Okay, so don't execute this script at once because language models are heavy. So it will take a lot of time to download and install on your machine. So only select those which are required. So next is you can also see here that it supports code mixed languages, right? So it supports 3 code mixed languages. One is English, then second one is Tanglish, and third one is Manglish. Okay, so that means the language model for Hindi and English for English, then for Tanglish it is Tamil and English, for Manglish it is Malayalam and English. So language model where you can say that mixed language words are there. So generally it happens that our higher education is generally in English. So we tend to a lot of English language words in our daily conversation, even though we are conversing or even though we are speaking in our native language or in our mother tongue. Okay, so whenever I'm speaking a Hindi language or Tamil language or Malayalam, so we generally use many English language words. Okay, so if you want to perform NLP on such a text, then you need to download appropriate code mixed language model. Okay, so don't execute this code. There is one more, that is set language Hindi. Okay, so this is code which you can actually execute. So there is a file called as setlanguagehindi.py file. So click on it and copy these two and come back to your Jupyter notebook here. Paste it and say shift enter. So again, it will take some time because it is downloading the Hindi language model. Okay, so if I want to perform NLP on Hindi, this is the first step. Okay, so on the first line, you need to import required packages. So from inltk.inltk import setup first, then to the setup pass the language code as the parameter. So hi is the language code parameter, language code for Hindi language. So similarly, pa will be the language code parameter. Okay, so downloading says this might take some time depending on your internet connection. Okay, and note here that you need to download these language models for the first time. Once you download it, you need not have to download again. Okay, yes, done. So similarly, if you want to download the language model for Kannada, then you need to say setup and because K is the code for Kannada language. Okay, so once your language model is downloaded and installed, then you can start doing other tasks. So first task we will do is tokenize. Okay, so the first line is again importing the appropriate modules. So here I'm importing tokenize module. Then next, define the text you want to text on which you want to perform NLP. Okay, so create a variable and store the text. Then use the function tokenize. So here tokenize function is taking two parameters. First one is the Hindi text and second one is the language code. Okay, so when I say shift enter here, so you can see here it has tokenized. Okay, tokenize the paragraph into words. So similarly, you can do it for any. Okay, say for example, I'll say here Kannada articles. So I'm just searching for random Kannada article so that I can get one paragraph of text here for our processing. Okay, so I'll okay. So I'll paste it here. Okay. Then here I'll change the language code. Okay, so let me confirm the language code. Okay, so for KN, so I made a mistake in the previous step, so I may have to execute that step again here. So I'll say KN, then shift enter. Let me wait for done message. Yes, done. So it's the same code which we had executed for Hindi paragraph. So instead of Hindi, I am now having Kannada text. Okay, so I'll say shift enter. Yeah, so you can see here. Okay, so it has separate. Okay, but I see some problem here. It was very much clear with respect to Hindi, but output is not so clear, or it is not accurate with respect to Kannada language. Okay, maybe the script used to write the Kannada text is creating a problem here. So it is not exactly tokenizing the words, it is sometimes tokenizing characters. Okay, maybe those characters are represented as words internally. That may be one possibility, but this output is not so accurate. So you can also check for your mother tongue or your language. So you just need to do these things. So import tokenize module, then create a string where you can store the paragraph of text in your mother tongue, then use the tokenize method and pass the string as parameter and the language code as parameter and execute. Okay, so we'll go to the next code snippet here. So after this, we'll go to identify. Okay. So here you can see 2 lines. So in the first line, I am importing the appropriate module, that is identify language module. Then to this function, I'm passing a string as a parameter. So this string is nothing but a Hindi sentence here. So I think again it is down language model, maybe. Yeah, that's fine. Okay. So what does here is going to return the language of input text. So here I'm expecting Hindi's model is taking bit time. So you need internet connection to download these models. Okay, fine. So we will not wait for it. So it's not that important. It will definitely return the language code. Okay, so after this, we can go for similar sentence.py. So here what happens is, again you need to download the required module. So here the required module is get underscore similar underscore sentences. So there is a method get underscore similar underscore sentences. It's going to take 3 parameters. So first one is the sentence. So it can be in English. So if it is in Hindi, you need to specify it as Hindi in third parameter. If it is Kannada, then you need to specify KN in third parameter. Then also how many sentences you want to generate, how many similar sentences you want to generate, that you need to specify. So here I want to generate 5 sentences which are similar to Bharat ek adbhut desh hai. Okay, I think it is better wait for the language model to download, maybe 1 or 2 minutes. Okay, now it says done. Okay, find some problem. Maybe. Okay. Okay, fine. So if it is giving a problem, we'll not invest much time on it. Okay, so in this case, what it does is now sentence Bharat ek adbhut desh hai, so it is going to generate 5 similar sentences. So what it is going to do is it is going to replace certain words. Say for example, it may replace the word adbhut with other words. Say for example, it may say Bharat ek mahan desh hai, Bharat ek sundar desh hai, like that. So it may replace some words in the input sentence and generate a new sentence. Okay, like that it can generate 5 similar sentences. Okay, then similarly sentence similarity. So in sentence similarity, what happens here is, again, so in the first sentence you are importing the get sentence similarity module and you are using get sentence similarity function in the second line. So you can see here some sentences have been mentioned as input. So there are 2 sentences which are input. So first sentence is Bharat ek adbhut desh hai. That is this sentence. Then second sentence is ऋषि मुनियों और अवतारों में भारत एक रहस्यमय देश है. So there are basically 2 sentences. So first parameter is the first sentence, second parameter is the second sentence, and third one is the language code. Some error I am getting. Fine. Okay. So in this case, what happens is it's going to return a numeric value, okay, which states how close the first sentence is to the second sentence. It may say that the first sentence is 50% similar to the second sentence, or the first sentence is 60% similar to the second sentence, and so on. Then next example which we can consider is text completion. Okay. Now to execute this code block, you need to import again the setup module. Okay. So basically it is to download the language model. So here it is written as Bengali, but you write it here as Hindi. Then next, you need to use a method called as predict underscore next underscore words. Okay, so it takes first parameter, that's the sentence. So here I have mentioned one sentence in the language, that is Bharat ek adbhut desh hai. Okay, then I have mentioned 10 words, that is I'm asking this predict next words method to generate next 10 words which are related to the sentence. Okay, then second one is then this is the language code, that is Hindi. Then this is the value which you need to specify between 0 and 1. Okay, so when you specify the higher value, that is when it is more closer to 1, you get more related words. If you specify low value, say for example 0.1 or 0.2, you start getting more unrelated words. So to get more related words, this value should be high, but you should specify it between 0 and 1. Okay, so next one is remove foreign language. Now in this code example, so you can see here in the first line, we are importing the remove underscore foreign underscore languages module. Then we are using the function here, that is remove foreign languages. So to this remove foreign languages method, we are passing a string as a parameter. Now if you look at this string, there are words from many languages. Say for example, I have some words from Hindi language, then I have some other language, and the second parameter is the language code. So what it is going to do now is it's going to keep only Hindi words and remove all foreign words. So this helps in reprocessing step where you want to remove the unwanted words, right? So this is a very useful feature. Okay, because if you perform pure NLP on a particular language, right, and if your dataset consists of you can say text to speech content, not text to speech content, it is the other way. So that is speech to text content. So in that case, we usually have words from other languages. So in that, if you want to remove the words from other languages, then you can use this function, that is remove underscore foreign underscore languages. Okay, not this, embedding vectors. Okay, yeah. So now embedding vectors, as I have told you, it gives you the numerical representation of words or textual information. Okay, say for example, now I have a sentence Bharat ek adbhut desh hai. So it's going to give me the vector version of this sentence. Okay, and it's also going to print the shape. So when I say to print the dimension, usually these dimensions are very huge, say 400 or 800, like that. So again, the first step is to import the get embedding vectors module, right? To that, pass the parameters. So again, I am passing Hindi text as parameters. Okay. Then print the shape. So when I print the shape, it's going to print the dimension. So this example, which basically uses multiple modules and multiple methods. So basically here we are tokenizing the sentence into words, and then we are generating the vector information of the text and finding the length of the vectors and size of the vector. And in second example, yeah, so in second example, again, it's a small application where it predicts next n words and get similar sentences. Okay, so to that we need to import the respective modules. So we need to import setup module, then predict next words module, then get similar sentences module. So here the Tamil language model will be downloaded. Then here n is equal to 5 means predict next 5 words, or you can also use tokens. Then here you can try to predict next 2 words. Okay. So this is about Indic NLP package. So you can visit the INLTK documentation to learn more about INLTK package. Of course, most of these examples are from standard documentation, and you can also see the sample output there. The next package which we are going to discuss is Indic NLP. So yeah. Okay. When you use Indic NLP library, you need to import the appropriate module. So in this case, you need to import indic underscore tokenize module from indic nlp.tokenize package. So define a string here. So here defining the Hindi language string, then print the input string, then print the tokens. Okay, so when you are printing the tokens, you need to again use the function called as trivial tokenize, pass the index string as the parameter. So you can see here that it has tokenized them into words. The next example we will see is transliterate. So as I have told you, it's going to just literally represent the same text in other language. So when you read it, it will be that language text. Okay, so we will see the output of this snippet. So again, the first step is to import the appropriate modules here. So here you need to import unique indic transliterator module, then define the input text. So here the input text is written in Hindi. So the input text reads as आज मौसम अच्छा है, सूरज उज्जवल है और बारिश के कोई संकेत नहीं है, इसलिए हम खेल सकते हैं. So this is the sentence in Hindi language. Now what I'm trying to do now is I'm trying to transliterate it. Okay, so to transliterate it, I'm going to use a function called as transliterate from Unicode Indic Transliterator package. So pass the first parameter as the input text. So this will be in language. Then second one is the source language, and third one is the destination language. Now note here that I'm not translating, so I'm just transliterating. So that means I'm representing the same two different scripts. When you read it, the meaning will be the same. Okay, when you read it, it is the same sentence, but the script will be different. Okay, so you can see here it's a Telugu text basically. Okay, so when I read it in Telugu, it will still be a Hindi text. Okay, so similarly I can specify other language also here. Okay, say Kannada. So you can see here only the script is different, but the sentence is in Hindi language only. Okay, it says आज मौसम अच्छा है, सूरज. Okay, so similarly you can specify other language also, maybe Punjabi. Okay, you can specify any language, but when you read it, you are reading a Hindi sentence. Okay, so this is about transliteration. The next is sentence tokenize. So we have seen word tokenizer. So now this is sentence tokenizer. So it is not going to split the paragraph into words. It is going to split the paragraph into sentences. Okay, so here you need to import sentence underscore tokenize module. So specify index string here, right? So it's a paragraph which is written in Hindi language. Okay, then specify the sentence split method. So you need to make use of sentence split method. So by default tokenizer, what it's going to do is it's going to tokenize into words. Okay, but if you want this specific requirement, when you want to, or whenever there's a need to tokenize into sentences, okay, you need to use sentence split method. Okay, so that's a tokenizer. So after this, we'll see this interesting feature called as detokenization. So you can see here what this detokenization has done. It has removed all the extra spaces before and after the words. Okay, say for example, you can see here there's an extra space here before the first word Suno. Then there is an extra space after the last word. Sentence delimiting character. Okay, in Hindi, that is the vertical bar. And also there is an extra space before dot and after, right, and before comma. So what this detokenization has done is it has removed the extra spaces. Okay, so it's like a trim function. It removes the extra spaces before and after the string. And then we'll go for phonetic properties. So in phonetic properties, what you need to do is you need to import the appropriate packages again using from indicanlp.langinfo space import star. Right now, here I have defined a variable called as C, and in which a character has, which is a Hindi character ka, right? A single letter has been stored, and second parameter is the lang, so which defines the language, that's the Hindi. Now I'm checking what this C is, whether is it a vowel, is it a consonant, is it velar, is it palatal, is it aspirated, is it nasal, right? So now it says that it's a consonant, and it says that several other parameters are false. Okay, it says that it's a consonant, it's a velar, and it's also unvoiced. Okay, but it's not nasal. Okay, so if you change this character, then you will get errant output. Okay, so basically there are functions available which are built in, and you can use them directly. So you can print phonetic properties. Then you can also check for script conversion. Okay, so script conversion is again transliteration. Okay, it is not a translation. Okay, so again you need to import the same unique transliterator module, define the input text, right? So it can be in any language, right? So at present it's in Hindi language. Now I want to convert that text into Kannada script. Okay, so text will remain the same, language will remain the same. Only thing is script will change. Okay, so it is same as transliteration. So you can specify here any other language, say BN. So now the same text which was mentioned in Hindi language is converted into Bengali. So this is about script conversion. So script conversion is same as transliteration. I think we have checked this one. Yes. Okay, we have seen this example. The previous example was related to consonant. Now the example is related to vowel. Okay, so let me execute this code. It's a bit long code. It's a code example. So it basically uses several concepts and it discusses or stresses the importance of pre-processing for natural language processing in order to get the accurate results. So it has been written using Indic NLP package. So basically here we are performing n-gram analysis. So first we'll copy this code, we'll execute the code and we'll see the output. Then we'll come back to the source code. We'll discuss what it does exactly. Okay, so when we execute this code, you can see here that thing is it is tokenizing, right? So it is taking a particular paragraph or a sentence in Hindi language as input and it is tokenizing them into words. Now when you see here, right, this can also be represented as a list. Okay, and the values in the list have been separated using comma operator. So we have elements suno, then comma, then kuch, then awaz, right, and so on. So basically if you look at the list, we have text, we have textual information which is but words, and we also have punctuation marks as the elements of a list. Okay, so this is a problem in NLP. Whenever you tokenize, it tokenizes everything. So the next step is to pre-process this information. Okay, so you need to remove these unnecessary punctuation marks. Okay, for example, you don't need this question mark for text processing. You don't need this sentence marker, right? So for most of the other languages, it is dot. Okay, for Hindi, vertical bar, right? Again, you don't need this comma. Okay, so these are unnecessary things, and these things should be removed. Okay, and these things will be removed in pre-processing step. Okay, and note here that also count the number of tokens here. So before processing, okay, so before pre-processing, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I had 10 elements to be processed. But after pre-processing, there are only 7 terms remaining. Of course, I also need to remove this comma. Only 6 terms will remain after pre-processing. Okay. So just imagine in just one small sentence, I'm able to significantly reduce the number of tokens from 10 to 6. Then just imagine in case of a huge text, or whenever you want to perform NLP on entire textbook which has millions of words. In that case, how much tokens you will be able to remove, right? How many tokens you will be able to remove, right? So the goal of pre-processing is to remove all unwanted words, all unwanted symbols. Okay, how to remove the stop words. Okay, like for example, hey is a stop word which marks the basically it is used in sentences, actually not at all required, right? So there are some punctuation marks which needs to be removed. If there are some numbers, some digits, those needs to be removed. Okay, removing all this, you also need to remove some unwanted words which are not related to the concept. Okay, say for example, if you are say for example there is a paragraph which describes about machine learning. Okay, then in pre-processing step you need to remove all those terms which are not related to machine learning. So in this way you will be able to reduce the number of tokens to be processed significantly, and it usually adds to the performance of the application. Okay, so pre-processing is very, very important. The next is n-gram analysis. So in n-gram analysis, what we do is we count the frequency of co-occurring words. Okay, and when we say just a gram, then we say we just count the frequency of occurrence of that particular word. Say for example, in the above sentence, okay, so appearing just for one time, again kuch one time, awaz one time. So basically all tokens are appearing only one time. Okay, if it is a large paragraph, then you will be able to see the change in this count. Okay, then I want to print here top 10 grams. Basically I want to get those words which have high frequency, and I want them in descending order. Okay, so basically I want to get top 10 words which are appearing in the paragraph maximum number of times. Okay, the next is word frequency of bigrams. So bigrams is frequency of two words occurring together. Okay, say for example suno and comma, how many times they are occurring, right? Then comma and kuch, then kuch and awaz, right? Then awaz and so on. Then similarly you can also perform trigrams. That is frequency of three words occurring together. Okay, so in this way you can perform n-gram analysis. So that is frequency of n words occurring together. And here many concepts are there. For example, you can use the built-in functions, and you can just prepare a sliding window and go on moving that sliding window over the paragraph and check the frequency. Second option is don't use these inbuilt functions, don't use this sliding window, just perform permutation and combination on all words. Okay, so many times this second approach is more preferable over the first one. So let us look at the source code here. Yeah, so in the first line, import index tokenized package and the counter module from collections, right? Then define the input string, then define the stop words here. Okay, so many NLP packages, they provide stop words list automatically, and you will also get this stop words list on the internet. You can directly download it and define it in a set or a list. Okay, so two kinds of stop words. One is grammatical and second one is contextual. Okay, So you will get all grammatical keywords, but contextual stop words you need to form. Okay. So in this part of the code, we are just printing the words, and next in this part of the code, we are removing all the stop words. Okay. So note here that in my doc, I'm storing all the elements which are not in stop. Okay. So you can see the code here. It says ELE for ELE in X if ELE not in stop words. So I want to print the words which are not part of stop words. Then I am just printing the number of tokens after pre-processing. Then this is the part of the code, right, where I am printing word frequency of words. Just I am printing word frequency. I am printing top 10 words. That's just grams, and here top 10 bigrams. Okay. So you can continue this code depending on your requirement. Okay. So after this point, that is once you the word frequency, okay, you can use the same code and you can extend the same code to extract the top sentences. Okay. So when you extract the top sentences, so how are you going to determine top sentences? You need to pick the first word, that is the word which has highest word frequency, and you are going to see in which sentence it is there. So based on that, you are going to compute the sentence score, right? So every sentence will get a sentence score based on word frequency, and again you are going to sort the sentences based on their sentence score in descending order, and you're going to get the top 10 sentences or top n sentences. So when you extract these top n sentences, you are actually generating the summary of the document. Okay. So this technique is known as extractive summarization technique. Okay. So it is basically based on statistical techniques. It may not give you the accurate results, but it is relatively faster. Okay, so next package is Stanza. So you can see here, you can actually use a website called as stanza.run, okay, where you specify a paragraph, right? You can specify any paragraph in any language, right? Of course, it should be supported by this package, right? And you can perform the various NLP tasks. So those NLP tasks are parts of speech, then named entities, then lemmas, then dependency parse. Okay, so you can see here the list. These are the languages supported here, not only English. So you can see here it supports lots of other languages. Okay, it supports Dutch, French, Finnish, Greek. Okay, in case of Indian languages, it supports Hindi, right? It supports Irish, Indonesian, Japanese, Korean, right? It also supports Marathi, then Sanskrit, Tamil, Telugu, and Urdu. So these are the languages supported by STAR. So let me check for some Hindi text. Okay, so there is a Hindi paragraph here. So I will copy this paragraph. Okay, some problem with. Let me select some other article. Okay, so I'll copy this paragraph and I'll paste it. Okay, so finally I'm able to copy one paragraph. Let me search for Hindi language here. Then I'll click on submit button. Okay, so you can see here it has generated a lot of content here. Lot of NLP has been performed on text. So the first one is part of speech. So it shows which are the nouns, which are the pronouns, which are the symbols, okay, which are the prepositions, right? Then it is also performing lemmatization here. So lemmatization you can see here. For example, here dosto is a word, but it is not in its root form. It is not in its original form. Okay, so the root form of dosto is dost, right? Similarly, ako, right? It's not the root form here, so it has performed the lemmatization. So it has removed all the suffixes here. So and it has returned up. Okay. Similarly, there are other things which are done with respect to lemmatization. For example, padiye. So lemmatization or lemma of padiye will be pad. So the root word of the term padiye. Okay. The next is named entity recognition. So it says that NER feature is not available for this language. Then it shows the universal dependencies. So how these words are dependent. So it shows the dependence with the help of arrow. Okay. Similarly, you can select the other language and put the text here and check. But not many Indian languages are supported with respect to stanza. So similarly, there is another library, Polyglot. So it is also multilingual NLP package. Okay, so you can visit this site polyglot.readthedocs.com